So guys, now let's go ahead and proceed with the discussion with respect to reciprocal rank fusion and hybrid search. As I said, whenever we try to query or whenever user queries from this particular vector database, which supports both vector search and keyword search, which is a combination of semantic search and exact search. Over here, first of all, to get the keyword search, we have to convert this into sparse vectors, and the sparse vectors will be probably searching from this particular vector database, and we get top k results. Similarly, with the help of dense vectors, we also get a vector search, and here we are going to get a result 2, that is top k results. Okay. Now, combining both of them, we have to probably consider a response, right? How to probably get the final response? That is what I'm actually going to discuss now. Okay. So here, with the help of reciprocal rank fusion and hybrid search, we will be considering two important things. Okay. Let's say this is my vector database. Okay. And from this vector database, you know that whenever user queries, so based on this queries, let's say if this is my dense vectors, first we're going to do the vector search and we're going to get the top k results, right? So when I say top k results, let's say that this is my first document, right? And this can be my second document, right? And this can be my third document. Like this, I will be getting a lot of documents. Similarly over here, based on my sparse matrix search, that is the keyword search, that is nothing but keyword search, I'm actually going to get my top k documents. So here also I will go ahead and draw this. So let's say here I'm going to get some other sentences, okay? And the ordering will be different, right? So here, let's say this is the order that I've actually got. I got document 1, 2, 3, 4, 5. Let's say the 5 documents I've actually got. And here also we have got some other documents. So let's say some other documents. But here the numbering is different. Let's say the numbering is like 4, 3, 2, 5, 1, okay? The numbering is different. This is my result 1 top k documents, and this is my result 2 top k documents, okay? Now considering this, see, here I've got in this ordering, that is 1, 2, 3, 4, 5 sentence. That is that I got in my top k like document 1, document 2, document 3, document 4, document 5. Similarly over here, document 4, document 3, document 2, document 5, document 1. This is the ranks that we have specifically got. Now how to calculate the final score? Because here this is based on my semantic search, this is based on my keyword search. When I say semantic search, that is basically based on cosine similarity, okay? So we are trying to find out the similar vectors and then we are trying to find out our final score. So in order to calculate the final score, the formula is very simple. Here we'll write summation of 1 divided by a constant plus the rank of documents, okay? Now this particular constant, that is C, it depends on various database. It depends on various databases, okay? Now with respect to various databases, this may range between 1 to 60, okay? And this is a constant base, okay? In various databases, they'll set this value to 10, 20, you know, and some of the databases I've seen the value to 60, okay? So since this is a constant, we're just not going to focus much into this. Instead, I will just take up this formula now, summation of I is equal to 1 divided by rank of D, okay? Since this is a constant, for calculating in every, the rank of every documents will probably give you the same answer with respect to that particular constant, like same impact it may be creating, okay? Now, how do we compute the rank, right? So for this particular sentence, you'll be seeing 1 divided by rank of D. So if I go ahead and compute this, this is nothing but 1 by 1, okay? This is nothing but 1 by 2, because this is rank 2, right? This is rank 3, so I'll get 1 by 3. This is nothing but 0.33. Then here I have 0.25. This is my fifth document. Let's say the rank is 5. I'm actually going to get 0.2, okay? Similarly, in this particular case, this is my document 4, right? And if I try to compute this particular rank, okay, it will be again 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. So that basically means the document of D4 is basically getting a rank of 1 in this keyword search. Here D4 is basically getting 0.25. Okay. Now when we try to combine the final score, okay, this is important. See this. So if I finally go ahead and take up document 1, so if this is my document 1, and if I try to calculate the overall rank, then what we have to do? We have to do the summation. So let's see, document 1 is giving 1 over here and 1 by 5. So I will just go ahead and write 1 plus 0.2. So this will be 1.2, right? Similarly, if I go ahead and calculate for document 2, right? So document 2 over here gives 0.5, right? So here I'm actually going to get 0.5 plus the document 2 over here is 1 by 3, that is nothing but 0.33, right? So here you can see I'm actually going to get 0.83. So this is my score that I'm actually going to get. And obviously this score is better than this score, so I will be getting document 1 based on my 50% probability or 50% focus on keyword search, right? And 50% on semantic search, right? If you change the weightage, right? If you change the weightage, then you'll be able to see that some values may also change. Similarly, you have this document 3. In the case of document 3, you'll be able to see that here I have 0.33. So let's calculate this 0.33 plus document 3 is nothing but 0.5. Again, here I'm going to get the same value, see 0.83. Now both these ranks are same, right? So if I want to retrieve the top k result, obviously this will be shown first. And then based on this too, right, where the focus is more, whether it is on keyword search or semantic search. Let's say if I say 70% focus is there on the keyword search, then over here you can see 0.5 values higher than 0.3. So it is just going to give you the display the document 3 in the second rank, right? So this way the weightage can also be provided in keyword search and semantic search, okay? And similarly, we go ahead and calculate each and every documents. So finally, you can see that here we can combine result 2 and result 1 top k elements, and then we can use this reciprocal rank fusion and hybrid search by assigning ranks, and we will be able to calculate a score, which will be finally given as a response. And here we can also assign weightage, and this can be combined with a prompt template, and we can summarize with our LLM model, right? So this gives an idea about the entire hybrid search, right? Now in this section, the next section, what we're going to do is that we're going to also see a practical example of how an hybrid search is basically done. But before that, if you know about one more search, right, that is based on graph knowledge search, okay, graph knowledge search. So in this graph knowledge search, I hope you may have heard about GraphDB, one of the most popular open source GraphDB is Neo4j. Okay. Now, if we are specifically using GraphDB to store the vectors, let's say if this is my database and this database is nothing but it is my GraphDB. In the case of GraphDB, I will be having like this nodes which will be connected with relationships, right? So this can be my node 1, this can be my node 2, and it will be connected with relationships. And we can, whenever a user tries to query in this, there are 3 types of queries that happens. One is keyword search, which can also be called as semantic search. This can be also called as synthetic search, or it can be also called as exact search. Then along with this, it also supports semantic search, right? And finally, you'll be also able to see that it supports keyword search, semantic search. Along with this, one more search is there that is called as graph knowledge search. Graph knowledge search. So it supports all these techniques, which is quite amazing. Just imagine, hybrid search just supports this 2 type, but now with this help of graph knowledge search, we will still be able to create a very good efficient RAG application, right? With the help of GraphDB. And this we will be seeing about GraphDB in the upcoming videos, in the upcoming sections. But let's go ahead and see some practical example for hybrid search. Hello guys, so we are going to continue the discussion with respect to the hybrid search, and here now we are going to implement a complete amazing project with the help of hybrid search using LangChain. Now for this we will be using a vector database which is called as Pinecone. Now Pinecone vector database provides you this both, right? Like you will be able to do the keyword search, you'll be able to do the semantic search. So let's go ahead and first of all we'll set up our account, and then with the help of code we will try to write each and everything, and we'll try to probably go ahead and create our the vector database itself. So first of all just go ahead and sign up over here. It is completely for free. First two to three instances you can create completely for free. So I've already signed up, so I will go ahead and log in. You have to just go to pinecone.io. Now once you go inside this, you'll be able to see that I've already created one Pinecone hybrid search, right? And if you go inside this, there are some kind of data that is already available over here, right? But as usual, we will not probably work with this, but instead we'll go ahead and create our new index, okay? But since I really want to do everything from with the help of code, so we will try to create the instance even with the help of code. So first of all, that you actually require is your API key, okay? So just click on API key, just make sure that this will be the default API key that will be provided over here, and you can also rotate the key values, like you can probably go ahead and change it if somebody probably sees it, right? So here I will copy this particular key value, and then I will start my coding over here, right? So here I will be creating my instance, everything as such, okay? Now just quickly to go ahead with, I have some good requirement.txt here. You'll be able to see so many different libraries, but for LangChain obviously you require a lot of libraries, but if I probably talk about with respect to Pinecone, I will be installing some of the libraries over here. So let me quickly go ahead and just paste it over here. So I'll be installing Pinecone client, Pinecone text, and Pinecone notebooks, okay? So these are the initial libraries that we will be requiring. So I've already done the installation since I don't want to make my video very long. So here you'll be able to see a green tick, and already the entire the installation has basically happened. Then I will go ahead and write my API underscore key. This API underscore key will basically be replaced with the values over here, right? So I'm just going to create this particular variable. You can also create an environment variable if you want, okay? Perfect. Now, since we are using LangChain, so please make sure that we will go ahead and import this from LangChain underscore community dot retrievers. I'm going to import a library which is nothing but Pinecone hybrid search retriever. Now this class is responsible in doing both the semantic search and synthetic search, right? So keyword search, like it has the combination of both the sparse matrix and dense vector search. And for that we have to create a retriever, and this is the class that we're going to use. So let's go ahead and execute this. And after executing this, the next thing will be that we need to make sure that we first of all create our index in our Pinecone, right? Without this, it will be of no use. So here, quickly, what I will do, I will just go ahead and import OS. Since I've already imported Pinecone, so I will go ahead and write from Pinecone import Pinecone, serverless spec, okay? And then I will just go ahead and create my index name. My index name over here, I will say, hey, this will be my hybrid search example. And please make sure that you give all this in a smaller letter, otherwise you'll be getting an error. So I'll say, hey, hybrid search LangChain Pinecone, okay? So this will basically be my index name, okay? Once I probably create the index name, we have to initialize the Pinecone client, okay? Then for initializing the Pinecone client, I'll write PC is equal to Pinecone, and we will initialize with this API key that I've actually created, right? So over here is my API key. You can create your own API keys, no need to use mine, okay? Because as soon as I upload this video, this will get deleted, okay? Or I'll rotate the key. Then we will go ahead and create the index. And here I'm going to basically write if index underscore name is not in PC dot list indexes, right? We're listing all the indexes. If this particular name is not there, then only we should probably go ahead and create this. So I'll write PC dot create index, create underscore index, and here I'm going to give my name is equal to index underscore name, whatever index underscore name we have specifically taken. Whenever we try to create an index, we also have to give our dimension. Okay, so here like what will be the vector dimension? So here I'm going to use the vector dimension is equal to 384. The reason is very simple. The reason why I'm using, and this is nothing but this is my dimension of dense model, okay? Dense vector. The reason is very simple why I'm using 384, because the embedding technique that I'm actually going to use is the Hugging Face embedding technique, which is nothing but dense transformer that by default converts any text into 384 dimension. So that is the reason why I'm creating this particular index with this dimension, okay? Along with this, the next thing that I'm going to use is metric. So for my metric here, I will be using a dot product. So this is all information you specifically get when you are creating an index. Let's say if I go to over here, create my index. So it's asked you for the dimension, right over here by default. You can see metrics also asks you whether you want to go with dot product, cosine, and all. Right? You can select any of this particular metric. So that is the reason why I am giving a metric over here, right? So I'm saying, hey, just go ahead and do it the dot product, okay? And this dot product specifically, I am going to do it for sparse values, right? Sparse value supported only for dot product, because we're creating this hybrid search for both of them, right? And then finally you have the spec is equal to, for this particular spec, I will be using serverless spec, and I have to probably give my cloud information like AWS it is and which region. This also you'll be able to get inside that particular. So I will just go ahead and write US East 1. Okay. So if you remember, just now we saw this particular index also. So if I go ahead and see this, here you have the serverless. Okay, all the information is over here. Let's say, and here you can select this US East 1 and all. This is locked, so that's the reason I've written this. I've selected AWS. If you go ahead with Google, you have to go ahead and write this, right? So this is just a starter plan to go ahead with. So I'm going to use this free one. Okay. Perfect. So let's see whether this gets executed. So here I think everything looks good enough. I have my index name, pc.create, and here I'll just write comma. Okay. Okay. Just a second. I will just update this entire thing. Okay, perfect. Now this looks good, exactly, right? I have all the details. Now let's go ahead and create this index. So here you'll be able to see it'll take some amount of time to create this index, but this is going to get created directly inside our vector database. Now if I go ahead and click on index, if I reload this, I think it should get created. Okay, so here is my hybrid search LangChain Pinecone, and right now the dimension is 384. I don't have anything. The metric is dot product. The reason of using metric is that I really want to support both. That is for my sparse metrics and my vector index, right? So here I have my all details. Now let's go ahead and further do the more coding over here. I've already created my API. Now let's click on my index and I'll say, hey, pc.index. Okay, pc.index, and here I'm just going to give my index underscore name. So let's go ahead and see this index over here. So this is my Pinecone index at this particular memory location, and obviously my index name that you'll be able to see over here. That index name, based on this index name, I'm trying to take out that details. Okay. Now First thing first, you know that, right? Our entire project is a combination of two different. One, I'll try to create a vector embedding, and the other one, I'll try to create a sparse matrix. Okay, and that is what hybrid search basically tells you to do it, right? So first of all, what I will do, I will go ahead and import OS, and here I will write from .env import load underscore .env. Okay, and we will be loading all our environment variables, right? Now, just to give you an idea about the environment variables, since I'm going to use an open source embedding technique from LangChain, from Hugging Face itself, so I will go ahead and import from LangChain underscore Hugging Face. Okay, I'm going to import my Hugging Face embeddings. Okay, and here one of the embedding technique that we regularly use, and with respect to the same dimensions, I'll be using this Hugging Face embeddings, and here I'm going to use my model underscore name is equal to all dash mini. This is a sentence transformer lm L6 and version v2. Okay, so this will specifically be my embeddings. So here, let's go ahead and see the embeddings over here quickly. Yeah, so my embedding is getting downloaded, and this will probably take some amount of time. And here you can see the word embedding is nothing but 384. Please note, before doing this, if you directly execute it, it will not work, because the reason it is working, because I have already imported os.environment. You have to create this Hugging Face token, right? HF underscore token, and this is already present in my environment variable. So I will go ahead and write os.getEnv is nothing but HF underscore token. You have to execute along with this. If you do not have the HF underscore token, this will not get loaded. Okay, so please make sure that you have this particular code. Perfect. So this was it. Now let's go ahead and execute it once again, and now I will be having my entire Hugging Face embedding. Now this embedding technique is used to create your dense vectors. If I go ahead and proceed further, for my sparse matrix, I'm going to use one more, that is pinecone dot pinecone underscore text for my sparse. There is an encoder which is called as BM25 encoder. Now this particular encoder uses the TF-IDF by default. Okay, TF-IDF techniques. So here I'm going to write PF25 underscore encoder. Okay, is equal to nothing but I will just go ahead and initialize this encoder, and I will say, hey, use the default one, which is nothing but TF-IDF. Okay, and this basically becomes my BF25 encoder. Okay, and this is responsible in doing the sparse matrix conversion for any queries or for any text. Okay. Now, I hope you are very much clear with all these things now, and you are able to probably do all these amazing stuffs and all, right? Now, I will try to create some sentences. Let's go ahead and create some sentences, and the sentences will be a list, okay? And just to show you one example, I will just be creating some sentences over here with respect to this particular list. I will have these three sentences, let's say. In 2023, I visited Paris. In 2022, I visited New York. And in 2021, I visited Orleans, okay? Now, I will take all this information, and quickly, I will go ahead and write BM25 underscore encoder dot. We're just going to fit on these entire sentences, okay? So once we do this, in short, we're just applying TF-IDF values on these sentences, okay? Perfect. So once I do this fit, along with this, what I will do, I will store the values to a JSON file. Okay. So here I'll just go ahead and write pf bm25 encoder dot dump. Okay. Now I'm going to basically dump my bm25 underscore values in the form of dot JSON. Okay. And here you'll be able to see that I'm actually dumping this entire information. You can also go ahead and load this just to make sure that you have that entire dump. Okay. And you can also load it. So has no attribute dumpy. Okay, it was dump. No worries. Okay. So now here you can see that I have my encoder, and this is specifically for sparse matrix. Okay. Now one more thing that you will be able to see over here is that once I do this particular sparse matrix dump, so I've actually created a sparse matrix for this, right? Now let's go ahead and create my retriever, and this retriever will be important because with the help of this specific retriever only, I will have the combination of both the embedding techniques and obviously the sparse embedding techniques, right? So for that, I will go ahead and create this pinecone hybrid search retriever, and here I'm going to use my embeddings is equal to whatever embedding technique I've used, that is nothing but Hugging Face embeddings, and then my sparse encoder, which will be assigned to my BM25 encoder, and I have to also specify my index, right? So this will basically be my index. Now once I execute this, this is my retriever. Now with the help of this particular retriever, it supports both embedding, the vector dense embedding technique, and along with that the sparse matrix. Okay, so this is my retriever. So I'll just go ahead and display my retriever. Okay, so this is my retriever, and this is the entire information that you'll be able to see, right? So finally, let's do one thing. Let's quickly go ahead and add all the text that I want, right? So I will say, hey, we will go ahead and add the text, and the text that we're going to add is all my sentences inside my index, right? So what are my sentences? Here you go. I'll copy this, and I will paste it over here. Okay. So let's go ahead and execute this. Now you'll be able to see that it will get inserted inside that particular index, right? The index, the pinecone index that we have created. Next time, we can probably retrieve any results. First of all, let's see whether it has got inserted or not. So if I go over here, here you can see it's loading, and all these three sentences are now available, and this is all 384 dimensions, right? So this one in 2021 I visited Context, Orleans, in 2023 I visited New York, Paris, and all, right? Now let's go ahead and ask some questions, and this time it is going to use a combination of both, right? Your vector dense search and the other search. So here I'll say, with what city did I visit last? Okay. So here you'll be able to see visit last. So here you can see, in 2021, I visited New Orleans, then New York, then visited Paris. All this page content is basically able to come over here. It is used both because this entire hybrid search retriever is using both embeddings and sparse matrix. Okay. If I say recent, so in 2021, all this information is basically coming up. Okay. Which city did I visit first? Okay. So here you can see in 2021, I visited New York. So all the information are basically you're able to see it over here. But internally, it is taking a combination of both hybrid search, and this is what is an amazing example, which you can also go ahead and do it. Okay. So I hope you like this particular video. I will see you all in the next video. Thank you. Take care. Bye. Hello guys, so in this video and in the upcoming series of video, we are going to discuss about GraphDB, and we'll be seeing that how we can go ahead and create some amazing generative AI application with the help of graph databases. And here also we are going to specifically use LangChain. Now let me go ahead and set up the context, because in this series of video, there are a lot many things that we really need to go ahead and discuss. So first of all, when we will start this, right, we are first of all going to learn about something called as knowledge graph, because this entire graph databases works on this fundamental concept, which is called as knowledge graphs. So we'll go ahead and discuss about this knowledge graph. After we probably discuss this entire thing, we are going to see there are a lot of different open source graph databases that are there in the market, right? But what we're going to do is that they're both paid and open source graph database. But one of the most popular open source graph database that we are going to specifically use is something called as Neo4j. right? So this Neo4j graph database, we will go ahead and have a look into like how we can specifically work in this, right? How we can insert a data, how a data is basically created into nodes, into properties, into relationships, into entities. All those things we will be specifically discussing. And in order to work with this graph databases, we like how we have specifically for MySQL, right? When we use MySQL database, we have MySQL queries. So similarly, when we use this Neo4j graph database, we will also be having something called as Cypher queries. Okay. So what I'm actually going to do is that one session I'm going to go ahead and keep for the Cypher queries itself. We'll spend around 15 to 20 minutes wherein we'll try to see that how we can actually work with Cypher queries. Okay, just to give you a brief hands-on. Once we complete this, after that, we're going to develop some amazing RAG applications or GenAI applications with the help of graph database. And in this case, our graph database will be nothing but it will be Neo4j. Okay. Now, once we proceed in working with all these topics, this will be a fundamental base. And recently, if you know, guys, LangChain has come up with an amazing module which is called as LangGraph. And with the help of LangGraph, you will be able to create some amazing multi-AI agents, which will be able to perform some amazing task, right? And this multi-AI agents also uses the concept of this knowledge graph, okay? So it is important. These are all topics what I will be discussing. It will be important. It will act as a fundamental base to start with LangGraph, okay? So understand this series of videos are going to be really, really important. It is also going to be really interesting, and you will be learning many, many things as we go ahead, okay? So yes, this was it. In our next video, we will start with understanding what exactly is knowledge graphs, okay? And then we are going to see the other topics. So yes, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. Hello guys, so in this video, we are going to discuss about knowledge graph. Now, what exactly is a knowledge graph? Okay, you can consider knowledge graph as a semantic network. Please focus on these keywords, which I am actually specifying. It is also known as semantic networks. And this network represents a network of real world entities. So let me just go ahead and write this. This is nothing but it is a network of real world entities. Very important thing, okay? Now, in this real world entities, if I just consider some example of the real world entities, I may probably say, hey, there may be some kind of events, right? There may be some kind of situations. There may be some kind of concepts, right? And this concepts or this situation may illustrate the relationship between them. The relationship between them, okay? See, whenever we talk with respect to NLP use cases, right? Let's say I have a sentence. I have sentence like this, okay? Let's say Rohit Sharma is the captain of Indian cricket team, okay? Now here you can see when we consider this entire sentence, okay, here you'll be able to see there are some important entities also, right? I can probably say, hey, here we are talking about Rohit Sharma, who's a person. This is another one important keyword which is called as captain, and this is the Indian cricket team, right? So we are able to specify from this particular sentence, and as a human being, I will definitely be, or you will be definitely able to understand if you have the knowledge of cricket, right? Here we say that, hey, Rohit Sharma is the captain of Indian cricket team. So Indian cricket team I can consider as a separate entity. Rohit Sharma is a separate entity, and there is kind of situation, there is a kind of relationship between Rohit Sharma and Indian cricket team that is nothing but it is with respect to the captain, right? So obviously when we take this entire sentence, for us human beings, we can definitely understand what exactly the sentence is. But to make a machine learn much more efficiently, right, it is a better way that we can actually represent this data in some different way, right? And that specific way is what we're going to talk about. That is nothing but knowledge graph. Now let's talk more about this, and you will definitely get a really good idea about this, okay? So here you'll be able to see a knowledge graph. If I just consider about a knowledge graph, okay, it is made up of three main components. Let's talk about these particular components. One is something called as nodes, okay? Second is something called as edges. And third is something called as labels, okay? Now let's see what this exactly nodes specify. I can say, hey, any object or any place or a person, okay, I'm just giving some example, can be a node, right? So here what we are specifying a node. What exactly is a node? Node basically means it can be any object, any person, any place, or any noun. You can also consider it as noun, right? Can be a node, okay? If I talk about edges, right? An edge defines the relationship between the nodes, okay? So edge is what? It defines the relationship between the nodes, right? So here, if I just consider, right, some examples, okay? And my example is something like Rohit Sharma is the captain of Indian cricket team, okay? So let's talk about this, okay? So here I will, you know that an object, place, or person can be a node, okay? And here you'll be able to see that I will go ahead and create this node. This is my first node. Here I'm just going to write Rohit Sharma, okay? So let me write it in another color. So let's say here I'm going to basically write Rohit Sharma, okay? My second node, if I draw it over here, is nothing but Indian cricket team. Indian cricket team, okay? Now we know that according to the sentence, we are saying, hey, Rohit Sharma is the captain of Indian cricket team. So when we say, hey, he's the captain of Indian cricket team, that basically means we are trying to show some relationship over here. So Rohit Sharma is somewhere related to this Indian cricket team. And that is where your third component comes into, label, right? In order to specify what kind of relationship is there with respect to this particular node, that is where we are going to use this label. And here, the label will be nothing but it will be something called as captain, right? So this is how, in a knowledge graph, this entire sentence is basically represented. Okay, Rohit Sharma is the captain of Indian cricket team, right? Now, why do you want to represent? Just think about this. Okay, why do you specifically want to represent, right, the data specifically in this kind of nodes and edges and labels? This is really much important to understand. Understand this is just one of the text. I may have another text over here. Okay, I may have some text like this. Virat Kohli, I hope everybody knows about these two famous people, right? Is the player of Indian cricket team. Now I've used my second sentence. Okay, I've used a second sentence. Virat Kohli is the player of Indian cricket team. So in this scenario, what I will do, I will just go ahead and create my another node. And in this node, we will go ahead and write Virat Kohli. Right? Virat Kohli. Now, when we write Virat Kohli over here, right, you'll be able to see that Virat Kohli is a player, right? So this is Virat Kohli is basically related to the Indian cricket team with the label that is nothing but player, right? So this becomes another relationship, right? Now, finally, you can see that if Rohit Sharma is the captain of Indian cricket team and Virat Kohli is a player of Indian cricket team, let's say that if we go ahead and ask our, or along with this, if we just go ahead and create a GenAI application along with my LangChain and some LLM modules, don't you think that with respect to this specific relationship, you know, there can be some relationship between Rohit Sharma and Virat Kohli? We can derive that, right? And that is what this entire knowledge graph does. Not only this, there may be more nodes which may be related over here. This will be related to, let me just go ahead and write this. This may be related to here. There may be again another relationship which you can specifically derive. This will be another relationship which can be connected to this, right? So many different connections. And just imagine when you have this huge amount of data, when this kind of graph is basically created, and this is nothing but this is my knowledge graph. And based on this knowledge graph, we can derive many things. Even our recent, like in Google search engine, right? Let's say if I am searching for Virat Kohli, then after getting the result of Virat Kohli, I may get some suggestion with respect to other players. Let's say like Rohit Sharma. How this is possible? Because Virat Kohli, you know that he's playing in the Indian cricket team. We get to know more about Indian cricket team along with Virat Kohli, all the information that you'll be seeing, and more suggestions will be able to get about Rohit Sharma. And that is how this entire Google search engine will be able to derive information that are related to Virat Kohli, because this entire graph, this entire knowledge of graph is connected to each other, right? Between nodes with respect to relationships. And that is how each and every suggestion that you'll be able to see. And this gives you a clear idea about knowledge graph. Now let me do one thing. Let me just go ahead and show you some of the amazing examples directly in Google Chrome, because Google search engine is the best example of specifically using this kind of knowledge graph. Okay, so let's go ahead and see that. So guys, now let's go ahead and see some examples from the Google search engine, because I feel that Google search engine is one of the best examples to probably showcase the working of the knowledge graph. So here right now, I'm not even signed in my Google account. The reason is very simple, because I do not want my search history to impact the kind of queries that I'm actually searching. Okay, so here if I just go ahead and click it, these are all the trending stories, trending searches that are probably showing up over here. So let me do one thing. To start with, I'm just going to take a basic example. Okay, so I'll go and search for my name, Krish Naik. So let me just go ahead and search. Okay, so here you'll be able to see that I'm able to find out some of the information. It says, hey, I'm a YouTuber. Along with that, I also upload videos on Udemy, as you all know. Along with that, here you'll be able to see that I have my profiles, LinkedIn, Instagram, YouTube, right? And here it is also specifying what all books you have actually written about me. This entire Google is providing it, right? So once I search for Krish Naik, you can see that since I have been using Google products from a long period of time, like I've been using Gmail, I've been using Google, I have my own Google account, right? You'll be able to see that it actually has taken my entire data and it has created that kind of knowledge graph. Because when I search for my name, it is showing my YouTube channel. If I go ahead and see in the videos, so many different videos are there with respect to my YouTube channel. Not only that, people also search for what kind of important suggestions are there. That also you're able to see, right? How this is entirely possible. It is very simple that it is possible because that entire knowledge graph is actually present with Google, and based on that knowledge graph, it is being able to retrieve a lot of information. Now, when I'm searching this specific information, let's take a different example. I will go ahead and write Einstein. Okay, so let me just go and search for Albert Einstein. Now, in the case of Albert Einstein, here you can see theoretical physicist is basically there. Overview education. And now this person, like Einstein, was born on 14th March 1879, and he died on 18th April 1955. Right. So here you'll be able to see about Einstein. We are able to see all the information and whatever research he has specifically done. All those research will also be visible as we go ahead over here. Right. Now this is what is there in the knowledge graph. Right. How Albert Einstein is basically connected. Now this is very important. So this all information you'll be able to see about Einstein. Right. All the information, influence, spouse, grandchildren, children. All this information is there. Okay. Perfect. Now if you go ahead and see here, you can see people also search for these all famous people. Now here you have Edward Einstein. You have Isaac Newton. You have Stephen Hawking, right? Hawking. Why all these researchers are like given as a suggestion for you? The idea is very simple, because Albert Einstein was a researcher, right? In theoretical physics, he was a theoretical physicist who created some amazing research. He did amazing research on different concepts, different things, and that all are available in the internet, right? And based on that, you're able to see that they're also trying to find out the link with respect to other researchers like Isaac Newton, right? Because Isaac Newton was also there at this particular time frame when gravity was probably, that apple fell on his head, and he was able to completely invent gravity completely through his research, right? So here you could see that. Then you have Stephen Hawking's, So all this information, how they are actually related to Einstein, that is basically shown over here, and that is all possible because of this knowledge graph. Right? Obviously, when I'm searching for Albert Einstein, when I search for Albert Einstein, they're not going to give the suggestion of my name, Krish Naik, over there. The idea is very simple over there, because I'm nowhere related, right, to Albert Einstein in terms of research or anything else. So it is completely different, right? So that is how, in this world, since there are huge amount of data that is available in Google, right, and there you'll be able to see that this kind of knowledge graph is created with respect to nodes, edges, and labels, right? And that is how this entire Google search engine is working behind that, right? Even YouTube search, completely YouTube search, the kinds of ad that is visible on you, like what kind of ads you'll be able to see it. That entire thing is controlled by this graph knowledge graph itself, right? So I hope you were able to get an idea about knowledge graph, and I hope I was able to explain you this in a pretty easy way. Okay. So in the upcoming videos, we're going to discuss about Neo4j graph database. And yeah, I just want to show you one more example over here. Let me hide this. So this is what a Neo4j database looks like. Okay, and I've inserted a huge amount of data over here just to try out multiple things. Okay, so let's say there's a relationship over here. I'll just and one of the relationships is something like chief executive officer. So once I click this, here you'll be able to see this is the query that you are able to see over here. And this query is basically called as a cipher query. Okay, so usually whenever you work with a graph database, in the graph database you specifically get this kind of cipher query. Okay, so this based on this cipher query, you can see that as soon as I selected a relationship like chief executive officer, it shows hey, Elon Musk is a chief executive officer of Tesla, right? Not only that, let's select some more thing, like trillion dollar company. So here you can see Tesla is a $1 trillion company, right? And this is the query that is there. I'll try to show you. I'll give a tutorial with respect to the cipher query as we go ahead in the series of video. Okay, then let's select some more. Okay, so here you can see there are nodes. Okay, nodes are over here. There are relationship, and there are property keys. Property keys are nothing but it's just like a you can just see that relationship are nothing but this specific relationship along with the label. If I go ahead and click on property keys, let's select one of them. Okay, there you'll be able to see some values that are really related to this kind of searches that we specifically do. But anyhow, I will try to show it to you. Some more examples if I try to go ahead and show you over here. Okay, let's see some more things, right? Let's say best selling is there. Okay, now here you can see Tesla. There is two best selling models, that is model Y and model 3, right? And this is the query that you have with respect to that, right? Then let's say I'll go ahead and to select one more thing, inspiration. Okay, so here you can see a piece of writing, inspiration, all this information, how it is there. Piece of writing that expresses emotions or ideas in a rhythmic and imaginative way. This is a poem, right? I've taken a poem, I've inserted it into the entire graph database. Automatically from that particular graph database, since I've used this Neo4j along with LangChain, you'll be able to see that automatically these nodes we are able to create it. And not only nodes, we are also able to create this kind of relationships itself, right? So all these things we will proceed and we'll see. It will be quite amazing and interesting when we will be starting this from completely scratch and we'll be understanding more about it. So I hope you like this particular video. This was it for my side. I'll see you on the next video. Thank you. So guys, in this section of video, we are going to start with our Neo4j graph database account creation. And over here, we are going to use Neo4j Aura DB. Okay, so if you just go ahead and search for Neo4j Aura DB, so here is the link. Okay, and you'll be able to create your own database in the cloud platform. The best thing about this particular Neo4j Aura DB is that you'll be able to run one single instance through which you will be able to develop multiple projects as such. Okay, so I'm just going to go ahead and search for Neo4j Aura DB. I'll go ahead and click on the first link. So once I probably go ahead and click on the first link, this is what you will be able to see, right? Neo4j Aura DB, the world's leading graph database, is a fully managed cloud service, zero admin, globally available, and always on. So what we're going to do is that I'll go ahead and click on start free. Okay. Now, when we start this, you'll be able to see it will ask you to probably continue with Google. You can just go ahead and sign up with Google. Let's say I will go ahead and sign up with one of my email ID. Once I click on continue, so I will be going inside my Neo4j database itself, right? So specifically in your cloud console. So I'll go ahead and click on terms of service. I'll just go ahead and say agree. Now there are three plans. One is free, one is professional, one is enterprise. If you are actually working, just you want to try it out, you'll be able to work in the free. This has like best place to start learning Neo4j, no credit card required, access to all graph tools. Okay, for learning a small development project limited to 200k nodes and 400k relations. So that many number of nodes you'll be able to create inside this. So right now, obviously I don't want your money to be wasted. So let's go ahead and try for free. And this is your entire password that is probably generated. So what you really need to do is that click on download and continue. The reason is very simple because the thing that we're downloading, this is the instance. You'll be able to see, you'll be able to get a username. See, Neo4j URI. So through this URI, you'll be able to access it. Neo4j username. So this is the username, this is the password, right? And this is on instance ID and instance name. This will be important when you start coding along with LangChain. At that point of time, you will be requiring all these details. So what I'm actually going to do, I'll just go ahead and close this. So I'll just go ahead and write, okay, I'll say, hey, work projects or personal projects. So let's say teaching or taking a class. I'll go ahead and click on next. I will write data scientist or data engineering. I don't have what this best describes your use case. Regenerative AI, I'll just go ahead and finish it off. Now here you can see by default, your first instance is basically getting created, and you can also go ahead and see this particular video with respect to the introduction to Neo4j. Okay, so this is going to take some amount of time, but please make sure that you save this entire details somewhere because we are going to use this particular details, right? When we work with LangChain. So for creating this particular instance for the first time, it is going to take some amount of time. So let's wait till the instance is basically going to get created. Okay, and then we are going to continue. So finally, here you can see that your instance has been created, and over here it will also track the number of nodes that you're going to create. Along with this, you'll also be able to see that the number of relationship that is going to create, right? It's going to track each and everything. The region where this particular cloud instance is created is this Asia Southeast 1, and this is your connection URI. Okay. Now, in order to open this particular instance, I will just go ahead and click on open. Okay, and it will just ask for a password over here. Here you can see this basically saying it is going to use the same session. It is just going to click on connect. So let's go ahead and connect this. Okay. Let's see. I will be giving my database username. So database user is over here. So this is my username, Neo4j. Okay. You need this specific information, and the password obviously you'll be able to see over here, Neo4j password. So I will go ahead and click this. Perfect. I'll go ahead and click on connect. So let's save this so that anytime I open this particular instance, I should be able to get it. Now here you can see that I've not created any nodes, relation, and property keys. Okay, and this is your entire instance. Now you can probably go ahead and write your query over here, and based on that particular query, you can go ahead and create your nodes, you can go ahead and create your relationships, and you can go ahead and create your property keys. So till here, I think you please do all these particular steps because in the next section of videos, we are going to discuss about something very important because how this database is completely different from MySQL database. That is what we are going to know about it, right? So please go ahead and follow the steps and probably create this entire account and keep it ready. So yes, I will see you in the next section. Hello guys, so in this section, we are going to discuss about the basic differences between RDBMS versus graph database. When we talk about RDBMS, this is nothing but this is my relational DBMS, right? Database management system. Along with this, we're going to compare with the graph database. If I probably take some of the example of RDBMS, it is nothing but like MySQL, SQL Server, right? I hope everybody may have known about this, right? And you may have also used it. So in order to compare the differences, so let me go ahead and write RDBMS over here versus our graph database. So the basic differences that I really want to talk about, and this is important before we start, creating our entire nodes, properties in graph database. Okay. So first is related to tables, right? So in RDBMS, we basically create tables, right? Similarly in graph database, here instead of creating tables, we will be creating something called as graphs. The second important difference is that inside this table, we insert records, right? We insert records, and these records will be something called as rows, right? In the case of graph database, we specifically use something called as properties and its values, right? So here, instead of saying it as rows, we specifically say it as properties. The third thing over here, and again, we will be discussing about all these things when we do it in our practical implementation. If I probably talk about tables, rows are there, rows are for rows records, right? Whenever we insert a record. But in every row, there will be some kind of columns. And with respect to these columns, there will be data also, right? Some data will definitely be there. So similarly over here, this rows, I just need to make some change over here. When we say rows, right, over here, inside this graph database, we have something called as nodes, okay? Nodes. Now, this nodes will be like this circular structure, right? It can be an entity, it can be a name, something like that. When we talk about columns and data, these are nothing but it is basically properties and values. Properties and values. So how we represent columns and data in RDBMS, similarly in graph database, we represent it as properties and values. Then coming to the fourth and the important point, which is called as constraints. I hope you have heard about this kind of constraints where you have something like primary key, where you have foreign key, where you have candidate key, right? So different types of keys are there, and the reason of making keys is that there'll be a dependency of another table in a specific table itself, right? Similarly, over here, if we really want to create constraints in graph database, we basically create relationships. Like one of the example I told, right? So this is my two nodes, and this may be related to this, right? Let's say over here I have Tesla. This is a company which is owned by Elon Musk, right? So I can just go ahead and write owned, right? So owned is basically a relationship. And in tables, most of the queries, we write a lot of joins queries itself, right? And instead of writing join queries in graph database, we specifically use something called as traversal. Traversal basically means based on the properties, based on the nodes, based on the relationship, we travel from one node to the other node to finally get a result, right? So these are some of the basic differences between RDBMS and graph database, right? Instead of using tables, we use graph over here. Instead of inserting records or rows, we create nodes over here. Then we have columns and data. Instead of columns and data, we use properties and values. Similarly, with respect to constraint, we have this primary key, foreign key, candidate key in RDBMS. Similarly, here we have relationship. And instead of join queries, we use something called as traversal. Now, let's talk about some of the important advantages. So let's go ahead and talk about advantages of Neo4j. Okay. Now there's some very good advantages. First, this Neo4j database works with respect to a graph data model. We'll talk more about this graph data model. This graph data model will be responsible in creating these nodes, relationship, properties and values, and many more things. Properties and values. Okay. Now coming to the second and very important point. When we use this Neo4j in the cloud, it provides us real-time insights. Like as soon as I create a graph. Because see, at the end of the day, when we use Neo4j, there you could see in that particular instance, nodes were getting maintained in a separate way, properties were getting maintained in a separate way, relationships were getting maintained in a separate way, right? Here, you'll be able to see that. If I go to the third point, you will be able to retrieve the data very much easily just by writing one query. And over here, we will be learning about this, which is called as Cypher query. Like how we have a SQL query, similarly, we'll go ahead and write the Cypher query. And sometimes you don't even have to write the Cypher query, right? Just by clicking on any of the relationships and all, automatically you'll be getting a basic template of all the queries itself. And that is all possible because of this Neo4j database. Okay. As I said, let's talk about this Cypher query. So we basically say Cypher query as this Cypher query language. Cypher query language, right? Now inside the Cypher query language, it is, you can just say it as it is a declarative. It is a declarative query language to represent the graph visually. It is used to represent the graph visually. Okay. And the best thing about Cypher query will be that you'll be able to understand in a very much easy way because it is human readable. Okay. And one of the very important thing that usually in RDBMS, sometimes when there is a nested queries and all, you really have to use a lot of joins. But in Neo4j, you don't have to use any joins. That's the best thing. So that makes this entire Cypher query language amazing for doing different purposes, for retrieving different kind of data itself. Okay. So we will be talking more about it as we go ahead, and I've also spoken about the advantages of Neo4j. But if I probably talk about most of the common properties like ACID properties, Neo4j supports complete ACID properties, right? When we say ACID, what does this basically mean? In RDBMS, there are 4 important properties. One is atomicity, consistency, isolation, and durability, right? So let me just go ahead and write this. It is nothing but atomicity, okay, consistency, isolation. Along with this, you also have this durability. So with respect to this ACID properties, which is one of the core features of RDBMS, similarly, this is also supported in Neo4j. You'll be able to see that once you start using this, there is no such kind of fixed schema. Okay, so one of the very good advantages with respect to Neo4j is that we don't have any fixed schema. It is having a flexible schema. Okay, it's not like that one of the node will have only 3 properties, the other node will also have 3 properties. No, nothing like that. It can have any number of properties. It can depend, right, based on the data that we have. So this was just to give you a clear idea about the differences between RDBMS and graph database. Along with this, we also saw what are the advantages of specifically using Neo4j. Okay. Now, in the next video, in the next section, we are going to discuss about the data model in Neo4j, and that will actually give us a crux understanding about how a node is basically created, what are the important things, what are the important components when we go ahead and create this kind of nodes by using Neo4j database, by using the Cypher query language. This was it. I will see you all in the next section. Hello guys, so in this section of the video, we are going to discuss about Neo4j property graph data model. Now, this Neo4j graph database uses something called as property graph model, and this model is specifically used to store and manage data. Okay, so we'll get an idea about it as we go ahead, as we proceed. Okay, now this is very much important. What exactly is property graph model? Now, this model represents 3 main important things. One is nodes. Second one is something called as relationships. And the third is nothing but, let me write it in another color so it looks good. So the first is nothing but over here, I will go ahead and write, it is nothing but nodes. Second is relationships. Third is something called as properties. So this property graph model, or this model represents the data, the entire data, whatever data you have right over here in this 3 important specifically these 3 important things, that is nodes, relationship, and properties. Properties are just like rows and records. So this will specifically be having key value pairs. Okay, it will be having key value pairs. And one more thing that you really need to understand, when we talk about this relationship, this is both unidirectional and bidirectional. So whenever we go ahead and create any kind of relationship, you can actually create it in the form of unidirectional, and you can also create it in the form of bidirectional. Okay, and every relationship, see, if I probably consider this relationship, let's say this is my node 1, this is my node 2, right? So let's go ahead and write node 1, node 2. Okay, now with respect to this node 1 and node 2, whenever we create any relationship, let's say this is having a relationship of this, let's say node 1 is the parent, or I can go ahead and write node 1 is the parent of node 2, right? Now in this relationship, this node 1 is just like your start node. And if I probably consider this node 2, it is nothing but it is my 2 node. Or we can also say 2 or end node. Okay, since we are basically going to write this, right? See, this is also called as start node. It can also be called as something called as from node. Okay, this can also be called as 2 node. So this is really important for you all to understand. Okay, but if I probably consider the entire graph DB data model, so if I probably consider graph DB data model, okay, here there are 3 important blocks. Okay, one is nodes, one is relationship, and the third one is something called as properties. Okay, as I said, I've given you multiple examples over here. So let's say this is one of my node, this is my another node, this is my third node. Okay, here I will go ahead and take one movie, right? So let's say Avenger. Okay, so let's say Avenger and Tony Stark. Okay, so I'll say, hey, Tony Stark. So Tony Stark was an actor in Avenger, right? So this is one kind of relationship. Okay, like Tony Stark was an actor in Avenger. There can be another movie where Tony Stark was again an actor, right? Here I guess he was a villain. I'm just putting. Okay, there was a villain relationship with respect to one of the movie. This movie can be any other movie, right? Movie 2. So this way you'll be able to see at any point of time this pink color node. This pink color circle is basically called as node. This is called as relationship, right? This actor is basically a kind of you can just consider that it is a kind of property, but you can define this property in key value pairs also, which I will probably be showing you, right? So this is what is entirely the understanding of the graph, the node Neo4j property graph data model. And again, I said, right, this can be bidirectional also. It can be a relationship, it can be unidirectional, it can be bidirectional. Okay, so like this, if you have an entire NLP text data, right? Just imagine NLP text data, then just by using, and this internally uses something called as graph neural network. With the help of this graph neural network, we will be able to create this, right? Now, from where we'll be getting this graph neural network? For this, we will be using LangChain. Okay. Again, LangChain has a good graph DB functionalities, which will be able to take the particular text data, and we will be able to convert this entire into this particular nodes. Okay. But for that, again, we need to write Cypher query. But if you just directly want to convert it with the help of model, we can use the graph neural network. And I think graph neural network functionalities, this also you can probably go ahead and train it from completely scratch. But right now, we'll focus more onto the LangChain, which has features to convert this particular data insert into the graph DB database itself. So yeah, this was all about graph data model. Now, in the next section of the video, we will go ahead and do some practicals and we'll try to insert some data in our Neo4j or RDB. So yes, this was it. I'll see you in the next video. Hello guys, so in this section of the video, we are going to probably go ahead and create this nodes, relationship, properties, labels, and we'll try to see that how this entire information is basically created with the help of Cypher query language. Okay, very important video altogether because this will actually help you to understand how to write a specific query. So here, first of all, as soon as you open your Neo4j or RDB, once you go inside this particular instance, you'll be able to see this particular text box, and this is where you write your own query, right? Now let's go ahead and try some of the queries over here, and we'll see how we can go ahead and create nodes, relationship, property, keys, and many more things. Okay, so let's go ahead. So first of all, what I'm actually going to do, I'm going to go ahead and use this create keyword, and let's create our first node. Okay, so I will just go ahead and write node 1. Okay, so once I create this, create node 1, so it is just going to create my first node, and once I execute this, here you'll be able to see that hey, node 1 is basically created. Okay, but I'm not able to see this node 1, right? If I go ahead and click this, it shows hey, I've assigned some ID over here. This ID value is 0. Okay, so I told you that whenever we try to create nodes are nothing but entities, names, something like that, right? And obviously over here, I did not provide any kind of information over here when I probably created this particular node because I need to provide some kind of labels, right? If I say hey, I'm going to create a node 1, let's say node 1 is something over here, and if I give a name like Krishna, then this particular node name will be assigned to Krishna, right? So let me just go ahead and in order to return everything, you can see match n, that is nothing but nodes, return n limit 25. Okay, so now let me just go ahead and create another node. So I will go ahead and write create node, and you can create multiple nodes also. But here, what I'm actually going to do, I will just go ahead and create one of the node, and along with that, I will just go ahead and assign some kind of labels. Okay, now when I say I'll be assigning some kind of labels, what does this basically mean? So let's say I'll go ahead and write Elon, okay, Elon Musk, okay, and this is my node that I'm actually creating. And let's say I'll go ahead and write he's the CEO, right? So once I execute this, you'll be able to see now I'm able to see one of the node which is called as CEO, okay. My node is Elon, but over here I've tried to assign some kind of label value which is called as CEO, okay. Otherwise I could have created another node like famous personality and I would assign one of the label like Elon, right? So this way I can now see my nodes over here, okay. So if I really want to go ahead and see like who's the CEO, so if I just go ahead and create over here, you'll be able to see this particular information, right? And once I go ahead and click this, okay, this shows the node details. This is my CEO, the key ID value is 1, okay. So till here I hope you got an idea of how to probably create a node, right? And here you can see as soon as I clicked on CEO, it gave me a result where match n colon CEO, return n limit 25. 25 basically 25 results is allowed to retrieve. And here I can probably see one of them. Okay. So I hope you got an idea with respect to creating a simple way of this kind of nodes. Okay. Now let me do one thing. Let me just go ahead and create one more type. Here I will go ahead and write Elon. Okay. Elon. I will create this particular node. Here I will go ahead and say he is also a CEO, right, of Tesla. Along with that, he's also an employee. So I'm going to create this now. See here, what exactly the CEO and employee will basically do. CEO1 is the label over here. Okay. And here I'm trying to add some more labels, right? Like employee is also one more label that I really want to create. So if I go ahead and execute this, here you can see that now it has got executed, and my one more node has actually got created. It is nothing but employee, right? And if I go ahead and click on employee, so this is my second node, right? Still, CEO and employee, there is no relationship, so we are not able to probably see the entire relationship of the specific node, okay? But here, if I write this query, match n colon employees, return n limit 25, okay? So this is one of the query with respect to Neo4j. So this all things we have actually tried, okay? And this is amazing because now we have also understood that fine, we can create multiple labels, okay? Just with respect to one node. So I hope you're very much clear with this basic things, right? Now, similarly, I can create different nodes with lot of different information. Okay, let's say I go ahead and write create Elon. Okay, inside this I go ahead and write okay fine, he is the CEO. Okay, now with respect to the CEO, I can go ahead and write some more information. Now I know that this is my label. Okay, but being a CEO, this person has some kind of name. Elon has name, right? So I will go ahead and write my name called as Elon Musk. So this is nothing but this is called as properties. Okay, so here I'm trying to create a node with this label name and this property. So I'll say, hey, Elon Musk over here. I'll say, okay, let's go ahead and write this year of birth. Let's say I'll go ahead and write in 1979. Okay, I hope so. He was born in 1979 or some other date, but you can go ahead and validate it. Okay, and then let's say the place of birth. I have heard is from South Africa. Okay, so I'll just go ahead and write SA. Okay, okay, perfect. So here you can see that I've mentioned all this information, and this is my property keys, key value pairs. These are my properties for this particular label. Okay. Or I can also go ahead and probably inverse this entire information, but right now we are able to share or store this particular name and all. So now let's go ahead and execute this. Once I executed this, you'll be able to see now I have this property keys name. Okay, name node is nothing but Elon Musk. POB over here you can see node is South Africa, and YOB is nothing but the node information is 1979. So this information you're able to see that now we have also created some kind of property keys, right? And this is how the query is just there. See, if I really want to understand what is the value for this name, so it is automatically creating this particular query. Match n when n.name is not null. Return distinct node as entity, n.name as limit 25, union all, match this particular parameters, right? R.name is not null, return distinct relationship as entity, R.name as name limit 25. You'll be seeing that this all kind of queries will try to generate from LangChain. So here the main idea is just to make you understand how quickly you can probably create your nodes, your relationships and property keys, right? Now, I hope you're able to understand this. Now again, in order to get all the information out there, I'll just go ahead and write match n. Okay, so let's go ahead and write match n, and here I'm just going to return n. Let me go ahead and write this match n, and here I'm just going to go ahead and return n. Okay. So if I go ahead and execute this, I'll be able to see, okay, fine, these are all my nodes that you can see over here. If I go ahead and click on Elon Musk now, you can see, right? So Elon Musk is one of the name over here, right? And you're able to see all these values. And this node details is nothing but CEO, right? So here you can see POB, name Elon Musk, year of birth, every information is probably visible over here, right? And this is amazing because here I made sure that I created based on the name, you can see the node name is basically assigned. If you're not providing, let's say if you have just provided label, initially the label will go away. But if you provided some property key value pairs where you have name information, that gets replaced over here, right? If you see another node 2 is here, 1 is over here, this is my CEO details and the other nodes itself, right? So blank by blank, you'll be able to see this. Yes, I'm able to see the circular nodes each and everywhere, okay? Perfect. So I hope you're able to understand this entire information, right? And you're able to see that how we have easily created this entire nodes. Okay. Now let's go ahead and try to create relationships. Okay. Now you know that Elon Musk is the CEO of Tesla. Okay. Now if I really want to create, first of all, I need to create two entities. Okay. So let's go ahead and create this. So here I will write. Okay. I've already created Elon Musk. Okay. Now let me just go ahead and write my the Tesla company details. So here I will write create. So I will just go ahead and write create. So this will be create. Now inside create, I will go ahead and write. Okay. Let's say this is Tesla. Okay. I will provide label over here called as company. Okay. And with respect to this particular company, let me just go ahead and give some information in the form of key value pairs. So I'll say name is nothing but Tesla. Okay. So here you can see Tesla is the name of the company and this is the label. So if I go ahead and execute it, you'll be able to see I'm able to get the company. So if I go ahead and just click this, I'm able to see Tesla. Okay, perfect. Now I want to create a relationship between Elon Musk and obviously if I probably say Elon Musk with Tesla, right? Now here you'll be able to see that if I click on name, right? Elon Musk is there and Tesla is there, right? So how do I probably go ahead and do this? So if I go ahead and click on company, so this is company, this is CEO, okay? And CEO, these are my three information, right? So Elon Musk. So let's see how we can probably join this, okay? Or how we can go ahead and create this relationship. Already, if you know, in the downwards direction, if I go, right? Here you'll be able to see where I've actually used it, Elon, right? So here I've created a node called as Elon, right? Now what I will write, since there is already a node with the name Elon, so if I go ahead and press this, I think it was this one itself, right? So let's see this, the node is there. So here what I will say, I will create Elon, okay? And then I will put a relationship. In order to put a relationship, I have to use dash. I'll use an R parameter, and here I will say CEO, and here I'm just going to give this arrow direction, and let me go ahead and write my another node. My another node will be what? My another node will be specifically for this particular company, right? And the company name that I have actually created, the company node that I have actually created is what? Tesla, right? So here what I'm actually going to write quickly, I will say, hey, go ahead and create this relationship with Tesla. And once I execute this, you'll be able to see created two nodes, created one relationship. Now CEO is one of the relationship. Now if I go ahead and click this, see the magic, okay? So here you can see 5 is basically getting created, 6 is basically created. Now what I have actually done is that I used this particular node, Elon, with Tesla. And I don't know why Elon, when I see down, okay, I had actually created this entire thing. So spelling is wrong or correct, let's see. Elon with CEO, right? So here, so if I go ahead and say Elon with CEO of Tesla, it created two nodes, but it is giving me this particular node name, right? The reason is very simple because this 5th and 6th is actually creating as a new node, okay? It did not use the older nodes itself, okay? So in order to do this, let's take one more very good example, okay? I will just create it from scratch and then we'll get to know why that node name did not come, okay? So I'll say, hey, go ahead and create, and let me go ahead and write my name, okay, Krish. I'll say, hey, I am a entrepreneur, okay? I'm an entrepreneur. This will be my label, and let me just go ahead and write name. Oops, name. So here I will just go ahead and create my name, and let's go ahead and write my name as Krish, okay? Krish. After creating Krish, I will just go ahead and write my YOB. This will be nothing but 1989. Okay. Along with this, let me write place of birth, and here I'm just going to write India. Okay. So all this information is there. Okay. Place of birth, India. All this information with respect to this, everything is available over here, right? And let me just go ahead and use this. Should be string. Okay. Now, let's say that I'm going to go ahead and probably press enter. Let's go ahead and create my another node. Okay. So here I'm just going to write create. Okay. And I will write IND India, which is my country. So here I'm going to write my country label, and let's say here I use something called as label, and here label will be name is equal to India. Okay. I just want to specify that I live in India. Okay, so that kind of relationship that I really want to put over here. So Krish is a node name, my node basically, and this is given with a label called as entrepreneur. Name is Krish, YOB, 1989, place of birth is India. I created another node with country as my label, and name is equal to India. So once I execute this, you'll be able to see now I'm having this entrepreneur, okay, Krish, and country with India. Okay. So guys, now once I have created this entrepreneur, so let's double click this. So here you'll be able to see that, okay, this is my node, obviously, with the label name entrepreneur, and here I have Krish, right? And if I just click over here, you'll be able to see all this information. But if I double click on this, you can see that it shows the relationship that it is using, lives in with the country India, right? And if I just double click on this India, here you'll be able to see that all the values with respect to India is also given. This is one way of creating the relationship, okay? But understand one thing, guys. Whenever we are working with huge databases, right? When we have a huge amount of database, right? With respect to tables, also we have different information. Let's say if I want to specify person name, I should definitely have a similar kind of labels used everywhere, right? So in order to just show you, let me do one more example, okay? Let's say I'm going to create a node, okay? So let's say this will be my node P, and here I'm going to just use my person name, okay? So this will be my person, okay, which is my label name. And let's say here I'm going to specify as name. Name is nothing but, let's say, one of the famous actor that is actually available is Tom Hanks. I hope you have seen this movie, amazing movies that he probably creates. And let's say this person is born in 1956, so I'll just go ahead and write 1956. So here what I've actually done is that I've actually created an person, a P, like a node P with a label name person, and the name information is Tom Hanks, and person is born in 1956. Okay, so let me just go ahead and create another node. So here I'm going to basically use another node which is called as movie, and here my node will specifically become M. I'm just mentioning M, and we're going to make this node similar for every records that we enter. So here I'm going to write M colon movie, okay, and here I'm going to use my title. Along with that, I will go ahead and use my, let's say, the movie that the person may have acted is like Forrest Gump. Okay, Forrest Gump, and it was basically released, and it's an amazing movie. I think everybody should probably watch this movie because it is fun, comedy. There's so many things in this, right? So here I'll go ahead and write released, and let me just go ahead and write 1994. Okay, so let's execute this. So here you'll be able to see that I created two nodes. One is with respect to person, so Tom Hanks is over here. With respect to movie, Forrest Gump is over here. The reason we have just used P as our node because whenever we create a new person over there, again the properties will only change, the name will change. Similarly, whenever I add a movie, right, the movie name will be changing, the title will be changing. Okay. Now let me just go ahead and create a relationship between this movie and person. The person is acted in the movie, so I'll just go ahead and create a relationship. Okay. Now in order to create a relationship, first of all, what I will do is that I will do some matching. Okay. So I will go ahead and write match. Inside this match, I will say, hey, let's go ahead and take P colon person. So here I will just go ahead and take this person, and obviously I have to match with the exact name of the actor. So here I will go ahead and write Tom Hanks. So I hope this is the name of the actor. Let's see, Tom Hanks. Okay. Now once I do this, then I will also do another match over here. Okay, so this is with respect to the person name that I'm actually doing. Let's do another match. Here I'm going to probably take M dot movie. Right, so if I go ahead and write this, let me see whether the brackets are closed properly or not. Yeah, this looks good. Okay, so I'll just go ahead and write M dot movie because movie is my sorry, it should not be dot, it should be colon. Okay, movie is my node name over here, and again I have to exactly use that particular title because I need to create a relationship. So let me just go ahead and write title colon, and let's say what is the movie name over here? Forrest Gump. Okay, it should be double R, but I'm just writing it as single R. Forrest Gump. Okay, so when I am probably executing this, okay, so here if I execute this, let's see what error I get. Okay, will I get any error? So here you can see query cannot conclude with match, must be a return clause. So I have to also go ahead and write a return clause. So what I will do, I'll press enter over here after doing this match. I'll say, hey, let's go ahead and create this relationship where I will take my P, which is my person. I will create a new relationship which is called as acted underscore in, right? And with respect to this, I will be creating a relationship with M. Okay, so this actually does a lot many things, right? And here you'll be able to see this entire thing that I've actually created a relationship. Okay, so here let me do one thing. Let me remove this. Okay. Okay, sorry. I think this got executed, so we are not able to update this. So I will just update over here. Okay. So this is the same thing that we have actually done. Okay. Now let's go ahead and execute this. Now here you can see no changes, no record. The query built a Cartesian product between disconnected patterns. Now what may be the problem? Okay, I used double R over here. No worries. So let's go ahead and execute this. Now it shows created one relationship. This query builds a Cartesian product between the disconnected patterns. And let's see, okay, whether the relationship is created or not. I clicked on acted in, and here you can see Tom Hanks has acted in Forrest Gump. Okay. The reason why we were able to get the previous warning over here, this one, it is because I'm just trying to insert any kind of data over here, and it is just trying to find out the relationship with respect to other labels also. But this is how very beautifully we have actually created a relationship, right? Similarly over here, see, we did this lives in and all. So here Krish lives in, this information is over here, 9 to 10 over here, 9 to 10 because here we did not give any label name, right? All this information we could see very much easily. Now similarly here in acted in, we have actually created this specific relationship. So any number of relationship you can go ahead and probably get it. Now there may be a scenario that where I want to probably retrieve nodes and relationship. Okay, so in order to do that, let's say if I go ahead and just execute this match P colon person, name is equal to Tom Hanks, return P. So I should be able to get Tom Hanks, right? Similarly, if I want P with person and I'm using this colon acted in, that basically means this is the relationship that we're looking for, and we're returning P and M. So here you'll be able to see that I will be able to get both the nodes, but I'm not able to see the relationship. The relationship, if I really want to get, then this is the query: match P, acted in, return P limit. Okay. Now let's do one more thing. Okay. Let's create one more person. Okay, and then we will try to add some more information with respect to that particular person. Okay. So let's say over here, I will say there is also one more actor which has probably acted in Forrest Gump. Okay, and if you see there are a lot of actors over there, so here I'll just go ahead and copy this. Okay, I will say, hey, movie title, this is there. So let's go ahead and okay, this is for the relationship. Okay, so let's see where the person we created this, right? So here I'm going to create another person, and let's say this will be another actor that we're going to use. Now see this will be amazing. I'll say, hey, I know I have not acted it, but I'm just going to write. Okay, Krish, I'm born in 1989. I know, but I'm not acted over here, so I'll simply try to create a relationship. So this will be my another person. So here now if I go ahead and click on person, so here Tom Hanks you can see, and Krish is, you can see, right? Now the next thing will be that I will try to create a relationship between this movie that is Forrest Gump and Krish, right? So I'm going to basically use this two information. So if I go back down, right, I created this entire node. So I'm also making sure that I'll create that relationship. So I'll say match this Forrest Gump. Okay, this is fine. This is to get the query. Okay, and here how do I probably create the relationship? Here you can see this. Okay, so let's copy this entire thing. I will paste it over here. Okay, and here I'm going to write Krish. Okay, person name is nothing but Krish. Movie title this. So and so I've acted it. Okay, so once I execute this now, if I go and now see acted in, you'll be able to see two people are acting over here. Krish acted in this. Tom Hanks acted in Forrest Gump. And this is how you can probably go ahead and build your queries, and you can keep on writing multiple things over here. Okay, for retrieving anything as such, just write the match keyword, and automatically you'll be able to retrieve all those information. Okay, let's say I need to also update different nodes and relationship because see in Tom Hanks the born is 1956. Okay, let's say that okay I have mistaken, I have to probably update it to 1957. So I will just go ahead and write match, and here I will write P colon person. Okay, and here I'm going to write my name colon. Okay, name colon. Let me just go ahead and write Tom Hanks. Okay, so okay this time Tom Hanks. Okay, so you're matching with the specific person information, and then we are just going to write a set keyword. So set is also there. I'll just go ahead and write p.born is equal to 1957. Okay, perfect. Let's return on this p. Then I should be able to get this particular information. So if I go ahead and click on Tom Hanks now, you'll be able to see 1957, right? So this was some of the queries. Again, guys, please write down the queries along with me for your understanding. It is, I don't know, like how we can probably download the script and all, but let's see whether we'll be able to know Cypher snippet saved. Click in this. But according to this, I don't know whether we will be able to explore these queries or not. But please go ahead and execute it from your side, okay? And if you are getting any kind of issues, just let me know with respect to that, okay? But I hope you got an idea of creating a node, of probably creating a relationship, of probably creating property keys, you know, and how you can basically work with different things, right? In the upcoming session, we will be discussing about more advanced queries as we go ahead, right? So yes, this was it from my side. I will see you all in the next video. Hello guys, so we are going to continue the discussion with respect to our graph database. Now we are going to see some more amazing examples which will be intermediate to advanced level, and we will try to see that how we can upload this particular data in the graph database itself, right? So here you'll be able to see that I've created a GitHub link where I've uploaded some of the database like datasets like movies.csv, posts.csv, ratings.csv, and then we will take all the CSV file and we'll try to upload this particular dataset inside this graph database itself. So for that, what kind of queries will be required? All those things we will be discussing. So the kind of use case that I'm actually going to show you, it is something related to social media platform, you know. So you know that you will be posting your post, there will be various users, and based on that, you may be liking a specific post, you know, and you may also have some of the friends in your social media platform. So considering this, you can see these are some of the important CSV files. So here is one user underscore social.csv. So here you have user ID, name, age, and city. So these are all the details, and it is a comma separated file. Then you have this user ID 2 type, like 1 to 2, who all are friends, right? Based on the user ID. So here you can see if 1 to 2 friend is there, so John and Sarah is actually a friend, right? And similarly 1 to 3 is a friend. Then 4 to 1. So fourth ID is basically liking the post of the first ID in terms of the user, right? So all this information is there. Other than that, you also have some post ID, content, user ID, and timestamp. So there is also post.csv file. Here you have posted something with respect to the timestamp, and you have all the information. Now what we are going to do, first of all, we will insert all the specific data inside my graph database. So how do we insert data? So for this, we will be using inbuilt function which is called as load CSV, right? So here I'll say load CSV with headers. Okay, so I'll say hey, with headers we are going to load all the CSV file. Then it'll ask me where the CSV file is available, right? So right now I have used this. So here you'll be able to see that I will be copying this entire link. I'll be pasting it over here. Okay, so this will be the link where my CSV file is present. So I will just go ahead and create as a temporary variable called as row. Okay, this row will be making sure that it'll have all rows. It'll basically iterate to all the records that are available inside the CSV file. Okay, then we'll go to the next slide and then we will go ahead and create all these users. Okay, now here what exactly we have specifically done? It's just like you are loading this entire CSV file. You're running a for loop on each and every records. Okay, so I hope this is very much visible. Okay, so I'll be just writing it in this way. Now what I will do, I will go ahead and say for every row, let's create a user. Okay, I know so there is a specific user over here, and if you probably click this user, there are some of the users that you'll be able to see. Okay, and let me just zoom out. Okay, and right now the user is just in this ID format. Okay, so it was the previous data itself. So what I will do is that I will just delete this user. Okay, in order to delete it, you just need to, instead of writing return n, I will go ahead and delete it. Delete n. Okay, so just by using this delete n and no need to write limit 25, you'll be able to delete the entire node. So once I execute it, here you can see deleted 5 nodes. Now you can't see any users over here as the nodes, right? So try to do it that way. Now I will go ahead and create my user. Okay. Now when we are creating the specific user, here I will also go ahead and specify my user ID. So let's go ahead and specify my user ID. This user ID will basically be my properties, right? Here I will be using 2 integer. Now see this. Once we use 2 integer, that basically means what we are doing for every row, whatever will be the ID over there, right? So right now this is the user ID, right? By default when we read it, this will be in string, but we will try to convert this into an integer. So here I'm going to write row dot user ID. Okay, so row dot user ID will be the thing. And then after that, let's go ahead and create my name row, like the name property. So it will be again row dot name. Okay. And finally, you have this age, which will be again 2 integer. We will use 2 integer to float whatever numbers you want. And here I'm going to basically write row.age. So this way, we are actually going to create all our properties, right? And finally, after this, we will also create one more. That is nothing but city, row.city. Okay. So I hope every user should be getting created directly from the CSV file. Okay. So now what I'm going to do, I'll close this, and now let's execute it and let's see whether everything is working fine or not. So here you can see, hey, amazing. It has created 5 nodes, 20 properties, and added 5 labels. Right now, obviously the label is nothing but user, and here are all your, you have all the element, all the people name like Sarah, John, Mike, right, David, and Linda, right? So all this information is specifically there. Perfect. So these are the people who are specifically using the social media platform over here, right? Now coming to the next one. For the next one, I will just go back to my post.csv, and these are the information that I posted with respect to the post ID. And here you can see mapping is also there with respect to the user ID. Okay. So let's go ahead and upload this specific file. Now what you do is that just pause the video and just try to see that how you will be able to load this particular file. Okay. Now I'm going to probably write down a query over here. So here I'm going to say load CSV with headers. Okay. Then I'm going to use from, and let me just go ahead and use my URL. Okay. And here is the URL. Please try to understand the syntax. Okay, so the syntax is very much simple. We are just using load CSV with headers from this particular URL. And here also I will just go ahead and use as row. Okay, and with respect to the as row, what we are going to do is that we're going to write this in my next query. I'll say, hey, go ahead and do the matching. And this time when you're doing the matching, please, first of all, let's go ahead and match the user. So I will write u:user. Okay, u:user. And again, I will go ahead and say, hey, use this user ID, whichever property we have actually created. Let me make some space over here so that it looks good. And I'll say, hey, the user ID will try to convert this into integer. Okay, and then we'll say row.user ID. You understand what we are exactly doing? We're matching all the users based on the user ID, which we are retrieving it from row.user ID. Okay. After doing this particular match, what we have to do is that we have to create a relation. Now let's go ahead and create this. I will say, hey, create this user and create a relation, something like dash. And let's keep that relation as something like posted. Okay. So here I'm going to create my relation as posted. And this posted should have a relation with what? With obviously post. So this will basically be my label, right? With post. Let me just go ahead and write post, right? And here we're going to use some properties. like post ID. Okay, what will be the post ID that I have? ID. Okay, it will be again 2 integer, and here I'm going to use row dot post ID because from this row I will be able to access all post ID. So I will just go ahead and write row dot post ID. Right. So let's see what are the post IDs. So I will copy this over here. Right. Perfect. Similarly, the next field that I have is nothing but content. So I'll go ahead and write content is equal to raw dot content. Right. Because that is my row dot content, not raw. Row dot content. Right. So this is what is my content is that. Then I have my user ID. Okay. So let's go ahead and write the user ID, but the user ID we have already done the mapping. So I'll just go ahead and put the timestamp, right? So here, the next thing that I'm actually going to use is timestamp. Now inside this timestamp, I'll use date time, right? So date time is obviously there. See over here itself, because we need to convert that into date time. So here I have a namespace called as date time, and here we're going to just go ahead and write row dot timestamp. Perfect. And then we will close this entire query. Step by step. See, here we are matching with respect to user ID and the row user ID, right? So user ID, this to row user ID. So then mapping is specifically done, and we're creating a relationship called as posted. So once I execute this, here you can see 5 nodes is specifically there. If I click on post, amazing. See, all the posts are there, right? So this is my ID also it is mapped, right? My first post, my timestamp. So Mike has posted this third, and Linda has posted this other post. David has posted this, right? All this information is John has posted this, right? So this posting has been done, and here you can just go ahead and check match p is equal to some blank space, like give nothing over here, and try to see like where is this specific relation. Once I click on this posted, you're able to see this. Okay? Now, let's do one more thing. There is also one called as relation.csv, right? We need to understand who's friends, right? So for this, we need to load this entire relationship.csv file. Again, let's go ahead and write it down. So I'll write load_csv with headers, okay, from my file name. File name is nothing but what is my relationship file. So it is present in this GitHub location. And here also I will just go ahead and create as temporary row. And let's press enter. Okay. Now this is just a simple match query. First of all, we need to match with user ID, with row user ID, then u2 user with user ID 2. See, there are 2 users ID, right, over here. See this, user ID 1, user ID 2. User ID 1 to user ID 2. What type the friends are, right? So this is the kind of mapping that you'll be able to see. So that is the reason we made 2 mappings. One is u1 with user ID, one user ID, and then u2 with user ID, where we are mapping user ID to user ID 2, and then we are mapping this user ID to user ID 1. Okay. Then we are creating this called as create u1 friends relationship, likes relationship with u1 to u2. Okay. So just go ahead and explore this. You will get a complete idea what exactly we have done over here. So once I execute this, so created 22 relationships. This is amazing, right? So if you go ahead and see friends, see nicely all the graph is basically coming. Sarah is a friend of Mike. John is a friend of Mike. Then and remember this user ID and user ID is basically getting mapped, right? 1 to 2, right? 1 to 2 basically means 1 is the friend of 2. So 1 is John, is friend of Sarah. So if you go ahead and see John is a friend of Sarah, and Sarah is a friend of Mike. This entire friend circle is basically getting created. Perfect. So I hope you have understood of probably creating all the tables and how you can basically define all the relationships. Now it's time we start retrieving, let's start from some basic queries. We'll go ahead and retrieve all users. So for this, I'm going to write my match keyword. Let me go ahead and write u:user. Okay, this will basically be user, and let's return u. Okay, so once I execute this, here you'll be able to see that I'm able to get all the users over here: Sarah, John, David, Linda, and Mike. Okay, now the next one, what I will do is that I will retrieve all the posts. Okay, so here again we will use a match query. Let me go ahead and write p::post. Okay, and here we are going to return p. Okay, sorry, we have to use this capital letter. It's good. Return p. So I'm just trying to check which all posts are there. So many different posts are there. Lovely, all beautiful. And this is basically given with the help of this post ID. Okay, perfect. Now let's retrieve a friend of a specific user. Okay, if I say, hey, for this user John, who's the friend? So here what I'm actually going to do, again, I'll go ahead and write my match query. And with respect to this match query, again, I will go ahead and write u is equal to u::user. Okay, and then I will go ahead and use the property name : nothing but John. Okay, so once I do this, and now I need to probably create that relation. The relation is very simple, friend, right? So I will use this. I will write : friend. Okay, and then I will say, hey, give me f user. Okay, I'm just creating this another label. And here, let me go ahead and write f user. This will be another label. This will be another label to distinguish between them, right? And then we are just going to return f.name. So once I do this, you'll be able to see that you'll be getting all the f.names over here. So David, Sarah, Mike, Linda are the friends of John. And if you don't believe me, see David, Sarah, Mike, and Linda. So if I go and click on friend, David is a friend, Sarah is a friend, Mike is the friend, right? And Linda is also a friend, right? All this information is basically getting extracted, and that is how you're able to see to it, right? Now, let's go ahead and see how many, let's see the post made by the friends of a specific user. Okay. So here you'll be able to see that I will go ahead and write my match query. I will say, hey, let's go ahead and create this u label, user. So u is my label. And then I'm just going to write u is just a node. Okay. Name with respect to John. Okay. Now we know that John, first of all, we need to retrieve all the friends, right? So I will go ahead and write friend. Okay. And then I will create another label, f::user. Okay. And I say, hey, let's go ahead with posted, right? So here I'm going to write, it's just a posted one. Okay. I know, see, there will be a little bit of confusion with respect to the queries, but you need to practice these things, right? But this is very simple. When compared to MySQL, I feel still this is very, very comfortable, very, very much easy. Yeah. Then you can go ahead and write p::post, right? So here what we are doing, we are basically matching, first of all, username, who's a friend of the other user, like of the same user, with respect to comparing with all the other users. Then we are basically considering whether they have actually posted, right? So posted is one of the relationship with respect to p is equal to post. Okay. And here I will just go ahead and write return f.name and p.content. It's just like inner queries, right? So now if I just go ahead and execute this, you'll be able to see David has posted San Francisco is amazing. Sarah has posted my first post. Mike has posted beautiful day in Chicago. Linda, love New York and all, right? This is how you can basically do this. But again, here the main aim is not to become pro in Cypher query language. This is just for your purpose to show you, because later on we will be, when we're implementing or when we're creating our generative AI applications with the help of LangChain, right? There we will be using all this kind of queries. Some of the queries we'll be using in order to insert the data and all. So guys, now let's go ahead and see one more example where we are going to find users who likes a specific user post. So here you'll be able to see with respect to the post, right? How many people have liked it, right? 4 to 1, 4 to 5, 1 to 5 like that, right? So we will try to create another relationship with respect to that, right? So let's go over here and let's see how to probably write this. So here I'm going to write a match keyword again, u::user. Okay. And let's say the user name is John. So I'll just go ahead and write John. Okay. And here we will go ahead and write colon posted, oops, colon posted relation. Okay. Then this will be mapped to p colon post, p colon push. And with respect to this, I will also go ahead and specify my likes. So let's go ahead and see with respect to likes, okay? Because we are comparing inside this p post itself, we have specific likes, okay? See, when you give this kind of direction, that basically means we are just trying to find out the relationship, we're traversing the relationship between this user and post. And inside this post, you know that there's something called as likes, right? So we are just going to use a reverse direction, right? Where we are saying this as likes. And this is another relationship that we are trying to create, okay? And this likes will be with respect to another user, I can just consider another user label, right? And then we will go ahead and return l dot name. Along with this, we will also return p dot content. So this way, you will be able to see everything as such. Let's execute this. So it says no changes, no records has been found. Let's again see this. You can see user with respect to name is equal to John, okay, and whatever John has specifically posted with respect to that particular post, and likes has been compared with l dot user over here, and then we are returning l dot name. So right now, no match is specifically happening. So with respect to any John post, I think that this is there. Let's verify the ID itself. Okay, so I will just make sure to copy the same thing. Let's execute it. So it says John posted p post. So John is over here with respect to John 1 comma user ID 1 comma user ID 2, right, with respect to likes. So I think there will be no record that is specifically matching. Okay, let's try one more query over here. Let's count the number of friends each user has. And now I'm going to use this specific query. I'm writing match u colon user with respect to friend f colon user. Again, f is another label. Another node. Return u dot name count f as number of friends. See, all the inbuilt function like how we use in MySQL and all. Similarly, we are able to do this. So order by number of friends describing. So it'll just show you that David has 5 friends, Sarah has 5 friends, John has 4 friends, Mike has 4 friends, and Linda has 4 friends, right? These are some of the good examples that I've actually shown you guys. But again, it is up to you to go ahead and try it out. Again, here the main intention of creating this module is not to become perfectionist in Cypher query languages because obviously the different scenarios, but you can see just the power of this, right? Our main aim of understanding this was that we should be able to work with LangChain whenever we are creating generative AI application. So yes, this was it from my side. I hope you like this particular video. I will be seeing you all in the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to GraphDB with LangChain. Now we will be implementing some amazing projects. Again, we are going to use the Neo4j Aura DB, and we'll see that how with the help of Python programming language, along with LangChain, we can specifically use and create some amazing Gen AI applications. So before we go ahead and start, we need to set up this specific environment. And again, to set up this particular environment, we have to make sure that we have all the necessary libraries. Here, the different kind of Python version I will be specifically using. Okay, so first of all, let's go ahead and create my environment. So I will go to my command prompt, and here what I will be doing is that I will just go ahead and write conda create -p, okay, v Python double equal to 3.12, and I'll give a yes prompt so that it should continue the execution, right? So now here you'll be able to see that in some time my entire VNV environment will get created. Okay, so this is basically getting created. Let it take some time. Okay, and since it is getting created, I will also go ahead and create my requirements.txt. Okay, now in order to work with Python 3.12, we have to install Neo4j, and please be specific with this particular version, right? Because I tried out different version and it was not working exactly when we are specifically working with Python programming language, right? Specifically with 3.12 version. So this was the right combination after a lot of research I saw, and it was probably working in our local. If you are using Google Colab and all, you don't have to probably just use this particular version also. Automatically, whatever is the compatible thing over there, it'll be considering that, right? Now I have this. Along with this, I will also go ahead and install my LangChain. Then I will write LangChain underscore community. Okay, so this is what I'm actually going to use. Not only that, I'll also use OpenAI. I don't require OpenAI, but let's take this. And then I'll also have LangChain underscore Grok because we will be using open source paid LLM models. Open source LLM models, not paid. Then I'll have Python .env. So let's go ahead and install all these libraries. So first of all, I will just go ahead and say, hey, conda activate env. We'll clear all the screen. And now let me go ahead and do the installation of all the libraries. So spelling mistake, it's okay. I will just go ahead and pip install -r requirement.txt. LangChain underscore Grok, it's okay because I made a spelling mistake. Okay, please don't forget to save the file. Okay. So here you can see all the installation will start taking place. So once you do the specific installation, it is also necessary that we will go ahead and create our .env file. So here I'm going to specifically take my .env file, and just to play with some of the things. First of all, I'm just going to go ahead and put my Grok API key, right? So this I will be requiring it so that I can go ahead and experiment with all my different LLM models, right? Different open source LLM models. That is the reason we're specifically using this. Okay. So this was the basic setup. Please make sure that you have this entire this version specifically use it because we will be using this version with respect to the Neo4j or DB, right? Whenever we want to connect with the database itself and try to insert some kind of data and all. Now in my so this was the initial setup. In the next section, we are going to see that how we can go ahead and get started. And again, for this, I've already told you, please make sure that you have the copy of your entire database information. And this I have told you to save it somewhere, right? So this information, please, you really require it because I will be using this particular database information and try to access my DBs, right, for the insertion purpose. So yes, this was it. I will see you all in the next video where we will be continuing the discussion with respect to GraphDB with LangChain. Hello guys, so we are going to continue a discussion with respect to LangChain with GraphDB. Now I will be showing you like what generative AI project that we are specifically going to create with the help of LangChain along with GraphDB. Okay, so here the plan is very simple. Let's say if a user queries, right? Let's say if a user is querying anything, right? Now with respect to the specific query, this will probably initially go to our LLMs, right? My LLM models. Let's consider this is my LLM model. Now this LLM model, what it should be doing is that it should be creating my Cypher query. Cypher query. Let's say if I go ahead and say, hey, who was this particular person who was acting in this particular movie? If I ask that question to my LLM should be able to create my Cypher query. And once I get my Cypher query, it should be able to probably query from our GraphDB database, right? Let's say this is my GraphDB database. Okay. And once it is able to query, right, again, it should probably get the response from this, give it to my LLM model. and based on our prompt, it should be able to give our output, okay, output response. So this is the entire thing that we are specifically going to create. And if I probably consider this entire thing, this block, right? This block where we are specifically using LLM Cypher query, GraphDB. So this is my GraphDB, right? This is specifically called as Graph Agent. But here, instead of only generating a Cypher query, we are also going to use a GraphDB and we're going to query with respect to the specific query that the user is putting. And once we get the output, we should basically be able to combine with the prompt along with my LLM model and get my output response. Okay. So this is the entire project that we are going to develop with respect to our that we are specifically planning in this particular project. Okay. So let's go ahead and let's generate this particular project. So I'll just go ahead and write one, and I will keep this like Q&A, right? Q&A with graph. I will write GraphDB. Okay, so this is done, I guess. Now, the first thing first, what I will do is that inside this folder, I will go ahead and create my experiments.ipynb file so that we get an idea how to probably go ahead and start this. Okay, so first of all, we'll go ahead and select our kernel. Once we go ahead and select our kernel, I am just going to go ahead and create a markdown. Let's say over here, I'm going to use these three codes. Okay, so here we are basically going to build a question answer application over a graph database. Okay, so to start with, the first thing that you actually require is all this information, right? So here, at least you have this URI, username, password, right? Instance ID and instance name is not required, so I will just go ahead and initialize this right over here. So let's convert this into strings. So I will just go ahead and initialize all these things. Or you can also directly put it in your environment variable if you want. Okay, and you can probably read from those environment variables. Okay, it is up to you. So okay, it is saying me to install the IPy kernel. So I will quickly go ahead and open my terminal. I will say, hey, pip install IPy kernel, because that is required when you are probably using Jupyter Notebook for the first time, right? And the environment that is specifically used over here is 3.12. So let's this installation take place. Till then we will just wait, and then once the installation will be completed, we will continue. So here you can see, guys, the IPy kernel installation is done. So I will close this. Now let's go ahead and execute it once again. Now you can see it is connecting to the kernel, and now it absolutely works fine. Okay. Now the next thing is that I will just go ahead and import OS, and we will go ahead and set up all these environment variables, right? So specifically, whenever we set up this environment variable, we are going to set it for Neo4j URI, username, and password. Okay. So this URL, we will try to replace it with Neo4j URI. So let me quickly go ahead and do this. And similarly, we will go ahead and replace this with our username. At least we require this three important information, and this will basically be my Neo4j password. Perfect. So till here, everything looks good. Now, in order to start working, first of all, I'll execute since I've set up all the environment variables over here. Now, the next thing that we are going to do, again, I will go ahead and write from Langchain _ community. Okay. Dot graphs. So Langchain community actually provides this library in graphs, which is nothing but it is a class which is called as Neo4j graph. Now, this Neo4j graph actually helps you to connect to your DB with the help of this information that is Neo4j URI, username, and password. So here I'm going to go ahead and create my graph, and here you have this Neo4j graph with URL is equal to. So first information that I want is, even though I've actually set up my environment, you can also directly pass all these values over here. So let's go ahead and pass it. So Neo4j URI. Then along with this, my second parameter is nothing but username. So I can go ahead and write Neo4j username. And the third one is something called as password, whatever password we have. And here also I will just go ahead and write Neo4j password. So this way also you will be able to initialize your graph, which is basically connected to your entire database, right? So once you execute this, here it shows that hey, Langchain _ community.graph Neo4j _ graph at the specific memory location, the object is basically created. Now let's see for which dataset we are going to specifically work. Okay, so dataset that we are going to work is nothing but it is with respect to movies dataset. It has some of the information like which actor has probably worked and all, right? So here let's see this particular dataset that we are going to use. So I'm just going to close this. Okay, so here is the dataset. So here you can see I've opened this movies _ small.csv file. It is available in this GitHub location. It has information like movie ID, release title, actors, directors. See, directors can be many. So you can see over here you have like Jim Varney, Tim Allen, Tom Hanks, Don Nichols, right? So Don Rickles. Then you have genres. Then you have IMDb ratings, right? And with respect to genres, right? Here also you'll be able to see that it has adventure, animation. So it has that pipe symbol. Now what we're going to do is that we're going to go ahead and read this entire URL. Right now, I've already shown you how to probably go ahead and read this particular URL. So first of all, we'll go ahead and create our query. Okay, so let's go ahead and create a query. So I'll say, hey, this is my movie query, and this time I'm just going to use triple quotes. Okay, so this will be my triple quotes. Here I'll say, hey, let's go ahead and load CSV. Okay, CSV, and here and I have to also make sure that I provide with headers from, because this is the query. Initially, we need to have some data, so that is the reason I'm writing this Cypher query language, right? And then I will go ahead and put this entire URL. Okay. Now from this, I will make this as row. Okay, so it will be, when I say as row, it is going to take with all the headers, right? So as row, we will be taking all the row, right? And then we will also make sure that we will merge this. Okay. Now see, merging is very much important because there are so many features that is available. So first of all, I will go ahead and create a node with movie M, right? M, and this will basically be my label. So and please make sure that whatever things I'm writing, you follow that same steps, right? Inside this movie, you will be having two important features. So if I go ahead and show you, so this is nothing but movie ID, right? So in order to access this, I will just go ahead and create my property which is called as ID. So here I'm going to basically write ID : right? Row dot movie ID. Okay. So but inside this movie ID also you'll be able to see that along with this movie ID. So if I go ahead and see over here, you'll also be seeing that same for that particular movie ID, there are information like release titles, actors, like IDMB ratings and all, right? Now obviously when I'm using this released, let's say title is also there, right? And IDMB ratings are there. Remaining all are like, they are like actors also, there will be many actors, directors also, there will be many directors. So first of all, let's do one thing. Let's take all the single fields and probably create that many number of features in short, right? Or property keys. So I'll go over here. Now see this, what I will do. I'll say, hey, go ahead and set all these features, that is m.released is equal to date. We're converting this particular value row.released to date. Okay. And then I have this row.title, m.idbm rating to float, row.idbm rating. Okay. So all these things are done. Similarly for directors, we will go ahead and use for each loop. So here you'll be able to see in Cypher query, you also have this for each. Director split row.director with this pipe symbol. Then you have this p person name is equal to name trim director. Then merge p director with respect to this particular m value. Okay. So this all the directors we are going to put inside our person node itself, right? Or person entity, which we have actually created. And we're also going to create a relationship with respect to p with movies, right? With all the movies information. Okay. Then similarly for the actor also we will be doing, and we also need to create another relationship that is called as acted in. Okay, so here directed, here acted in. Okay, and again we are going to basically do trim.actor. We are using this pipe symbol to separate all the actors from that movie. Okay, and similarly you'll be able to also see that there will be a genre field, right? And genre also we are using a pipe symbol. So again, genre is split row.genres. We are using this pipe symbol again. We are saying merge G genre name trim.genre. Then we are merging this by creating a relationship over here with this G, right? And G is nothing but genre. So movie with genre is basically created as a relationship. Person with movie, we have created a relationship like actor. P directed with M, we have created like this. Okay, so this is the query to probably load this entire data set. So I will go ahead and execute this. So if you go ahead and see my movie query, okay, so here you'll be able to see this is my entire query, right? Perfect. Great. Now what I'm actually going to do, I'll just go ahead and write graph.query. Okay. So if you go ahead and see this definition, the cipher query to execute, whatever query that we are going to execute over here. So let's go ahead and write this movies query. Okay. So once I execute this, here you'll be able to see I'm getting some blank. Okay, but no worries. Let's do one thing. Let's take this entire graph and refresh its schema. Okay, so I'll go ahead and write refresh schema, and we will go ahead and print our graph.schema. Okay. So here you can see all the information, right? Node properties, this is all the previous information that I had uploaded, right? Now you have movie, user, post, this, right? Relationship also you can see. Person acted in movie, directed in movie. These all are my previous information that I had, right? Now let me do one thing. Let me just go back to my Neo4j DB. So let's reload this. I don't know whether we will be able to reload this or not, but it shows disconnected. No worries. I will go to my homepage of Neo4j. Okay, so let me just go ahead and write Neo4j or RDB, and I'll go ahead and click this. Start free. It'll tell me to log in. Okay, so I've logged in over here. I'll go ahead and open it. And it'll tell me to connect. Let's say whether it connects or not. These are all my queries that I've actually created, and it has also been attached, right? Now let's go to the database. Here you can see in genre. So if I go ahead and click this, see, amazing graph is basically getting created. That basically means my entire data has got just inserted, right? Romance, drama, Father of the Bride Part 2, it is a comedy, genre comedy, Toy Story is to comedy, it is fantasy, it is having this animations and all, right? Amazing, right? And if you go ahead and see acted in, right? This is a huge database again. So with respect to acted, you'll be able to see over here. Let's see with the acted in, I'm just going to click it. See, Forest White Ticks, acted in Species, Burnt by Nikita Mike, I guess they have acted in different movies. Client Eastwood, this Jolinsky, French Twist, right? So this is the kind of data that we have already there. Okay, along with this, you know that we have also created directed, right? So if I go ahead and click on directed, there's so many directors, see, Oliver Stone and all. So with respect to person, how many persons are there? If I want to double click this, it'll show a relation. It has directed Heat, John Lester, it has directed Toy Story, right? So this is a simple way of just showing you that how with the help of using this graph.query function, right? We use just this graph.query to probably insert this entire data, right? And it has executed the entire query itself inside the graph database. Now, this was the basic fundamental of inserting. Now in my next video, we'll proceed further, and then I will try to ask any kind of questions with the GraphDB with the help of LLM, and I think I should be able to get the answer. And that is what we're going to see in the next video. This was it. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to GraphDB with LangChain. Already in our previous video, we have seen how to insert this specific data, right? Now let's go ahead and see that how we can play with our LLM model. So first of all, again in this, we are going to use Grok API. So first of all, I'll go ahead and write import OS. And along with this, I will also say from .env, import load_.env, and we will go ahead and initialize this. Now quickly, I'll go ahead and write grok_API, and let me go ahead and use get os.getEnv with respect to our grok_API_key. Now, once I get this grok API key, okay, so grok API key over here, let me just create this variable as grok API key. Now we will just go ahead and import, because we need to load our model, right? LLM models. So I'll say, hey, from LangChain_grok import chat grok. Okay. Now let's go ahead and create my LLM model, and here I'm just going to go ahead and write chat grok. And first, I have to initialize my grok API key itself is equal to grok API key, and then my model underscore name is equal to gamma. Let's say I'll grok API key. Why this is highlighted in this way? It's okay. We'll run this. Okay. So 9B, and I'm just going to use this specific model, gamma 2 model, which is the new model over there, right? And once I initialize this, this will basically be my LLM model. So yeah, my entire LLM model is ready. It has this. It is using this model called as gamma 2, which is an open source model with this particular secret key. Okay, perfect. Till here, everything looks good. Now it's time that see what our plan was. Our plan was like whenever user probably writes a query, it should probably go to the LLM model. This LLM model should create my cipher query, and further by using the cipher query, I should be able to query from my graph database and get the output. And along with the output, I should be able to get back the response. Okay, this entire thing I really want to create. Now for this, what I will do, I will quickly go ahead and first of all create a chain. So I will say, hey, from LangChain.chains, I'm going to import graph Q&A chain, graph cipher Q&A chain, right? So I'll just go ahead and use this cipher Q&A chain, which will actually help you us to work with this. Okay. Then inside this chain, I'm going to initialize this graph cipher Q&A chain, and here we really need to pass some information. And there is a function which is called as from LLM. Okay. Now when you're using this graph cipher Q&A chain, the first parameter that we need to pass is our graph, right? So graph, obviously this information is over here. This is my graph, right? With respect to this entire schema, and because I need to query this graph itself, right? And then I have my LLM model. Okay. LLM model. Then finally, I will also go ahead and write verbose is equal to true, so that I'll be able to see that how the conversation is basically happening. Okay. So this in short is about the chain. Now if I go ahead and display the chain, so here you'll be able to see this particular chain, right? So prompt template over here by default, you can see, right, the graph cipher Q&A chain. I did not have to separately specify my prompt template, because if you go forward, right, there is a prompt template that is internally using this LLM chain, and here you can see prompt template is the input variable is question and schema. I need to pass question and schema. Schema is getting passed through this particular graph, right? And then the task is nothing but generate cipher statement to query a graph database, right? Use only the provided relationship types and properties in the schema. Do not use any other relationship type of properties. So this is the default prompt that's created with this cipher Q&A chain, right? So this work has already been done by LangChain itself. Now I will just go ahead and write response is equal to use this chain, and we will go ahead and invoke. Now once you're invoking over here, right, I will just go ahead and write query, and let me give the query over here. I'll say what was the, or I'll say who was the director director of the movie Casino. Okay, so this is what I really want to check. Now let's go ahead and see the response. So once executed, okay, I'm getting an error. Response. Let's see. So over here it shows who was the director of the movie Casino, Martin Scorsese. Okay, so I hope this is absolutely right. So let's see. First of all, I'll go ahead and click on movies. So I'll say hey, n is equal to movie colon or movie is equal to. I'll go ahead and write Casino. Movie colon should be what? Let's see. This query is wrong. Let me just see this. Okay, so acted in somewhere Casino. Let me just directly see from this. So if I go ahead and write, so here you can see this information, right? Martin Scorsese. Okay, so this is the director specifically for the Casino movie. Okay, and if you say again, I don't want to become a proficient in probably seeing how this or learning this particular queries. Okay, but I would definitely be seeing that. Okay, is my LLM model able to generate the query, and am I able to get the answer? The answer is very simply yes, right? So this is the query that has got created. Okay, here I have the answer. Okay, I don't even have to probably work on this. So let's execute this. So here you have this, and here is your answer, right? Martin Scorsese. Okay, so my entire query has been generated. So this was what I had to write. Okay, I forgot it, right? So I need to write title colon Casino. I need to use this property keys, and I'm writing directed with respect to p.person, and we are returning the name. Okay, so yeah, this was a very simple way of basically executing this. Okay, let's ask some more question. I'll go ahead and say, hey, what was the entire cast? I'll just go ahead and ask this question. Okay, all right, what was the entire, or who are the actors? Okay, so let's respond this. Robert De Niro, Joe Pesci, Sharon Stone, James Wood, right? And this is the query that has got created. And here you can see full context also it is able to generate, right? With all the information that you have, and you're able to see this, right? This looks really good. And just by using some line of code, we were able to create all these amazing things, right? And we are also able to probably see the entire schema along with this. We are also able to query it, right? So whatever the queries that we have specifically used, this we are using with the help of chain itself, graph Cypher Q&A chain. Okay, and by just this, seeing that you can see how powerful this is, right? So I hope you like this particular video. This was it from my side. Go ahead and try it out and just try to see whether you're able to get the queries or not. Okay. Yes, this was it from my side. I will see you on the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to graph database with LangChain. Already in our previous video, we saw that how we can quickly generate a simple Q&A where we are specifically chatting with graph database itself. Here, the concept was very simple. With the help of LLMs, we were creating our entire queries, right? Cypher queries. And based on that, we were executing it and we were retrieving the results from the graph database. But understand, there may be scenarios where the LLM may not perform well, with respect to different complex kind of queries. So it is better that we try to improve this graph database query generation mechanism, right? Now here, what we will be doing is that we will go with some prompting strategies, which will try to improve the graph database query generation. So we will largely focus on methods for getting relevant database specific information in your prompt. Okay. So for that, I will just go ahead and quickly, let's say that I'll go ahead and create one more file. And here I will just go ahead and write prompt strategies, right? IPYNB file. So here we're going to specifically go over here. Let me go ahead and select my kernel. Okay. Now, as usual, this will be very much common. So here I'm going to use the same import OS. I will copy and paste it over here. I could have probably done in the same notebook, but let's go and do this. So let's delete this. Let's create a code over here. Let's paste it. And again, I'll paste this one. And similarly, I will go ahead and set up my environment right over here. Right now, the next step, quickly, what we are basically going to do. Again, you remember this is the graph queries. If you probably see, we have already uploaded this entire graph, right? Just by executing this graph.query. So we know that this data is already present. Okay. Now, what we are going to do over here is that we are going to develop some prompting strategies. Now, before that, I go ahead and develop these prompting strategies. Let's go ahead and quickly include all the LLM models that we have. So here are this line of code that I'm just going to copy it and paste it over here so that I'll be able to access my LLM models, right? So let's quickly do this. Okay. So I have my LLM model. I'll go ahead and execute this. Okay. This we really need to go ahead and do it. Okay. Now, you will be seeing that we will try to use some kind of prompting strategies. Now, what are the kind of prompting strategies that we are going to use? I will just have a go ahead and have a look. Okay. Now, let me do one thing. Let me also use this Cypher QA chain. Okay. So I will use this Control C, Control V. Okay. And here I'm just going to create this specific chain. Let's go ahead and create this generate Cypher QA chain. Generate Cypher QA chain from _ LLM. Okay. And here the first parameter is nothing but graph. I'll be using the same graph. See, I also have, so here I'll also be giving my which LLM model I'm actually going to use. This also has a parameter which is called as exclude types. Let's say you want to specifically exclude kind of field and do not want to search based on that. Let's say I'm going to use genre, right? So I'll be using this and telling basically do all the searches by excluding this particular field, and I'll keep the verbose equal to true. Okay. So once I go ahead and execute, this will basically be my chain. So graph is not defined because I've not created the graph, obviously for good reasons. So because I've not inserted any data, right? So I will try to just insert this entire data itself, right? So here again we will go ahead and use the graph. Okay. Perfect. Over here, and again if we just go ahead and write graph.query with movie query, we will be able to insert the elements, but it is just going to probably, okay, I've also initialized this graph, right? So if you remember, where is the graph? Graph.query. So graph should be on the top. Here is my graph. Okay, so I will just go ahead and quickly initialize this so that it will be able to communicate with the database. Okay, so this is my graph. I'm just trying to connect it, and then we will go ahead and execute this movies query. It is just trying to insert again. Okay, you can probably go ahead and see this, right? All the steps are same. Nothing is different. We're doing the same thing over here with respect to this. Okay, perfect. Now let's execute this. So this is my graph Cypher QA chain, and I have all these things, right? You can also go ahead and see the entire chain.schema. Okay, if you want, if you're interested, and you'll be able to see, hey, what kind of schema it is basically holding, right? And if you want the entire graph schema, that also you'll be able to execute it. So here you can see node properties are the following: CEO, this, all there, and what all nodes, like what all relationships, everything you'll be able to see it over here. Okay, now let's include some of the natural language questions and we'll try to convert that into a valid cipher queries. Okay. So obviously with respect to prompting strategies, we'll give some of the examples. Now let's take some of the examples. Now this is a very big list. Okay. Let's say one of the question is like, how many artists are there? Okay. So we are matching A with person acted in movie and we are returning this count distinct A. When I say artist, I'm specifically talking about actors. Okay. Then which actors played in the movie Casino, right? So here if you see, right, if I just go ahead and probably now previous one, if I just go ahead and ask the same question. Okay. I'll say the same question over here. How many artists are there? Okay. So here you'll be able to see what kind of answer we will be getting. So if I just go ahead and execute it, here you can see match P person, count P as artist. So 1240 artists. But when we talk about artists, we're specifically talking about actors, right? So here we are just seeing that, hey, which all person has acted in the movie. So whenever we try to give this kind of queries, obviously we're not going to get that exact answer what we are looking at based on the natural language processing text, right? So here what we're going to do is that we're going to define some prompting strategies where I will be writing in the form of question and queries. So you can see how many artists are there. This is the query. Then there's another question that says which actors played in the movie Casino, right? So we have matched that with movie title is equal to Casino, acted in A, return A dot name. So we're giving some examples over here with respect to different questions and cipher queries. So how many movies has Tom Hanks acted in? So let's try to experiment with this also. Okay, so this is one. I'll copy this. We're just using the previous strategies over here directly by using the LLM model. How we will be able to get the response. Let's see this. Okay. So if I just go ahead and execute it, and let's see the response. So acted in movie, it shows 3, right? And obviously the result may be right because the LLM is able to understand. But by using these prompting strategies, the LLM model will completely get an idea like whenever we are asking this kind of questions, right? So here also it shows list all the genres of the movies in the list, right? And here you have this entire query. Again, you do not run, you do not understand. If you're not able to understand this particular query, it is fine. So at the end of the day, your LLM model is generating. This is what we have actually created with respect to the sample queries. So you can go ahead and have a look with respect to all the other queries. Which directors have made movies with at least 3 different actors' name? John, right? So this kind of queries are complex queries. So we are trying to match this director with this particular actor in this, and we are trying to match with the person where A dot name starts with John, with D count distinct as A, John counts where John counts is greater than or equal to 3, right? So this kind of complex queries we are trying to just make a list of it. Okay, that is the pure idea about it, right? By using these prompt strategies. So once we go ahead and execute it, so this has got executed. Now what we are going to do is that in LangChain itself. So if I go ahead and write from LangChain underscore core dot prompts, right? I'm just going to import few short prompt template, okay? And then we are just going to have this prompt template because I have to probably create my prompt template also. So here I will say, hey, this is my example prompt, and let's go ahead and define my prompt template. And here I'm just going to use dot from underscore templates, okay? And here we're basically going to use this important things. One is user input, okay? And then we're also going to have this entire question, okay? And I'm going to say, hey, by just giving this question, I should be getting my cipher query, and this we will give another input parameter which is called as query, okay? Now, see, this is fine, right? You have an example prompt template is over there. Now, why this few short prompt template will be useful? So now let me just go ahead and create my prompt. I will go ahead and use this few short prompt template. And inside this, let me go ahead and give some examples. So here I will be saying, hey, examples is equal to examples of, let's say I will go ahead and take some 5 examples, the top 5 examples, okay, from here, not all, but I'll give some sample of 5 examples. Then I will say, hey, use this example prompt, okay, and this will basically be my example prompt, okay. So here what we're doing is that inside this prompt template from prompt template, I'm giving this user input questions over here, right? So here you can see that I'm giving some examples over here, and I'm also providing this particular example prompt. Okay, now see what will happen. You'll be able to understand. I will create a prefix. Okay, the prefix will say what the LLM model has to do. So I'll say, hey, you are a Neo4j expert. Okay, then I'll say given an input question, create a syntactically very accurate cipher query. Okay, so I'm just going to write cipher query. So once I probably create this, so this basically becomes my prefix, right? And now here itself, with respect to the suffix, so there's also one more parameter that we will be using. I will just provide this. Hey, this is the user input, this is the question, this is cipher query that we're getting, right? This query needs to be supplied, right? And with respect to this, you know that the input variables, what are input variables I'm using over here? One, I can definitely see something called as question, okay? The question. And second, we will also be giving schema. Now, why do you think we have to give schema over here? Let's execute this, okay? So let's make a new code cell and let's see the prompt. So now, I will just go ahead and execute this. Let's see the prompt. So now, with respect to the prompt, you can see input variable is this. How many artists are there? See, this is the list of things it has made. So few short prompt template. When we give the specific examples, you have considered that how many examples is there? The top 5 examples, right? Right. Then prefix is basically added, okay? And then suffix is also added, right? So you are a Neo4j given an syntax. I have to probably use the spelling correct. Syntactically. Okay, perfect. Very accurate cipher query. So this is your prefix. This is your suffix. Suffix is also added, and here you can see that your question is going right. All the other information is specifically going. So this looks very good, right? It's perfect mostly. Now let me do this thing. Okay, I'll just go ahead and ask this particular question, and here I'm giving some kind of schema. Okay, schema like foo. Okay, just take as an example. Here I'm actually going to give a schema. So it is first of all going to give me a question error saying that key error questions. Okay, so questions is there? A question is there. Let's see. Print format question. How many artists are there? Questions. Okay, this should be question. Okay, perfect. Now let's execute this. So here you can see you are a Neo4j expert. These are my user inputs. Everything is visible over here. How many artists are there? And here you are specifically getting the cipher query, right? So all this information you are able to see it, right? And through this is your entire information with respect to the things that we have given over here in a few short prompt template. But now it's time that let's go ahead and execute this and see. And then you'll be able to understand that how this will specifically work with graph cipher QHN. Okay. Now my LLM model is obviously there, right? So you have your LLM model. So my LLM model is nothing but this one. Let's see. Okay. Now at least you should be able to get a good accuracy. So this is my LLM model. Okay. I will go ahead and create my chain. Okay. Now chain will be nothing but graph cipher QHN. Here I will say, hey, dot from underscore LLMs. The reason why I'm initializing this because my prompt has been changed now. So I'll go ahead and write graph is equal to graph, LLM is equal to LLM. And now I'm going to use my cipher prompt. See, before inside this chain, when we created this chain, we did not give any prompt, but now we have to give some cipher prompt. Now cipher prompt is nothing but we will give this particular prompt, which is my few short prompt template. This is just to give an LLM some ideas about how what kind of questions we're asking and what kind of cipher query has been generated. Okay, and then finally I will go ahead and write verbose is equal to true. Okay, So once I execute this, so once we have executed this chain, we have our chain ready. Now we will just go ahead and take some of the examples. Okay, let's say I'll go ahead and list all the genres of the movie, so and so. And I've just taken the top 5 queries. You can take any number of queries in your few short prompt template. Okay, so I'll just go ahead and write chain.invoke, give this entire statement, and it says this match is not happening. Let's see why this match is not happening. Okay, we'll execute this. Okay, Schindler's list. Okay, Schindler's list. If I remove this particular list, okay, there's no matching records. Let's see, we're not able to get any information. But I will try like this. How many artists are there? Which actors played in the movie Casino? Okay, let's try this one, and we'll see whether we're able to get some kind of response or not. So here I'll go ahead and execute it. So here it shows Robert De Niro, Josh Pesci. This is coming as right. Okay, let's see some more examples. How many movies Tom Hanks acted in? Okay, so I will just go ahead and search for it and paste it over here. Chain.invoke, and I will write this particular query. So here you can see count is 3, but I don't know the answer. Why? Oh, return M. So count is 3 over here. This query is basically getting matched. Let's execute this one. Here you can see the count is 3. Okay. But when we try to ask this in our prompt template, what was the answer that we are getting? Okay. So here also the same type of query is generated. Okay. So let me go ahead and execute this. Match. Okay. This query is wrong. That is the problem, right? This was the problem. So I'll go ahead and execute this. Remember this. Okay. This was the right thing. But you can see, right? It has been able to generate perfectly over here. So I'll just remove this. Okay. Double titles were used over here. I'll just go ahead and use this like this. Yeah, perfect. But we need to think over this. Why this had actually come as count of M is equal to 3. Okay, how many movies acted in? Tell me the number. Okay, I'll just go ahead and execute this. Let's see. I don't know the answer, but it is able to provide the full context. Okay, we really need to see to this why these things are happening. Okay, but let's try to ask one more question. Provide tell about actors or provide display the actors who acted in multiple movies. I think now it should be able to generate this. Okay, where size current generated statement is not valid. Okay, cipher. Let's see what query this is. Again, these are the problems that usually happens, right? And here you can actually see what all problems we are getting. Size of this one, where size of A pattern should only be used. So this is basically generated by the LLM model, and this is one of the disadvantage that you can see. Display all the actors, or I'll just say actors, and here it shows size of A. I don't know, actors who acted in multiple movies. I don't know why the size of A is basically taking. So these are the scenarios where your LLM model can also go wrong. Okay, but no worries at all, because we also whenever we create some kind of applications, not everything is perfectly right. So these are some of the examples that you can actually check it out. But yes, I hope you got an idea with respect to the prompting strategies. But just go ahead and check it out. But I just want to keep this error like this so that you'll be able to see it. Okay. So yes, this was it from my side. I will see you all in the next video. Thank you. In this video, we're going to talk about quantization. Exactly, is quantization we're going to discuss. We're going to discuss about full precision, half precision, and this is something related to data types, like how the data is stored in the memory. When I specifically say data in LLM models, I will talk about weights and parameters, right? Because at the end of the day, LLMs are also deep learning neural networks in the form of transformers or BERT, right? Then we're going to discuss what exactly is calibration. This is also called as like calibration in model quantization, right? We're going to also make sure that we're going to see some problems, right? How we can actually do calibration. Then there is different modes of quantization, right? First of all, I will explain you the definition, then only you'll be able to understand. In modes of quantization, we're going to discuss about 2 types. One is post-training quantization and quantization-aware training, right? So these all are very important in terms of fine-tuning techniques. Now let's go ahead and talk about quantization, and we will try to see the definition, right? Quantization, okay? Now, if you want to really understand the meaning of quantization, it is better to write a simple definition for it. Okay, so quantization basically means conversion from higher memory format to a lower memory format, right? Now, I've written a very generic definition what exactly quantization means. It is nothing but conversion from a higher memory format to a lower memory format. Now, when I say higher memory format, let's consider any data, right? And if I probably consider any neural network, okay? So let's say if I have neural network, right? And when we train this neural network, right? All this neural network are interconnected. At the end of the day, what are the parameters that is probably involved over here? It is nothing but weights, right? We specifically have weights. Now, weights are usually in the form of metrics, right? Let's say that I have a 3x3 weight. Okay, I'm just taking as an example. In one of the layer, I have 3x3 weights. And over here, every value, right, is probably stored in the memory in the form of 32 bits. Right, 32 bits. We also say this bits as we also denote it as something like FP32. What exactly is FP32? So FP32 basically means I can also consider it as, see, FP full form is not floating point. Okay, but I'm just writing floating point 32 bits. Right. When I say FP basically means it is nothing but full precision. Right, full precision or single precision. Okay, so this is the definition that is probably given. Right, but in short, this is like a floating point number. Okay, so over here, let's say my number is somewhere around 7.23. Now this number is stored based on 32 bits in the memory. Right. Now, understand when you have a very big neural network or you have LLM models, right? As you see different LLM models, right? Parameters keeps on increasing, right? Some may have 70 billion parameters. If I probably consider Llama 2 with 70 billion parameters, that basically means it has 70 billion parameters in terms of weights and bias, okay? Now, it is not possible for me to, let's say I want to use this particular model, and I want to probably do some fine tuning with respect to the normal GPU that I have, right? And let's say I have a very limited RAM in my system. Let's say the RAM I have is somewhere around 32 GB, right? I cannot directly download the specific model and put it in my RAM itself, right? Let's all load it in my VRAM that is available in the GPU, because GPU also has some limited RAM, right? And it is not possible. You cannot directly download it. Obviously, it will require use space. The other way is that, yes, I can probably take a cloud space somewhere. Let's say in AWS. I can create my instance. I can say, hey, give me this much RAM, 64 GB RAM, and I probably want this much GPU. And then I will try to load the model over there. That you can do it. But over there, what is basically happening? Lot of cost is involved, right? Based on the resources. The cost is involved, right? So in this scenario, and why this 70 billion parameters happening? Why this model has a 70 billion parameter? Because every weights or every bias that is available in this, this may be getting stored in 32 bits. So what we can specifically do is that we can convert this 32 bits into, as I said over here, see, conversion from a higher memory format to a lower memory format. Let's say I can probably convert this 32 bit into int 8 and then download the model or then use the model, right? After doing this, what will happen? Within my system, I will be able to inference it, right? Obviously, for fine tuning, if I want to fine tune it on a new data set, I will obviously require GPU. But if I consider with respect to inferencing, it becomes quite easy because now all my values that are stored in the form of 32 bits, it will be stored in the form of 8 bits. So what we are specifically doing over here, we are converting from a high memory format to a low memory format, and this is what is called as quantization. A very important thing. Now, why quantization is important? Because you will be able to inference it quickly. So inferencing basically means what? If I have an LLM model, if I give any input to that, I should be able to get any output, right? I should be able to get a response, right? Now, when I give any input, all the calculation with respect to different weights will happen, right? And obviously, if I have a bigger GPU, this inferencing will quickly happen, right? But if I have a GPU with less cores, let's say, then what will happen? This calculation will take time. But if I convert my 32 bit to 8 bits, right? Every weights are basically converted into 8 bits. Now, just imagine the calculation. Will there be a difference? Yes, it will happen a little bit much more quicker. So quantization is very much important for inferencing. And some of the examples that I can probably talk about is that, and obviously you may have heard about this. It's not like only an LLM model we specifically do, right? In different computer vision models and NLP models also. But if you think that there's a lot of weights that is involved, and all these weights, if I want to quantize it, right, I can actually do it, right? Now this inferencing, let's say I want to use a specific deep learning model in my mobile phone. So in my mobile phone, if I want to use it, right, in a specific app, then what I will do? I will try to quantize, right, whatever deep learning model I created from 32 bits to 8 bit, and then I will try to deploy it in my mobile phone or any edge device. Any edge device, right? It is not possible that you can probably deploy this big model over there. Right? It is not possible. So and so many parameters. So what we do, we basically perform quantization. So I hope you are able to understand over here. Quantization is nothing but we are trying to lower down the memory, right? With respect to any weights that we have, like from 32 to probably int 8, or let's say FP16. We can also say FP16, right? Let's say if I have an FP32 bit that is specifically required to store any information in my memory, I can also convert this into FP16 bit. This is also quantization only, right? Usually all these values are stored in floating point, right? We specifically say this FP32 bit, we say single precision or full precision. We for FP16 bit, if I'm trying to convert like this, it is basically called as half precision. Right? So you should be able to understand all these technical terms, right? And in short, these are nothing but these are floating point numbers, right? Now similarly, in TensorFlow also you'll be able to see. When we probably work with TensorFlow, you'll find TF32 bit, right? The data types, the numbers are stored in this particular format, right? And it is important, okay? This all our terminologies that are super important. But I hope you got an idea. What is the main aim, what is the main motivation out of quantization is that if I have a bigger model, I should be able to quantize it and make it as a smaller model so that I can use it for my faster inferencing purpose, both in mobile phones, in the edge devices, let's say in even watches, smart watches, I want to use it over here. I can actually do that, right? Now, if I talk with respect to LLM model also, with the help of quantization, see, once we compress this particular model, right, later on, we can also perform fine tuning, right, fine tuning. But here, there is one disadvantage. When we quantize, right, when we perform this quantization, since we are converting from 32 bits to int 8, let's say as an example, there is some loss of information also. And because of this, there will be some loss of accuracy. Now, how to overcome this? We will talk about it. There are different techniques how we can specifically overcome it. But I hope you got an example. What exactly is quantization? What is full precision, half precision? Half precision example is something like this. Now, let's talk about what exactly is calibration. Now, calibration basically means how we will be able to convert this 32 bit into int 8. Like, what is the formula? What is the mathematical intuition that is specifically required? Let's go ahead and discuss that. So guys, now let's go ahead and try to understand how to perform quantization. And this is super important in terms of mathematical concept that I'm probably going to talk about. Because with the help of TensorFlow, just by writing 4 lines of code, I will be able to perform quantization. But it is important, you should know that how you can actually do it manually. Whenever I talk in terms of what are the types of quantization that we have. So we have two different types of quantization. One is symmetric quantization and one is called as asymmetric quantization. Now just by showing you an example, you will be able to understand what is the exact difference between them. Okay, let's say I have a task, and this first task that I am probably going to talk is with respect to symmetric. And understand, I hope in deep learning you have heard of something called as batch normalization. So if you have heard about this batch normalization, so batch normalization is a technique of symmetric quantization, right? So every time you'll be able to see that whenever we do forward propagation, backward propagation, between all the layers we apply batch normalization so that all our weights are zero centered. That is near the zero, and the entire distribution of the weights will be centered near zero. Okay, so batch normalization is one technique of symmetric quantization. So let's go ahead and see one example. So this will be my first example over here. I will go ahead and write it down, and now you'll be able to understand it how symmetric quantization is basically performed. What is symmetric quantization? You have understood from higher memory format to lower memory format. We'll try to convert. Okay, so here we're going to understand the mathematical intuition. So let's go ahead and talk about one technique which is called a symmetric unsigned int 8. Okay, quantization. So we will see this technique first. Now here, what is our main aim? Let's say I have a floating point number. Okay, so let's go ahead and write it down. Let's say I have a floating point number between 0 to 1000. Now just imagine that these are my weights, right? Whatever matrix weights I have, my values ranges between 0 to 1000. Let's consider in this particular way, right? And this is, let's say, these are the weights for my larger model. Okay, larger model. Okay. Now one very important thing that you really need to understand, right? When I talk about any larger model, let's consider any LLM model. Okay, so in LLM model you have a lot of parameters. Let's consider this is one kind of LLM model. Now, when I say all these weights are there, this may be getting stored in 32 bits. Okay. Usually, what will happen, guys? The weights will not be in this range also. Okay. It will be in the minimalistic range. So I will just consider this as some numbers. Okay. So that you don't get confused with respect. These are some numbers. I will also not consider the LLM model over here. And let's say these numbers are stored in the form of 32 bits. Okay. Now my main aim is to convert this into unsigned int 8. That basically means 8 bit. Right. So 8 bit basically means what? 2 raised to 8 is how much? 2 raised to 8. But when we say U unsigned, that basically means my value will be ranging between 0 to 255. So I want to quantize from this value to this value. Okay, what is my aim? I want to quantize my range of values between 0 to 1000 to 0 to 255. Okay, this is what is my aim with respect to this. Okay, so this is what is my target. Now let's see. Okay, so if I probably draw just a real points, and the same thing we will do with the weights over there, whatever quantization process we are specifically doing. Let's say I have values between 0 and this is basically 1000. Okay, then what I will do over here, I want to convert this into again 0 to 255. Okay, now let me talk about one very important thing, guys. Whenever we have any, let's consider this one. If we have this single precision floating point 32, right? If you have this number, how this number is stored, do you know that? The one bit will specifically be used for signed or unsigned values, right? Let's say positive or negative. If positive is there, then it will be +1. If negative is there, it will be -1. So all the values are basically saved between 0 to 1, right? It can be 0 or 1, okay? Then the next 8 bits are stored for exponent. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is for sign. This all numbers that you see, it is basically stored for exponent. This is how it is stored inside the memory. And remaining 23 numbers, all these 23 bits will basically be saved for mantissa. This is specifically for the fraction. So if I have a number which looks like 7.32, now 7.32 is a number, it is a positive number. So for my sign bit, there will be a positive value, let's say 1 over here. Then this 7 will be probably put up in this 8 bit, and remaining 0.32 will be put up in this mantissa, right? So this is how the numbers are basically stored in the memory, right? If I consider an example with respect to FP16, right, half precision floating point 16 bit, then you'll be able to see there'll be 1 bit for the sign number, there'll be 5 bits for the exponent. We basically say exponent 1, 2, 3, 4, 5. Let's consider this 5. Let's draw till here. Okay, so this let's say that this is 5. 1, 2, 3, 4, 5. Okay, so this will be 5, and remaining 10 bits will be saved with respect to mantissa. So we basically say this as a fraction, right? Anything that comes after a decimal, right? And this is how you will be able to see this will take less memory, this will take high memory, right? Now what is our main aim over here? I already have a 32-bit number. I need to probably convert this into a range of unsigned int 8. Unsigned int 8 basically means I will not take any negative numbers. It will be between 0 to 255, right? This is what I really want to do. Okay. Now for this, what will be the equation? And I hope you have heard about something called as min-max scalar. I've repeated so many times this in my machine learning sections also. So any number that is over here, how will I be able to convert from this floating point to this unit int 8, right? Unsigned int 8, right? How I will be able to do it. Now for this, let's go ahead and calculate it and what equation is specifically required. Okay. So that basically means over here what we are going to do. 0.0 will be converted into a quantized value of 0. Okay, not 0.0, it will be 0. And similarly, 1000 should be converted to a quantized value of 255. At the end of the day, the bits are decreasing. So quantization is basically happening. But we have to probably come up with a scale factor. Now what exactly is a scale factor? So let me define a scale over here. So here, the scale formula will be x max divided by x mean. And then they will be divided by q max minus q mean. This q is nothing but quantization. Now what is the x max over here? 1000, right? So this I will consider as my x. This I will consider as my q, right? I'm showing you how quantization happens in a symmetric distribution. Symmetric basically means all the data is evenly distributed. Okay, and we really need to convert this based on this itself. These are evenly distributed. Now what is x max? X max is nothing but 1000 minus 0. Then q max. Q max basically means 255 minus 0, right? So if I probably go ahead with this specific division, right, then what will be the value that I will be having, right? 1000 divided by 255, it is nothing but 3.92. So this is nothing but this is called as a scale factor, right? Scale factor. So any number that I have over here, if I want to convert from this FP32 bit to U int 8, I just need to use the scale along with one formula which is called as round. Okay, so I will apply round with respect to any number. Let's say if I consider 500 divided by 3.92, or let's just consider 250 divided by 3.92. So if I want to see what will happen to 250, right, what will be the number in this U int 8, so I can probably go ahead and divide it. It will be nothing but 250 divided by 3.92. So if I go and calculate it, it is nothing but 63.77. So if I do the rounding, that basically means this will be 64. So in short, any number that is over here, let's say it is 250 over here, this will get converted to a quantized value to 64, right? So the same thing the code will also be doing. And this is for symmetric unsigned int 8, okay? Quantization. If I want a quantization for some other factor, let's talk about this, okay? So let's say I have another kind of distribution, and this is time that it is asymmetric, and I want this as U int 8. So if I want to perform this quantization, so what will happen now in this particular case? Let's say if I have values between minus 20.0 to 1000, okay? So these are my floating point. Now I want to perform quantization and convert this into 0 to 255, right? Now, in case of asymmetric, what will happen is that in my real number section, right, these numbers are not symmetrically distributed. It may be right skewed, it may be left skewed. Okay. So in this scenario, you'll be able to see that my values are ranging between minus 20 to 1000. I want to convert this into this. Now in this scenario, if I apply the same formula, x max minus x mean, so how it will be 1000 minus 20. So minus of minus 20 is nothing plus 20 divided by 255. So if I probably do the calculation, then you'll be able to see that I will be getting somewhere around 4.0. Okay. Now, very important thing that basically means this 20.0, if I quantize it, right? If I quantize it, it will get converted to something like 4.0. Oh, sorry. This is the scale factor. Okay, scale factor. Now, if I take any number and try to convert it, let's consider minus 20. If I try to convert it by dividing by 4.0, right? And if I do the round, so what it will become? Minus 5, right? Minus 5 of round. This much I will probably get, minus 5, right? Now, you can understand that this minus 20.0 is getting converted to minus 5.0. But you can see over here, my distribution starts from 0 to 255. So how can I forcefully make this minus 20.0 to 0? All you have to do is that go ahead and add the same number in a positive way. So in this case, the number that you see, this 5, right? This is basically called as 0 point, right? So there are two important parameters that we specifically talk with respect to quantization. One is 0 point. For the above one, since we have a symmetrical distribution, here the 0 point was 0 only. And the scale was 3.92. In this particular case, since it is asymmetrical distribution, here we have a 0 point as nothing but 5. But scale is 4.0. So these two parameters we usually require to perform quantization. Okay. And these are some of the examples that I have shown you to just give you an idea like how quantization basically happens. And super important in terms of understanding is this simple equation, you'll be able to understand how things are basically working, right? At the end of the day, understand quantization is a simple process of converting that high full precision floating point 32 bits into small bits. You know, it can be unsigned integer 8, it can be signed integer 8. If we say signed integer 8, then what will happen is that it will be ranging between -128 to 127. And based on that, you can specifically apply the formula, right? Now let's go ahead. See, we had already discussed about these two topics. One is this, and second one we wanted to discuss about calibration. Now this squeezing that you could see, right, from here to here to here, here to here, we are squeezing it, right? This squeezing process is basically called as calibration. Whatever process we are basically applying in this quantization process, it is nothing but it is called as calibration, because we are squeezing those values from a higher format to a lower format. Okay, so that is nothing but calibration. So we have completed both this thing. Okay, now let's see what are the different modes of quantization. One is called as post-training quantization and quantization aware training, right? I will talk about this, why it is super important, both this technique. Okay, so you'll get an idea about it over here. So first of all, we will go ahead and say post-training quantization. So what exactly is post-training quantization? Here we already have a pre-trained model. So we already have a pre-trained model. Now, if I want to use this pre-trained model, obviously the weights are very high. Here we apply calibration, right? When I say calibration, that basically means squeezing the value from high format to a lower format, right? And then after performing this particular calibration, we take what kind of data? We take that weights data, whatever weights data is basically there in this particular pre-trained model, and then we convert this into a quantized model. Okay? So once we apply this process, then only we'll be able to get the quantized model, and then we can use this entire model for any use cases. Okay, for any use cases, right? This is a simple mechanism with respect to post-training quantization. See, understand, post-training basically means I already have a pre-trained model where my weights are fixed. I don't need to change those weights. I will just take or download those weights. I will take this weights data, apply the calibration, and then convert this into a quantized model, right? The second technique that we have written over is quantization aware training. Okay, quantization aware training. So let's talk about this. Quantization aware training. This is also called as Q. So this is also called as QAT. Okay, so we can write it as QAT. Okay, quantization aware technique. This is basically called as PTQ. Okay. So over here, what is the exact difference we'll try to see between these two, okay? Now in quantization aware training, what happens? See, over here, what is the problem? If I probably perform calibration and if I create a quantized model, there is a loss of data. And because of this, what will happen is that the accuracy will also decrease, okay, for any use cases. But in the case of quantization aware training, okay, you'll be able to see that we will be taking out train model, whatever train model is there. Train model is there. Okay, let me just go ahead and write it down. Train model is there. Then we perform quantization. Again, quantization is what? Same, the calibration process will apply over there. We will probably do all these things, okay? And then once we do this, the next step is that we will go ahead and perform fine tuning. See, we know that with the help of PTQ, you'll be seeing over here on the top, some loss of data and accuracy is there. But here, with respect to fine tuning, we will take new training data. Now, once we specifically take new training data, we will be fine tuning this model and then we create a quantized model. So with respect to any fine tuning technique that we will be seeing, we don't use post-training quantization. We specifically use quantization aware training technique. So that basically means we are just not losing accuracy of data over here because we are in turn adding more data for the training purpose. And through this, we will be fine tuning our data and then we create our quantized models, right? So this is the basic difference. So all the fine tuning technique that I will probably show you in the future will be of this type, that is quantization aware training, so that we do not lose much data accuracy. So I hope you got an idea with respect to all these three techniques, guys. Going ahead, there are two important techniques that we really need to understand. One is Clora and one is LoRa. So these techniques specifically will be also understanding with respect to fine tuning. So I hope you got an idea. Just get to know about all these things, guys. This is important because if someone asks in the interview what exactly it is, then you'll be able to understand it very much easily. And again, explaining all these things will be important if you're really interested, because in generative AI, what I feel is the most important thing is with respect to the fine tuning things. So I hope you like this particular video. This was it from my side. I'll see you in the next video. Have a great day. Thank you and all. Take care. We are into the part 2 of fine-tuning series, and in this particular video, we're going to discuss about LoRa and Clora in-depth intuition. Already in the playlist of fine-tuning, I've discussed about quantization, and I hope you've seen the video early. Many people were requesting for LoRa and Clora also. So let's discuss, and we will try to discuss the complete in-depth maths intuition. The best thing will be that, guys, I'll try to explain this maths in-depth intuition. I've already seen the research paper, and there are a lot of complicated things that is probably there in the research paper. But I will try to teach you in such a way that at least you should be able to understand, what exactly is LoRa, and then we'll also see one example, how with the help of code you will be able to do it. And trust me, these are some of the very important things in fine-tuning, because tomorrow you go in any interviews, you're going to get asked respect to this kind of questions that may be coming, because at the end of the day, any generative AI projects, specifically with LLM, right, LLM models, if you are working in the company, they will be giving you fine-tuning tasks. To talk about the research paper, so what does LoRa means? LoRa basically means low rank adaptation of large language models. This is this amazing research paper, and probably you'll be seeing a lot of this kind of equations as you go ahead. There'll be different performance metrics. But as usual, I will do what I'm good at. I will try to break down all these things and probably explain you with respect to examples, with respect to code, and many more things. So quickly, let's go ahead. So why LoRa and Clora is basically used? LoRa basically means low rank adaptation, lower order rank adaptation. It is specifically used in fine tuning of LLM models. Okay, so let's go ahead and discuss this. And I've created this amazing diagram over here. Initially, whenever you have a pre-trained LLM model, that basically means let's say that there's a model something like GPT-4 or GPT-4 Turbo, right? And this model has been created by OpenAI. So we basically say this model as the base model, okay, GPT-4 Turbo. And this model is trained with huge amount of data, right? So the data sources will be internet, it can be books, it can be multiple sources, right? At the end of the day, all these models, how you can measure them, they may be saying that, hey, it supports 1.5 million tokens, it has been trained with this many number of words, right? So many tokens of words. Now what will happen is that all these models, probably to predict the next word, it will have the context of all those tokens, and then it will be able to give you the response. So these all models are basically base model, and we also say this as a pre-trained model. Okay, some of the examples again I'll be telling you: GPT-4, GPT-4 Turbo, right? GPT-3, GPT 3.5, something. All these models are specifically pre-trained models. Now, further we can take this model, and there are various ways of fine-tuning it. Please make sure that you watch this video till the end. If you watch this video, you will understand everything that is actually required with respect to fine-tuning. And there are multiple ways of fine-tuning also. Now, let's say that I take this model, I do some amount of fine-tuning, okay, and this fine-tuning is done on all the weights of the specific model, right? So some of the application that we may generate is like ChatGPT. We may generate like Cloudy ChatGPT, right? Cloudy GPT itself, like the chatbot that we specifically use. Some of the examples. Okay, so this one way of fine-tuning is there where we train all our parameters. So here we specifically say full parameter training. Okay, so here you can see full parameter fine tuning. So here I'm going to write full parameter fine tuning. Now this is one way of fine tuning where we train our entire parameter based on our data that we have. Okay, and after training it, we can develop applications like ChatGPT or any custom GPT that you specifically create. As we go ahead, you can also take these models and perform domain specific fine tuning. Okay, so one type of fine tuning is this. The other fine tuning technique that you can specifically use is called as domain specific fine tuning. Some of the example, let's say that I'm fine tuning a chatbot model, which will be for finance, it can be for sales, it can be for different domains itself, right? So here the main important word is domain. So this fine tuning also we can perform. Okay, so again, why I'm saying all these things, because there are various ways of fine tuning things, right? One more fine tuning we can basically divide by is something called as specific task fine tuning. In case of specific task fine tuning, these are my different tasks. Let's say this is task A, B, C, D. This task can be something related to Q&A chatbot. This task can be something related to document Q&A chatbot. Different applications. So that is the reason why we are specifically saying over here as specific task. Okay, specific task fine tuning. Now perfect. Now this is good. You have seen all the different ways of fine tuning. Okay. Now let's talk about full parameter fine tuning. Again, I'll repeat it. This is my base model right now. If you use it as an example, as I said, GPT-4 Turbo, GPT 3.5, Gemini 1.4, different models can be there. We can take this base model, we can fine tune and create applications like ChatGPT, we can create other applications like Stable Diffusions, not specifically to LLM, but LLM, we can actually do it. Then we can also further fine tune this based on domain specific fine tuning, right? Based on different domains like finance, sales, retail. We can also take this model and do more specific task fine tuning, like task A, task B, task D. Let's say I want to convert this into text to SQL. I want to have this as document Q&A. So I can further fine tune it based on specific task. Now let's talk about this full parameter fine tuning, okay? And what are the challenges with full parameter fine tuning? And that is where, see, I'm building up the story. Later on, I'll be explaining you where LoRa will be used. Now in full parameter fine tuning, the major challenge is that we really need to update all the model weights. Let's say that I have a model which has somewhere around 175 billion parameters. That basically means 175 billion weights. Now in this particular case, whenever I fine tune this model, I need to update all the weights. Great. Now when I'm saying updating all the model weights, and when we talk about this many number of parameters, why it can be a challenge? Because there will be hardware resource constraint, right? So with respect to different tasks, if I really want to use this particular model, that much RAM I really require for inferencing purpose, that much GPU I really require, right? So for downstream task, it becomes very difficult. Now what is downstream task? Downstream task, some of the example is like model monitoring, right? Model monitoring. The other task can be like model inferencing, right? Model inferencing. Similarly, the GPU constraint that we may have, the RAM constraint that we may have. So we may face multiple challenges when we have this full parameter tuning, full parameter fine tuning. Now, in order to overcome this challenge, we will specifically use LoRa and Clara. Okay, what exactly is LoRa? As I said, low order rank adaptation, and Clara is something. It is also called as LoRa 2.0. So we'll discuss about both of them with respect to mathematical intuition, and you'll get a complete idea what I'm actually trying to say. Now, what does LoRa do? Okay, now let's read the first point, and this is very much important because in the research paper you will find this equation. Okay, this equation. Now, what exactly LoRa will do? LoRa says that instead of updating all the weights in full parameter fine tuning, right? Instead of updating all the weights, it will not update them. Instead, it will track the changes. It will track the changes. Now, what changes this is basically tracking? It will track the changes of the new weights based on fine tuning. Okay, this is very much important to understand. So, based on the new weights, how we are going to combine these weights with the pre-trained weights. Okay, so here you can see these are my pre-trained weights from the base model. Like let's say that this model is Llama 2. Now, if you're performing fine tuning using LoRa, then LoRa will track the new weights over here, which will be of the same size. Okay, so let's say if this weight is 3 cross 3. Then the new weights, when it is probably doing the forward and the backward propagation, those new weights will be tracked in a separate matrix. And then these two weights will be combined, wherein we will get the fine-tuned weights. Now, this way, what will happen is that this tracking will happen in a separate way. But still, you may be thinking, Krish, here also we are updating all the weights itself, right? So here also the resource constraint will definitely happen. Yeah, fine. I'm talking about 3 cross 3. But what about weights and parameters where there are 175 billion, right? 175 billion parameters or 7 billion parameters. That time I'll be having a huge matrix, right? So at that scenario, you need to now understand how LoRa works. Because this weights, how it is getting tracked, it will just not get tracked in this 3 cross 3 matrix. Instead, all these weights that is getting tracked, then a simple mathematical equation will happen. I'll not say mathematical equation will happen, but there will be a technique that will happen which is called as matrix decomposition. That basically means the same 3 cross 3 matrix is saved it in a 2 smaller matrix. Now in this 2 smaller matrix, you can see this is nothing but 1 cross 3 and this is nothing but 3 cross 1. Right? Sorry, this is 3 cross 1 and this is 1 cross 3, right? So this is 3 cross 1 and this is 1 cross 3. When we multiply both these weights, then I will be getting this weight only, right? So over here, if I consider I have around 9 weights, 4, 5, 6, 7, 8, 9, right? You'll be able to see that I will be able to get all these 9 weights from how many number of parameters? Just 6 parameters, right? Because when we multiply this, then you'll be able to see that I'll get all these 9 parameters or 9 weights that I have, right? So in short, what LoRa is doing is that it is performing this matrix decomposition where a big matrix, and this matrix can be of any size, is decomposed into 2 smaller matrices based on a parameter which is called as rank. How to calculate a rank of a matrix? You can definitely check out any YouTube channel. There is a simple algebraic equations based on transpose of a matrix, how we calculate the rank. But let's say that this matrix that I have, which is a 3 cross 1 over here, the rank of this particular matrix is 1, right? And if I use this 2 matrix, you can obviously see that the number of parameters that I'm storing over here is less when compared to this, right? Yes, there will be a loss in precision, but it is making sure that when we combine both these matrices, we'll be able to get the entire updated weights. And just imagine, start thinking, guys. Let's say that if I have 7 billion parameters, now I'm trying to perform fine tuning on those parameters. So whenever I track those weights, this huge matrix will be decomposed into 2 smaller matrices. And when we are decomposing this matrix, this updated track weights matrix, into two smaller metrics, obviously we'll be requiring less parameter to store all these values, right? And this way, your fine tuning becomes very much efficient. And this really solves the resource constraint, right? This is the most important thing, right? And so in any research paper that you go ahead, you'll be seeing this equation. W0, this is my pre-trained weights, plus the tracked change weights is nothing but my pre-trained weights plus B multiplied by A. What is B? B is this, A is this. So when we multiply this, you'll be able to see that we are able to get all the track change weights, right? And obviously this requires less parameters. If you're decomposing our bigger metrics into two smaller metrics, less parameters is required. Now what will happen if we keep on increasing the ranks? If we keep on increasing the ranks, this parameters will also keep on increasing, but it will always be less than this. Right? If I have 7 billion parameters, if I try to decompose that into two matrices, two smaller matrices, with increasing rank, then also the parameters that will be required will be less. How I'm saying this? Because in the research paper also they have tried with multiple trainable parameters. Now let's see over here. There are multiple techniques for fine tuning. Some of the techniques that are there is something called as prefix embed, prefix layer, adapter. Adapter is one very famous thing that is probably used before LoRa. Right? You can see as the rank is increasing, the parameters also increases. Right? Initially, the trainable parameters are 175 billion, but when I use techniques like adapter, right? So initially it will have 7.5 or 7.1 million parameters with rank is equal to 1. But as I keep on increasing the rank, you'll be able to see that this parameters also get increased. But you can see from 175 billion parameters, if I compare 7.1 million weights, the percentage is very less. Now similarly in LoRa, because of that matrix decomposition, you'll be able to see that as I keep on increasing my ranks. So these are my ranks with respect to Q, K, V. Because in transformer you have this 3 parameter Q, K, V. Then only all the matrix multiplication will happen with respect to these 3 parameters. And then as we keep on increasing the rank, here you can see 4, here you can see 8, here you can see 64. Then you'll be able to see initially we got 4.7 million parameters. Compare from 175 billion to 4.7 million. How this was possible? Because of the matrix decomposition. Right? And as we keep on increasing the rank, you'll be seeing that the parameters are increasing, right? The parameters are obviously increasing, but if I compare it with 175 billion parameter, this is very less, 9.4 million. You can just see the percentage, right? So here also, when rank is equal to 8, 37.7 million, then rank is equal to 64, 30, 1.9 million, right? Parameters are there. So still, it is making sure that the parameter is not that much, not like 175 billion or not near to this. If I talk with respect to percentage, it is very, very less. I've also made another table, right? Just to show you, if I have different models, number of trainable parameter. Here you can see I have one LLM model with 7 billion. If I use rank is equal to 1, then I will be having 167k parameters to fine tune weights based on fine tune weights. Then, and this 167k parameter basically means what? This decomposed matrix that I have, right? Two metrics, that many number of parameters. So in the first case, it is just nothing but 167k parameters that is available in this decomposed matrix. Okay. When we combine them, then we will be able to get how many? 7 billion parameters. If we combine both these metrics, then we'll be getting 7 billion parameters. Okay. Then similarly, you can see in 13 billion, then you have 228k parameters. In 70 billion, you have 529k parameters. In 180 billion, you have 849k parameters. So as you keep on increasing the weight, this parameters will keep on increasing, but it is not increasing with that huge amount, right? Even you can see when we keep the rank as 512, right? So here you can see 86 million parameters is there when compared to billions, right? Microsoft, it came up with this LoRa technique in one of the research papers. It has used rank is equal to 8, okay, to probably do the fine tuning, and it has performed absolutely well. So most of the time we select this particular value, but at the end of the day, how to select this, right? It won't matter, because the parameters are increasing by very less number over here as we go ahead. So usually you can select rank 1, 2, 8 while you're performing fine tuning. Now there may be also scenario that when should we use very high rank? When to use high rank? This answer, because in the interview they may ask you, if the model wants to learn complex things, then you can specifically use high rank, right? Let's say some of the model is not trained to probably interact or probably perform some of the behavior. At that point of time, those complex things can be handled when you're probably increasing the number of ranks. Okay, so this can be a very simple question that may be asked in the interview. But I hope you got a complete idea. At the end of the day, this is the equation that you'll be able to see in most of the research paper. What LoRa is doing is that nothing. Very simple. All the track weights is decomposed into two smaller matrices with different ranks. It can be different ranks. When you're fine tuning, the first thing is that you really need to set that rank. Okay, if you set that rank, like in this particular case, if I go ahead and calculate with all the mathematical stuff, I will be able to get the rank is equal to 1. Okay, for this also rank is equal to 1. Right. So similarly, if you have rank 2, so one of the matrices can be something like this. So decomposed matrix. So this is based on rank 2. Okay. So if I probably combine this, right? So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? If I multiply this, I'll be getting a matrix of much more parameters, right? But at the end of the day, in this particular case, it is less number of parameters, right? So this is what LoRa is all about. And because of this technique, the fine tuning is done less. The weights, the parameters becomes less. So this is how the main resource constraint is done. And with respect to all the downstream tasks, it becomes very much easy. Now, one more thing that I really want to talk about is LoRa. Okay, LoRa basically means quantized LoRa. Okay. Now you have already learned from the first video what is quantized. Quantized basically means, now in LoRa case, what will happen is that all these parameters that is probably stored in float 16-bit. Okay, we will try to convert this into 4-bit. That's it. Okay. Once we do this, you'll be able to see that we reduce the precision, and then we try to reduce these values also. By this, you don't require much more memory. So that is the reason we say quantized LoRa technique. Okay. And the best thing about this is that LoRa also has one amazing algorithm which will be able to take care of both this part. Let's say there is a float 16-bit, I quantize it to 4-bit. I can also convert this back into 16-bit. Okay. So with respect to this explanation, guys, I've already spoken about many things over here, LoRa and LoRa. This specific video, we are going to fine-tune gamma models in Keras using the LoRa technique. Created a lot of videos how does fine-tuning happen, what is LoRa, what is quantization, and many more things. So in this particular video, we are going to fine-tune the gamma model. And again, remember guys, gamma, if you don't know, it is a completely open source model that has been provided by Google. And we'll try to see that how we can actually fine-tune our LLM models with respect to this with our own custom data. So here, one of the things we are going to use everything step by step. We'll go ahead and do it. Okay. Now, first of all, you need to complete the setup instruction at gamma setup. So if you probably click over here, you can probably watch this entire. You can see this entire, the documentation that is specifically given. The first thing that you specifically require is an API key. So first of all, go to aistudio.google.com and then click on get API key, right? And if you don't know, guys, you also have now access of Google Gemini 1.5 Pro, which you can probably access it, right? And then over here, after going to this particular page, you need to click on create API key, right? Once you specifically create API key, you'll be just allowed to give the name, select the project, give the name, and automatically you'll be able to get an API key over here. Copy that API key. My API key is already, I've created it, so I'll be specifically using that, right? So you have to just go to aistudio.google.com. Okay, so this is the website that you will specifically go to. Okay, then you need to go to kaggle.com and specifically get the access, right? So you need to get the access of this, the Gamma setup itself, right? So if you go ahead and write Kaggle Gamma, right? Access, right? If you just go ahead and write it over here, here you can see that Gamma will be there. So you have to go to this particular page, log in into it, and here you'll be seeing you have consented the license to license for Gamma. First of all, if you have not consented it, here they'll be asking you an option of request access. So once you need to click the request access, and once you go ahead and select all the terms and conditions, you will be able to get the license agreement, right? So then you'll be able to get the license consent, and then you'll be able to use it. Okay, so that is the first thing. And right now, all these models are available over here with both, and it can run on JAX, TensorFlow, and PyTorch. Okay, so this is the next step that you really need to do, right? And then go ahead and configure it. I'm already using a paid Google Colab Pro account, so for me, I definitely require a lot of RAM because I really need to show you a good fine-tuning technique. Okay, so quickly, let's go ahead and configure it. As I said, once you probably go ahead and create an API key, go to this particular secret key, and then you need to write over here as Kaggle key along with the API key. Otherwise, you can also go ahead and write Google API key, right? So I will just enable it so that I'll be able to use it over here. Okay, so this is the Google API key that I require, and if you really want to access it from the Kaggle itself, you need to probably select this too. Okay, so once it is done, and if you want Hugging Face token also, if you want to use it, you have to create it, right? So all these things are selected. Now what I'm actually going to do is that import OS. And how to, okay, one more thing that you will specifically require is Kaggle key and username. How do you create it? So you have to probably go to this particular settings button, right? If you go ahead and click on settings, right? Once you go ahead and click on settings, I think somewhere the API will be there, so you can go ahead and create a new token, right? So once you create a new token, you'll be getting two important keys. One is Kaggle key and one is Kaggle username. So you have to set it up. So once you probably click on token generating a node, token will automatically expire the previous one. So I'll not do that because I've already done it. So once you do that, JSON file will get downloaded, and there you'll be getting two keys. One key is the Kaggle key and one key is the Kaggle username. So you have to make sure that you have to set all this up over here, okay, before you start this particular project. Then we will go ahead and select all the, we'll go ahead and set up all the environment over here. One is the Kaggle username and one is the Kaggle key. So I'll go ahead and execute this. Once this is basically getting executed, the next step is that we will go ahead and install Keras NLP. And I think this is the first kind of videos where I've specifically uploaded how you can find Gamma models in Keras using LoRa. Okay, so Keras is also having this specific feature. So first of all, I will go ahead and install Keras NLP and Keras greater than or equal to 3. So once the installation will specifically take place, because we are going to use Keras to do the entire fine tuning. Okay, so this is going to take some amount of time. Then we can go ahead and select the backend. You can use JAX, Torch, TensorFlow. So it already provides all the specific features, right? So in the environment, I will be selecting Keras backend as JAX, right? JAX, the best thing is that again, just like TensorFlow and Torch, but again, it is a completely open source. You can also use this specific thing. Okay, so till the installation is taking place, then we are going to avoid memory fragmentation on the JAX packet. So we are going to set this XLA Python client memory fraction. Okay, so here we'll be setting it to 1.0. So this is the initial environment that we really need to select. Okay, so you are now connected to GPU runtime but not utilizing the GPU. Don't worry, we'll be utilizing because I need to probably do the entire fine tuning with the help of GPU. Okay, so initially Kaggle username, Kaggle key, then install all the Keras libraries that is specifically required, and then you select the backend that is called as JAX. Okay, so here we're getting some error. I think it is a conflict, but no worries. I think it is working fine. Then we'll go ahead and execute this where we are selecting the backend in this. Okay, now let's go ahead and import Keras and NLP. Okay, Keras and NLP. Okay, here to fine tuning the Gamma model, right? What we need to do is that we need to set up our data set in the form of JSON file. Okay, where you'll be able to see this. I will just go ahead and click this particular link, and here you'll be able to see this. Okay, how the data will specifically look like. So this data is specifically present in Hugging Face. If you go ahead and open it, okay, so I think I will go ahead and open it. Okay, so here let's see whether I'll be able to read the JSON format. Okay, so JSON format, I'll just try to load it over here. Okay, JSON lines, JSON. I think here you'll be able to find out how you can load it. Okay, whether it is asking me to drop it over here. Let's see. I can drop it or what? Okay, so this is how the file looks like. Here you can see there is a JSON file has two important things. One is instruction. See, I will just zoom out a little bit. So here you have something like instruction, then you have something like context. So in this, you specifically have one is instruction, one is context. Instruction is what is the question, and context is basically what is the answer. So if you probably see all the inputs and outputs are specifically in this particular structure, right? Because I'm going to use this structure itself, and for Gamma also, even for OpenAI, you definitely require in the form of this JSON file, right? JSON-L, right? So where you have two important information, instruction, and then you have context. So based on this, you can also create your own file. Since I'm showing you a fine tuning technique, so I will be downloading this dolly15k.json. So here you have 15,000 records with respect to this. As soon as this file will get downloaded, you'll be able to see over here. Okay, so here you can see Dolly Databricks dolly15k JSON. Again, it is an open source data set. Just to show it to you, you can definitely use it. Now, the next thing over here, you'll be able to see that the code that we are specifically writing, import JSON data, and then we are opening the JSON file, then we are loading all the JSON file into JSON itself, then we are reading the context. If the feature context does not exist, we'll continue. Otherwise, we'll create this kind of template, right? Where my instruction will have the instruction data and response will have the response data. Okay, and then we are going to append it inside this particular list of data. Okay, once we do this, this is what my first top 1,000 data looks like, and here you can see that it is Reddit, and here you'll be able to see this is my entire data. With respect to the top 1,000. Okay, so we are going to just use the top 1,000 data, and the format that we specifically want is basically written over here. In this format, that is instruction with instruction, response with response. Okay, whatever content is present in that JSON file. Then it's time that we will be loading the model of Gamma. So here we can write keras_nlp.models.gamma casual LM from preset, and there are two types of models. One is Gamma 2 billion parameters, and one is Gamma 7 billion parameters. How I'm saying it? So if you go over here, if you go down. Okay, so here we have the access of Gamma 2 billion. Yes, 2 billion parameters. 7 billion also, if you go and search for Hugging Face, this one you'll be able to see. And this is what the performance metrics looks like. Okay, so here you can go ahead and execute this, and this will load the model from the Kaggle itself. And then it will be loading into our Colab notebook. All the models are basically getting loaded. All the weights are specifically getting loaded. And you can create this model. I will also show you till the inferencing part. Each and every thing will be shown over here. And once it specifically gets loaded, you'll be also able to see the entire how that entire model is basically created, how many layers it has, how many parameters it has. And obviously you can see 2 billion parameters, but just by downloading it. Once we download this entire thing in our Colab notebook, here you can see we have this tokenizer called as Gamma tokenizer along with this padding mask layer and token ID. Everything is given over here. And here the total number of parameters are somewhere around 2.5 billion, and it is 9.34 GB. GB. One thing you have to take care, guys, if you really want to run this, you really need to have a paid Google Colab Pro account. Okay. Then let's go and see this. And this is just the model. I've still not fine-tuned it. So without fine-tuning, we will run this. Okay. So we will create template.format, and the instruction will be, what should I do on a trip to Europe? Okay. I'm just asking a generic question to a gamma model, and response is completely empty. Then we take the same Keras underscore NLP. So here you can see Keras underscore NLP dot sampler top K sampler K is equal to 5. So I'm saying that try to provide me 5 results out of there. And whatever gamma underscore LM I've actually done, we are going to compile with this particular sampler. Okay. So once we compile it, then we can use this gamma underscore LM to generate the prompt, and it is probably going to give me some 5 responses. So if you probably go ahead and see this. So if you're following my LangChain playlist on all the fine-tuning playlist, you will definitely be able to understand how things are going over here. Right. So once I execute it, I will be able to see the prompt definitely over here. But just understand what are the steps. Initially, we create the prompt, then we create a sampler. Okay. This sampler will basically say that how much top 5 results we want, and then we are going to compile with the sampler, and then we are going to generate. Okay. So here you can see the responses is easy. You should just need to follow the steps. So and so. What are the benefits of travel agency? What do I choose? So 5 different records will be probably over here along with the response. Okay. But still, we have not fine-tuned it with our data set. So one more example is over here. Explain the process of photosynthesis in a way that child could understand. And here again, we are using gamma underscore LM dot generate, and we have already created a sampler. So here we'll be able to see the entire response with respect to the question that we have given, and understand multiple response will be able to get it. So explain the process of photosynthesis in a way that a child could understand. So here you can see all the responses are there. Chlorophyll is a great pigment. Explain how plant absorbs, plant captures sunlight energy through the leaves and use it. Okay. So all these things are definitely there, but the main thing is with respect to the fine-tuning. Now LoRa fine-tuning, I hope you know about the mathematical intuition. If you have not known, you are very late because I've already uploaded a video in my playlist. Right? How does LoRa work? LoRa works and all. That is a prerequisite that definitely you need to know. Okay. So this tutorial uses a LoRa of rank 4. What is rank? What is the importance of rank? Everything I've actually included. Okay. So here we are going to enable LoRa with rank is equal to 4. And now if you go ahead and see the summary. Okay. So enable LoRa for the model and set the rank to 4. So here you can see the parameters. Trainable parameters becomes less when compared to all the parameters over here. So hardly 1 million parameters are there from billion to million, right? So that many number of trainable parameters, only 5.20 MB. And then note that enabling LoRa reduces the number of training parameters significantly from 2 million to 1.3 million. Okay. Then we are going to set the input sequence length to 512. Okay. Again, you can change it to 1024 also. We're going to select the optimizer called as AdamW. Okay. In Keras it is already there. So Keras optimizer.AdamW learning rate is 0.0005, weight decay is 0.01. Okay. This is how we basically set optimizers in Keras. And then we are also going to exclude from weight decay, exclude lane norm and bias terms for decay. So here we are going to set this up. And then finally we are going to compile with this specific loss, that is sparse categorical cross entropy. Again, since it's a multi-class classification, I'm basically using form log is equal to true. Then you have optimizers. Then you have weighted parametrics. Again, over there sparse categorical accuracy is given. And then we do the fit of the entire data with epoch is equal to 1 and batch size is equal to 1. So this is probably going to take, if you're doing it in the paid collab, it is going to take somewhere around 10 to 15 seconds. You can also do along with my execution. Okay, it's probably going to start, and again, it's going to take around 10 to 15 minutes. So we will wait till this entire processing will start, but we'll wait at least till the first epoch should get started. And it is going to, based on the 1000 data points, I think it is going to take 1000 epochs. Okay, because batch size is only 1, because we're going to send a sentence for every sentence. We're going to do the forward and backward propagation with the help of AdamW optimizers. So yes, let's wait, and I think it should start. Now it has started. It is hardly going to take somewhere around 9 minutes 17 seconds. So we'll wait till this particular thing is getting executed, and then once it probably takes, okay, it shows 1 hour, okay, but I think it will hardly take 15 to 20 minutes. Okay, 15 to 20 minutes. So here you'll be able to see as you keep on going, the loss is also getting decreased. The sparse categorical accuracy will also keep on increasing. Okay, so we'll wait till this particular happens. Again, you can increase the number of epochs to get a more accurate model. Okay, so let's wait till this particular entire training happens, and then we are going to see the inferencing part. Thank you. So guys, finally the fine tuning is done, and here hardly took around 10 minutes, 10 to 11 minutes. Okay, so here you can probably see all the fine tuning accuracy. If you increase the number of epochs, so definitely this accuracy will keep on increasing. But let's check whether it is working perfectly fine. We'll also try to understand how to specifically do the inferencing. So here you'll be able to see now I'm giving the same question. What should I do on a trip to Europe? Now it will be able to give the response based on the data set. Okay, so here you can see the previous response was something like this. Yeah, it's easy. You just need to follow the steps. First, you must book a trip for the travel agency and all. But now you take it'll be a different response altogether based on the data set we have. Again, over here, same thing, sampler, gamma underscore LM dot compile, and then we are going to generate the same thing, right? So now let's go ahead and see the response after the fine tuning, how the response looks like. Okay, so yes, I think we should be able to get the response now in just some seconds. And similarly, the same other example also we'll try to see, explain the process of photosynthesis in a way child could understand. So here you can see now the response is completely different. The first thing is to get a passport and visa, and then plan what to do. If you're traveling to Europe, I recommend starting out in Paris, France. Paris is a great city to start out because it's the largest city in France and has tons of things to do, and all everything is you'll be able to see over here, right? Now, similarly with respect to the photosynthesis, so many different kind of answers you saw over there, but now you'll be able to see that how quickly you're able to get a quick response, and you'll be able to get a better response after the fine tuning. The same thing you really need to do. Anyhow, I will be giving you the entire materials. Just go ahead and execute it. Just the prerequisite is that you really need to understand about the fine tuning techniques. I'll be putting the fine tuning playlist in the description of this particular video. So here you can explain the process of photosynthesis in a way that child could understand. Photosynthesis is the process by which plants and some other photosynthetic organisms use light from the sun as a source of energy. So and so all the information is given, right? So you can also increase the size of the fine tuning data set, train for more steps, setting up a higher LoRa ranks to increase probably the performance of these models, modify the hyperparameters such as learning rate and weight decay. But I hope you have understood how you can probably fine tuning a gamma model using, and what we have done using Keras, and again the technique was used LoRa. So I hope you like this particular video. I'll see you on the next video. Have a great day. Thank you and all. Take care. Bye. Hello guys, so we are going to continue the fine-tuning series, and in this video I'm going to talk about an amazing platform which is called as Lamini. And this Lamini platform has almost each and everything from using basic LLM models to probably create chatbots till fine-tuning different LLM models with your own custom data. And trust me, if you've seen the Google Gamma model fine-tuning right over there, you found many difficulties, many tasks needed to be done. But this as a platform simplifies the entire fine-tuning process. So let me just go ahead and show you an example how you can perform fine-tuning in this. And obviously in this you will also be getting some amount of free things, like with respect to if I just go ahead and see the pricing, right? So here in the pricing, in the free, you can see what Lamini can do. You can see the full model lifecycle, choose a model, run RAG, try running, see evals, use for inferencing, compared to top open source models like Llama 3, Mistral 2, 5.3. All these models are specifically available. 5,000 inferences requests per month, and then limited turning request. And you can also run on Lamini's optimized compute platform using LoRa PEFT. So already we have learned about LoRa PEFT, quantization, Clora, right? So we'll try to see how we can probably do the entire fine-tuning process. Okay. First of all, let's go ahead and log in over here. So once you probably log in, you'll be able to see that you'll get redirected to app.lamini.ai. Once you go over here, you can see that out of 5,000 total inferences, I have somewhere around this many number remaining. So obviously, when you can try this much, definitely you'll be able to understand how does the entire fine-tuning process continue, right? And currently, this is the API token that they actually provide. Okay. Along with this, you can go ahead and train your model. So let's say that this is the model that I have actually trained, and here you can see this model with respect to the custom data set, how it is, and how was the base model before, right? So all those results also you'll be able to compare. You'll be able to go through the playground and ask any kind of questions. You can probably go ahead and check out the logs with respect to the entire fine-tuning process. That also you can probably do, right? Not only that, here is the entire documentation which you can also go ahead and follow. What are the documentation, how to use this entire Lamini using this particular library, how you can basically start. Okay, so this is really amazing because completely for free you will be definitely able to access all these things. Okay, so let's start and let me just show you a basic example with respect to fine-tuning. And in this particular example, I will go ahead and take Llama 3 model. And then we'll try to see that how things works over here. Okay. So first of all, I will go back to the same graph LangChain. I'll be using the same requirement.txt over here because I may require all these libraries. I may not require Neo4j, but I will just try to show you with respect to that. Over here to start with, we require one model. Okay. Which model is that? We definitely require for that. It is nothing but Lamini. So let's go ahead and first of all start with the Lamini API. Lamini model itself. So we can go ahead and probably start doing it. Okay. So first of all, I will just go ahead and write over here. Okay, and I'll show you the step by step how you can basically do. Okay, so the first thing that I will be writing is my library, which I'm actually going to use. Okay, Lamini. So I will just go over here, just go ahead and write pip install -r requirement.txt. Okay, I'm in different folder. Okay, cd dot dot, and here also I will write cd. I'm inside my graph LangChain. Okay, fine. Pip install minus -r requirement.txt. So once you do that, the installation will take place. I've already done the installation so that it does not take much more time. Now here I created one folder called as fine-tuning, and here is one file that is called as fine-tuning.py. I'll be writing my entire code over here itself as we go ahead. Now, the best thing about using Lamini with respect to any kind of models that you go, first of all, you need to prepare your data. Okay, one example of preparing your data over here, I have actually created this. Okay, and I have also checked the documentation. It was very simple. So over here you can see I will just try to create a Q&A fine-tuning LLM model. I'll use Llama 3, but with respect to this particular data. Okay, so here you can see in every data you have this in form of list of key value pairs. Okay, so here you have input, then you have output. Okay, so for this input, this is the output. For this input, this is the output. And if you probably see this, everything is about Lamini itself. Is the Lamini type system similar to a Python type system? So this is just like FAQs, some kind of questions that you have related to Lamini, right? So here you have, does Lamini have a limit on the number of API requests you can make? Lamini provides each and every user with 3 tokens upfront, right? So this is the answer. If I ask this question, this should be the answer. Like this, we have created a set of questions and inputs and outputs. Okay, so here it actually becomes this particular function. This function is get data, and we are creating a variable over here. Okay, now let's go ahead and start this. Okay, so this is my data which I have, and obviously for creating this particular data, I don't think so you'll require much time. So first of all, I will go ahead and write import Lamini. Okay, along with this, I'll say, hey, from Lamini import Lamini. Okay, so there will be this Lamini class which I'm going to specifically use. Okay, now I've already told you. First, to start with, we need an API key. So if you go over here, if you go to the eval results, or let me just see this. Okay, so here if I go to the account, okay, so this is the API key that I have. So I'm just going to copy this particular API key, and I am going to just assign this API key to this particular Lamini variable, right? So first of all, what I'll write Lamini.api underscore key is equal to this particular API key. Okay, so this is the API key that I'm setting. You can also store this in your environment variable and call it over here by using os.getEnv, right? That I've already shown you. Now I will just go ahead and use my LLM model. So in order to call my LLM model, I'll just use this Lamini class. Inside this, I will give my model dash name. Now model underscore name will be in the same way like how you define your model through Hugging Face, right? So let's say I'll go ahead and use this MetaLlama model. So it is MetaLlama slash MetaLlama. Okay, and this we are going to use 3. It is nothing but 8 billion parameter, and this is nothing but instruct model I'm going to use. Like this is how the model is available in your Hugging Face also, right? If you go and see for this particular model, you get the entire path. Because the best thing is that this entire thing will be running in the Lamini cloud. And it will be taking care of all the quantization process, even LoRa and LoRa, every fine-tuning will basically happen over there. Okay, so this basically becomes my LLM model. Now what I will do, I will just go ahead and write data is equal to get underscore data. Here I get my entire data itself. Now I'm going to fine-tune my entire LLM model. I'll just write LLM dot fine-tune. Sorry, LLM dot. There's a function called as tune, and inside this we will just go ahead and write data. Or so there's a parameter which is called as data or data set. It is nothing but it is assigned to this particular value called as data. Okay. Now this is the most simplistic way of fine-tuning, right? This much code will actually help you to get started. Okay, but we'll not stop here, right? We will do some more things. Let's go ahead and add some of the hyperparameters. Now with respect to the hyperparameters, what are hyperparameters that you have over here? Okay, so I'll write down some of the comments so that you'll be able to see this. Common hyperparameters to tune include learning rate, early stopping, max steps, and optimizer. Okay, which are optimizers you can specifically use. So guys, here are all the common hyperparameters you can probably include for tuning this particular model. Let's say learning rate, early stopping, max steps, and optimizer. So learning rate, obviously you can set up some values. Let me do one thing. Let me just show you one example how you can go ahead and probably set it up. So here I'm just going to create my second parameter, which is called as fine-tune underscore args. This is what the documentation says. You need to provide your additional hyperparameter in this particular way in the form of key value pairs inside this. So here I'm going to basically go ahead and write learning underscore rate. Okay, while we are fine-tuning, it should be equal to, let's say I will go ahead and write 1.4 e to the power of -4. Okay, so this will basically be my learning rate, and I will just use this learning rate and try to probably fine-tuning it. You can still add max steps and optimizer, but I just want to keep it as default values itself. Okay, now let's go ahead and run this. So quickly I will go to my fine-tuning folder. I'll say python fine-tune.py. Okay, so once I execute this, you'll be able to see that now this entire thing will be running, and it will first of all load the dataset. See, it is uploading the dataset. Dataset is uploaded. The dataset is this. Consider using this future to train using the same data, and this is the URL where we will be able to track. So if I click this URL, it will go ahead and open my Lamini page. Okay, so let's open this. So oops, I think it is this page or what? So 8134, right? So I will open this. So let's see in this train. So here you can see 8134 is running, and before I had tried some more and it got failed, I stopped it in middle, right? So here you'll also be able to see the logs, and I've tried multiple things here. It has been also successful, but I was just exploring multiple things over here. So here you can see all the logs is basically getting generated, and if you closely observe the logs here, LoRa underscore A is there, LoRa underscore B is there, weight related to weight parameters are specifically there. All the information is visible over here, right? And this entire training is basically happening. And how simple it was. You just need to put your data in the input and output format, and just by writing this particular code, you could actually see it, right? Now let me do one thing. Let me go back to the completed, and obviously this process is going to take some amount of time, right? Around 5 minutes, 10 minutes, based on your dataset size. But I have trained with a similar dataset over here, and you can see I'm able to get the trained model. Okay, but let me talk about some of the important metrics that you'll be seeing after the model is basically trained. So the first thing is that it is something related to eval results. Now what does eval results basically talk about? Here you can see the model that you have used, right? This model that you see over here, this is after fine-tuning, and before you had this base model, this was before fine-tuning. Okay. Now before fine-tuning, when we asked the question, can Lamini be used on a regular computer, or do I need specialized hardware or software, right? So here you could probably see if I just go ahead and click this was the answer before, right? But now your answer has much more details when compared to the previous one, right? Similarly, if you go ahead and see the second question, are there any step-by-step tutorial walkthrough available in the documentation? So here, if you go ahead and see, before the answer used to come like this, but now you have this entire detailed question, detailed answer, right? This is all because of fine-tuning, right? And here, similarly, you'll be able to see what does this cancel underscore job function mean. Before it was something like this, right? With respect to the base model, but with the fine-tuning model, you'll be able to see this, okay? So here you'll be able to see every kind of new responses with respect to the answers that you're able to get, okay? The second thing is playground. If you really want to go ahead and play with this entire model, you can also go ahead and play it, right? So here on you'll be able to chat and you'll be able to ask any kind of questions. So with respect to this particular playground, you can probably go ahead and ask any questions and you'll be able to test it over here itself. You'll also be able to get one link, over here with respect to the model. Now see, this entire thing is got trained, right? Now if you really want to go ahead and see with respect to this argument, the argument that we have used learning rate, right? Here you're able to see the eval results, right? This model and your base model response, and it is like quite a difference over here, right? Which is amazing. So with respect to this, again, you can go ahead and ask any question in this playground and you can probably ask them, okay, to test your model, how the result is, you can go ahead and test it over here. Similarly, there will be something like you can also create the public link for this model. So all you have to do is that click on yes, confirm, and once this is done, you will be able to share your entire LM model links with anyone so that they will be able to use it in the chatbot, okay? So this will probably take some time. I've already clicked on yes, okay? So let this go. But overall, you'll be able to see that here, how easy, how simple it was probably to train this entire model, right? And here you can see, right, now I have this public link. I'll copy this over here. I'll paste it over here. Now you can go ahead and ask any question and you can go ahead and try it out. And again, it depends on how much quantity of data you're basically being able to train. But I hope this gives you a clear idea about the entire fine-tuning process and obviously how simple and easy it was, right? So yes, go ahead and explore it from your end. As we will be seeing that this probably I felt is the most easiest way, and it was my duty to probably go ahead with this specific platform and make your work very much easy, okay? So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, welcome to this new amazing module on building generative AI application using LangGraph. Now LangGraph is an amazing library that is available in LangChain, and with the help of LangGraph, you'll be able to build stateful multi-actor application with LLMs used to create agents and multi-agents workflows, right? And one amazing thing about these agents will be that they will also be able to communicate with each other, right? Specifically, if you're working in some data science projects, you'll be having data analysts, you'll be having data scientists, you will be having product managers, you'll be having program managers, and while developing the entire project, there will be a lot of communication with all these specific roles, right? With respect to requirements, with respect to development, and many more things. Now we can actually create those kind of projects with the help of completely different multi-AI agents. Each and every agent can specifically perform different tasks. Let's say for my project, I want to probably create a multi-agent generative AI application. There, I may have a data analyst, I may have a data scientist, I may have a program manager, and I can probably implement all the functionalities with the help of this AI agents itself, right? And that is what, in order to efficiently manage this entire workflow and the stateful management, we specifically use LangGraph. Okay. Now, in the upcoming videos, you'll be seeing some amazing projects where I will be showing you the importance of LangGraph. Now, compared to other LLM frameworks, it offers this core benefits, that is cycle controllability and persistence. LangGraph allows you to define the flows that involve cycles, essential for most agentic architectures, differentiating it from DAG-based solutions. Okay. So there will be a lot of things that we'll be discussing as we go ahead. Why this module or why this library is super important? Because see, if you have already seen this particular post, LangGraph, what LangChain has actually done is that they are also coming up with this LangGraph Studio. Okay. Now, with the help of the studio, what you will be able to do is that you'll be able to create all these workflows just by drag and drop. Right now, this particular studio is just available in Mac. Okay. But don't worry, as soon as it gets uploaded from both Windows and Mac, I will start making the videos on that also. Just by doing drag and drop. Here you can see, just by doing drag and drop, you will be able to implement the entire workflows. And right now in our course, till this entire studio does not come as an open source availability, what we'll do, we'll try to write the code for all these things. Okay. And that will be the best thing to probably learn, because once you learn all those things, working with the studio will be super easy, right? So here you can just see an example, right? When we are specifically running this entire workflow, right? How step by step it is able to run, right? So here you can also see an example. This is my workflow that is probably running up. I'll ask a specific question, who created you? So step by step, it will probably go to the agent, it will take an action, it will go and execute each and every code, and it will go ahead and execute and show us the output response. That is the most amazing thing, right? So right now in this upcoming series, what we are going to do, first of all, we are going to develop this with the help of Python programming language, and along with that, we'll also be using a library called as LangGraph. But once this studio is available, I will also show you all the examples with respect to that. And probably should be available in some time. Okay, that I will keep a note on that, and I'll keep on updating my course itself. So this was just about LangGraph to give you an introduction. But here, please make sure that you remember this. It is a library for building stateful multi-actor application with LLMs used to create agents and multi-agents workflow. And this agents will be able to communicate with itself and will be able to perform various tasks. And that is what I'm actually going to show you in the next video, where we'll deep dive more into LangGraph and we will be developing some good projects. So yes, this was it from my side. One very important thing that I really also want to note, that we will first of all start with Google Colab, right? We'll work with Google Colab, wherein we will go ahead and write out code. We'll execute and show you each and everything. Let's say I will give you an example. This is one of the first project that we will specifically work on, where we will create a simple chatbot application with the help of LangGraph. And here you'll be able to see that this kind of graphs will also be visible. These are nothing but these are nodes, right? These are relationships that also we have learned in the graph database. And we'll see step by step how we will be executing all these things, right? So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, in this video and in the upcoming series of video, we are going to discuss about a new module in LangChain which is called as LangGraph. Now LangGraph is quite amazing because it actually helps you to build stateful multi-actor application with LLMs. It is used to create agent and multi-agent workflow. So this is really important. Now there are a lot of libraries, a lot of open source libraries that are available which actually helps you to create multi-agent workflow. But if I probably consider LangGraph, it's quite amazing. So in this entire video and in the upcoming series of video, I will be discussing many things about LangGraph. First of all, the agenda of this particular video will be that we'll try to discuss what exactly is LangGraph, why LangGraph, and we'll see how we'll try to create a chatbot wherein we will get just started with LangGraph, where I will be showing you with respect to all the coding things, right? So all these things we will be covering. And when we'll discuss about why LangGraph, at that point of time, you'll understand the importance of LangGraph. And through this, you'll also be able to cover, or you'll be able to just compare with all the libraries, open source libraries that are available to create multi-AI agents workflows, right? And I feel right now LangGraph is quite amazing. And as you all know, what LangChain is also doing is that LangChain is coming up with its own cloud platform through which you will be able to build your own multi-agent workflow using LangGraph, and you can do it completely in a visualization way, right? And right now it just supports for the Mac machine. So we'll be discussing all about that as we go ahead. But right now, let's go ahead and focus on, first of all, we'll go ahead and see the definition of LangGraph. So if I talk about what is LangGraph, LangGraph is a library for building stateful multi-actor application with LLMs used to create agent and multi-agent workflows. Compared to other LLM frameworks, it offers this core benefit cycles. So this is really important. Controllability and persistence. Okay, LangGraph allows you to define the flows that involves cycle, essential for most agentic architecture, differentiating it from DAG-based solutions. Now, if you have seen already my previous video, I hope everybody knows about GraphDB. Okay, so what exactly is GraphDB? It probably helps you to create, if I probably just talk about creating RAG application using graph knowledge, right? So here specifically you have nodes, you have relationship between the nodes like this, and with the help of this kind of relationships, you can actually build this graph knowledge. Okay, and graph knowledge is specifically built right now, even in Google search engine, you'll be able to see graph knowledge. And with the help of this graph knowledge, you'll be able to develop some amazing RAG application because the efficiency with respect to the graph knowledge search is quite amazing. So graph knowledge has the combination of all the kind of search, the hybrid search, the graph knowledge search. So whenever you have any information which is displayed or which is probably converted into a graph knowledge information, then your conversation with this kind of data store, right, can be quite amazing. So already I've discussed about this in our previous video, but in this video we will try to talk about LangGraph. And the main thing will be that how we have actually created this GraphDB structure, right, in the form of graph knowledge. Similarly, LangGraph is also offers those kind of functionality. We can create the entire multi-AI agent workflow using this graph knowledge itself, right? So like how we have nodes, relationship, and all. Similarly, in the LangGraph also we'll be able to do that. Okay. So till now we have just discussed about the definition. Don't worry if you're not able to understand, because once we start the practical application, everything you'll be able to understand. Okay. Now let's talk about the second question, the second most important question: why LangGraph? Why LangGraph? Okay. Now here I will be talking about some amazing benefits of using LangGraph in point wise. Okay, so let's go and talk about this amazing benefits of using LangGraph. So number one, okay, number one is that it really simplifies the development. Simplifies development. Now when I say simplifies development, what does this basically mean? See, whatever complexities, usually whenever we develop any multi-AI agents, right, there are multiple things that is involved. The state management of the agent, like at which stage, at what work it needs to really do, and agent coordination. Let's say one agent needs to communicate with any other agents, right? When we say agents, we are basically talking about multi-AI agents, right? So these two things are very important. Here, if I probably seen most of the libraries that I've actually used, most of the open source libraries that I've used to probably develop multi-AI agents, this two information that we have, that is state management and agent coordination, I found out a lot of difficulties with respect to managing these things, right? But with the help of LangGraph, it really simplifies it. Now, when we talk about state management and agent coordination, what does this basically mean? Let's say that I'm using 3 to 4 multi-AI agents in my generative AI application. One agent is probably doing some Wikipedia search. So let's say I require agent 1, I require agent 2, I require agent 3, right? So let's say all these specific agents are there, right? Each and every agent probably needs to, it does some specific task, right? Let's say this will be doing a Google search, this will be doing a Wikipedia search, and this will probably do a vector search, vector DB search, right? And here is my chatbot, which is specifically using all this multi-AI agents. Now, whenever we develop this kind of application, it is very important that we have to do the state management efficiently for all the agents, and also the agent coordination. What does agent coordination basically mean? The communication between this kind of agents. Let's say whenever a query is asked, first of all, we go and ask agent 1, hey, whether you really need to do a Google search. If you're doing it, you really need to provide that information to agent 2. Then agent 3 will probably come into picture. So this kind of communication is basically a kind of agent coordination. Okay. So whenever we are developing this kind of things, and there may be also scenario that when you're developing a use case, the agent 1 response may be dependent on agent 2 response. So agent 2 will only be able to work when they get the response from agent 1. I'm just giving some hypothetical scenarios. Okay. Now, when you're developing this kind of chatbots, as a developer, we really need to define workflows. We need to define logics, right? Without worrying, right? Without worrying about so many different things, right? So that is what it actually does. LangGraph actually provides you this entire, it simplifies this entire development process, and it will actually help you to create an efficient multi-AI agents, right? So we'll be discussing more about it when we go ahead and discuss about the practical implementation. Second thing is that why LangGraph you should use it. Second thing, a very important point is related to flexibility, okay? So whenever we talk about flexibility, I will just make sure to provide some description information over here so that you'll be able to refer this, okay? So with respect to flexibility, you can see with LangGraph, developers have the flexibility to define their own agent logic, communication protocols. This allows for highly customized application tailored to specific use cases, whether you need a chatbot that can handle various types of user requests or a multi-agent system that performs complex tasks. LangGraph provides the tools to build exactly what you need. Okay, so it's all about giving you the power to create. So with respect to flexibility, as I said, the kind of logics that you can basically write will be quite amazing. You'll be seeing that how granular level logics you can actually write with respect to each and every agent that you specifically create. I'll be showing you as we go ahead with one very good practical example. Okay, then the third thing is that if I talk about the third important point, why specifically we should use LangGraph, it is related to scalability. Okay. Now, whenever we talk about scalability, here, when we're building this multi-agent application, we can actually build large-scale multi-agent applications. Now, what do we mean by large-scale multi-agent application? See, the kind of robust architecture we basically use, this large-scale multi-agent, we basically say this as large-scale multi-agent application because it can handle high volume of interaction, right? The interaction can be between agents, and it also has a really amazing or complex workflows. And you'll be seeing, when we define about complex workflows, it will be very simple to develop the entire workflow itself, right? And even LangChain is coming up with a feature, and probably many companies are going to use specifically in enterprise, right? And there is also an enterprise version. We can specifically develop this as an enterprise level application, right? With all the features. And it is also coming up with its own cloud where you can just do drag and drop and you can actually create this, right? Final important feature, if I talk about, is something called as fault tolerance. So it also has this amazing feature, LangGraph, okay? So the kind of libraries you'll be seeing, LangGraph libraries will include, right? It will be able to handle errors. You'll be seeing that. It will be able to handle errors. It will be ensuring even though your application fails, it should be continuously working. And let's say that one individual agent encounters an error, right? Then also there will be some fault tolerance mechanism it will basically have, wherein it will not just stop the application, but instead it will keep on running, right? So this is one of the very important core feature, that is reliability, right? Whenever we talk about reliability. So this was two important things. We have discussed about the definition of LangGraph. We have discussed why LangGraph. Now it's time that I show you some of the amazing applications how we can actually go ahead with the development. Here, what we are basically going to do is that we are going to create a chatbot, okay? And we'll try to create an agent, let's say, in the form of chatbot. And again, in the backside or right or in the back end, you'll be able to see that we'll also be able to create a graph, like how that entire agent specifically works. So quickly, I will go ahead and this I'm executing in the Google Colab. You can also go ahead and use it, okay? So let's say that I will just use any of the GPU that I have, okay? I'll just go ahead and connect it. Anyhow, you don't require GPU in this, but definitely we'll be seeing that if you have any kind of, if you require any kind of keys over here. And when I say that I'm going to create a chatbot, let me just go ahead and discuss about this architecture of the chatbot. So what I'm going to create over here, right? So let's say that there's a chatbot over here. This chatbot, I will try to create some kind of node. Let's say this will be my start node, okay? Whenever any user query comes, you should be able to see that I will create a chatbot over here. This chatbot can basically interact with any LLM models, okay? And once it probably gives you the output, we should end this entire flow, okay? So the reason why I'm drawing this in the form of graph, because LangGraph also does the same thing, okay? So LangGraph also creates the entire flow in the form of graph itself, where you'll have nodes and all, right? Now there are two main important things when we see this. These are specifically nodes, right? Start and end node. This chatbot is one node, and when I write chatbot, that basically means it is having some kind of definition, right? If a chatbot needs to move from one step, let's say from one state to the other state, we basically call that as a state management, right? So probably after executing this, the chatbot is moving towards the end state. So something is basically happening. So let's go ahead and create this, and then you'll be able to understand more about it, okay? So first of all, we will go ahead and pip install LangGraph. So we are going to specifically use LangGraph, okay? And we will also use Langsmith. So let's go ahead and execute this. Langsmith, I hope everybody knows what exactly it is. So till then, I will also go ahead and show you the documentation page of LangGraph. So this is what LangGraph is all about, right? It has Python, it supports JavaScript and all. But if I just go ahead and show you LangGraph tutorials, right? So here you can see this is the tutorial, right? And not this, sorry. Let's see. Yes, here you go, right? In the LangGraph page, it should be somewhere. Or let me just go to LangChain, langchain.com. And here's your LangGraph, yes. So here you can actually see we will try to create this kind of nodes, right? And I hope everybody has seen this kind of nodes specifically, right? So what does LangGraph actually supports you to? It provides controllable cognitive architecture for every task. It is designed for human agent collaborations, right? This kind of graphs also you'll be able to see. All these things I will try to show you in this video. So it has this fault tolerant scalability, optimized for real world interaction, integrated developer experience, amazing features. And I feel, right, if you probably get the access of the beta server, right, and you'll just be able to see the power of this. But at the end of the day, we will be creating some amazing agents, you know. So here you can see I've installed both the libraries, LangGraph and Langsmith. Now let's go ahead and start more things over here. Now as we go ahead, we're also going to install LangChain, because we definitely require LangChain, and then we are going to use LangChain underscore grok. Along with this, we are also going to use LangChain underscore community, right? So these all libraries will be specifically required in order to build our entire chatbot, right? So here you can see the installation is basically taking place. Okay, perfect. Now let's go ahead and import OS, or what I will do is that I will write from google.colab, okay, import user data, okay. Now see, as you all know, when we work specifically with VS Code, you know, we used to create environment variables to access any keys. It can be Grok API, it can be Langsmith keys. Now, similarly, with respect to Google Colab, whenever you're working with Google Colab, here you can see one option. Here you can actually go ahead and upload all your secret keys. Let's say if you want to use Grok API, if you want to use OpenAI API, if you want to use Langsmith API, if you want to use Hugging Face API, you can just go ahead and enter it over here, add a new secret key, and you can add the key and value pair. Okay, here is your password, here is your key name. Now, in order to access this key, you can actually see that I've already uploaded it over here, right? So let's say, since I'm going to use a chatbot which will be interacting with my Grok API, so if you don't know about Grok API, you can just go over here and search for grok.com. When you go to grok.com, you can sign it with your email ID. Let's say I'm going to sign it because it provides you free API to access the open source models. You know? So I will go to Grok API over here, and here you'll be able to see that a lot of different models are basically available. Right? Llama 3.1, you also have Llama 3, you have Gamma 290, you have Distal Whisper Large, V3 encoding EN. So all these kind of models are there. You can specifically use this particular model. And I've already covered this in my previous videos. Okay. Now in this scenario, what I'm actually going to do, I will be using some APIs for this. So if I go and click on Start Building, here you can see that I will go to my Grok Cloud console. Then here you can go to API keys. Once you go to API keys, you can probably create your own API key. I've created so many different API keys. You can go ahead and create your own API key, right? I've already shown that also in my previous videos. Once you create an API key, just go ahead and click over here, add a new secret key, just go ahead and write grok underscore API key and put it over here, right? All the API keys itself. Now, once you're able to add in the secret, the next thing is that I will try to read that particular API key in my Google Colab. So in order to read, I will go ahead and write from google.colab import user data. And let's say that I want my grok underscore API underscore key. I can just use this user data dot get grok API key. So if I go ahead and just print this, you'll be able to see that I'm actually able to read it, you know, grok API underscore key. This is just to show you, don't use this anyhow. So here you can see it is asking, should we access this particular secret name, grok API key. The notebook title untitled 106.ip does not have access to secret name grant access. So if I click on grant access, but right now what happened? Timeout happened, right? So I'll go ahead and execute it once again. And now you'll be able to access this, right? So this is my grok API key that you're able to see. Perfect. Right? So now this grok API key, I can actually use it. I can use it for creating my LLM application, anything that I want, okay? Now, once this is done, what I'm actually going to do, I'm also going to use Langsmith, okay? And I hope everybody knows what exactly is Langsmith, right? So here I will go ahead and write Langsmith. Langsmith actually helps you to, so if I go ahead and just do sign up, right, it'll be able to help you to track each and every information with respect to the interaction that you have actually created in your chatbot, right? So if you go to Langsmith over here, also you'll be able to get the dashboard, right? So I'll go to settings. Here is my API key. If you don't have an API key, go ahead and create an API key. But if you go ahead and see my secret key, I've already added that, Langsmith underscore API underscore key, okay? Now let's go ahead and read the Langsmith key also. So I'll go ahead and write Langsmith is equal to user data dot get. And here also I'm going to use Langsmith. Let's see, what is the key name? Okay, so I'll just go ahead and print my Langsmith. Okay, so here you'll be able to see that. I will also be able to get it. So it asks for grant access. I will give the grant access over here, and it should be able to display it, and it is displaying. AFE is the last term. AFE is also over here. So I've read both this particular key, and both this key will be specifically used for creating my chatbot application. Langsmith will be specifically used for tracking everything that is basically happening over here. Now the next thing will be that I will go ahead and import OS. Then let's go ahead and import os.environ. I will just go ahead and save all these things, right? So first of all, I need Langsmith API key. Okay. I can also go ahead and write Langsmith, or I can also go ahead and write Langchain API key. So let's go ahead and do this. Langchain API key, I will set this to my Langsmith. Okay. We need to set up this specific keys itself. Okay. Then my endpoint is specifically not required. I will just go ahead and copy these two things. And this basically just used to set up the basic requirements, right? Langchain tracing v2 and Langchain project. Okay. So let's say this will basically be my course LangGraph. Okay. So this is what is my project name that I'm actually writing. I'm saying that, hey, we need to make sure that you need to keep the tracing underscore v2 as true. And Langchain API key is nothing but it is assigned to Langsmith API key. Now, you may be thinking, why did you use Langchain underscore API key? No, you can also use Langsmith. But according to the documentation, when I saw, both of them were satisfied. So I just used Langchain underscore API key. So let's go ahead and execute this. So once this is executed, you'll be able to see all the information over here. Now, quickly, let's go ahead and write from Langchain underscore grok import ChatGrok, because I need to use the ChatGrok open source models. Okay. Now this is done. Now I will go ahead and create my LLM model, so which is nothing but ChatGrok. And inside this, I will be using my grok underscore API underscore key, which is equal to grok API key. And my model underscore name will be nothing but, you can use multiple models, any models that you want. So in the Grok Cloud, I can see there's Llama 3.1, anything that you want. I will just go ahead and use this Gamma 2 9B IT. Okay. So this specific model, I will go ahead and use it. It is up to you. Now, nothing compulsory which model you really need to use. You can use any model that is provided by Grok. Right. So this is that. This is my LLM model. Okay. Now the next step will be that. Now here you can see, yeah, I'm able to access all the models. I'm able to access the model Gamma 2 9B IT. Okay. Now it's time we start building chatbot using LangGraph, right? So here is what we are going to basically start, and this is the most important thing, right? So if I probably go ahead and say this, okay. So first of all, understand there are multiple things which we really need to start with the importing part, okay. So first of all, I will be importing something called as annotated, right? So from typing, I'll be importing annotated. From typing extension, I'll be importing typedict, okay. Along with this, I will be importing two important libraries from LangGraph. So I'll go ahead and write from LangGraph. You'll understand why this importing is done just in some time, okay. From LangGraph.graph, okay. I'm going to just go ahead and import two things. One is state graph. State graph actually helps you to manage the entire state management. Then your start node, and your end node, right? You remember that I actually created a diagram, right, where we had a start node, then we had an end node, which actually shows the flow of the entire chatbot itself. Okay. Along with this, I will also be showing, like this. See, the state graph is basically used for the state management purpose. Now, the state graph needs to keep on changing based on some parameters. Okay. So for that, what I will be doing, I will go ahead and write from LangGraph.graph.messages. Message. I'm just going to go ahead and import add underscore messages. Okay. Now this is one of the function. What it does is that we have this something called as messages, right? As we keep on adding the messages over here, we'll be able to see that our state management, our state of the agent will keep on changing. Now this messages is just like, you can understand, like when a user is giving a query, the LLM model is giving a response. When it is giving a response, the message will get added over here, and then my state of the chatbot will also get changed, right? So this messages is basically keeping track of all those things. Okay. So now let's go ahead and execute this. So this has got executed successfully. You can understand each and everything I've actually explained. We will talk about this too, right? Just in some time. Now we will go ahead and create our own class. Let's say this is my class state, which will be making sure to probably control the entire state management. Here I will go ahead and write typedict. Okay. So I will go ahead and write typedict. Okay. Typedict. Okay. So this class is basically inheriting this particular typedict. Okay. Now what we will do, we will go ahead and write some comments over here. Okay, so that you'll be able to understand. Messages that have the type list, the add message function in the annotation defines how the state key should be updated. It appends the message to the list rather than overwriting. So inside this class, I've created a variable called as messages. Okay, and this messages is of type annotated, and this annotated is basically saying, hey, it is a list type. And here I'm using this function called as add messages. This add messages will be responsible on adding or appending the messages to this list. Okay, which is basically created in the form of list in this messages variable, and it will not override them. The entire state management will be controlled as we keep on adding this particular messages, because on every add we will be changing our state. Okay, now the next thing that we will go ahead and define. Since I've defined my class state, I will go ahead and write my graph builder. Okay, I will go ahead and define my graph builder. So this is what we start our graph building process. So here I'm going to use state graph, the state graph which I've actually imported it over here. And this state graph will have this particular class which is called as state, because the state knows which messages are there, what messages are basically getting appended. And this graph builder should be responsible in managing the entire state management, right? So once I execute this, here is my graph builder. So let me just go ahead and execute this. So this is my graph builder over here, right? So here you can see langgraph.graph.state, state graph at this specific location. So guys, now after we have created the graph builder, what we are basically going to do is that already in this diagram you saw that, right? We are going to create this chatbot. Now this chatbot should be interacting with our LLM. So for this, we'll go ahead and write some definition. So let's quickly go ahead and create a function, definition chatbot. And remember, whenever we're creating any node, right, in this entire graph builder, it needs to take the parameter as state, okay, whatever state we are giving over here. And this will be important because the reason is very simple. Because based on the state message, right, whatever messages, whatever interaction that we are doing, the state management will keep on changing. So here we go ahead and define this chatbot where we take the parameter as state, and then we return. You know that after any response that we get from the chatbot, we need to update this messages variable. So here I will go ahead and create this messages, and here I will just go ahead and write llm.invoke, okay. And this invoke will be specifically invoking from the state message, which will have the user queries, right? So whenever user queries, you'll be able to see that this messages will get appended in this particular message variable. And once it does that, we're just going to invoke that. And whatever response we're getting it, we're again appending it over here, right? Or we are putting in this particular value. We are returning this entire in this particular format. When we return this, when we are inheriting the state class, right, it is going to understand, hey, whenever we return this kind of message, it is going to trigger this add message and it is going to add this in this messages variable. Okay. So just understand in this way is that here I have a chatbot function which is invoking the previous messages based given by the user, and we are returning some kind of messages over here. Okay. So once we execute this, I will be getting my chatbot. Now this chatbot needs to get added in this graph builder. So here I will go ahead and write graph underscore builder dot add underscore node, and here I'm going to specifically use chatbot as my node name, which will have the functionality of this particular chatbot. Okay. So once I execute this, you'll be able to see that this entire node is basically getting added. So now if I go ahead and just display this, you'll not be able to see much things over here, but we'll be seeing the entire diagram. So step by step, you can see that what we have done. First of all, we have created this class state. Then we have created our graph builder. Then we have defined our chatbot, what functionality is basically doing, and what it is returning. It is returning just message colon some output that we're getting over here, right? And remember, the chatbot is inheriting the state class, and the state class has one variable messages in the form of list, and there's a function called as add underscore message, which will keep on appending whatever message we are specifically getting over here, right? So that is what it is basically doing. Now, since we have created this graph builder, now it's time that we connect this chatbot to the start and the end node. Okay, so here I'm going to go ahead and write graph builder dot add edge. Okay, so add edge start chatbot. Okay, so we are basically going to add the start and the chatbot, and similarly we are going to add chatbot till the end, right? So then only we'll be able to find out, we'll be able to get this kind of flow. So start is basically appended with chatbot, and chatbot is basically getting appended with end. Start basically means whenever we get a user query, it will just start the process. The chatbot will do the interaction with LLM. It will give us the value, and it will go to the end state. And how the state management is basically happening because of this state class which we have inherited in graph builder. Okay, so once we execute this, this is done. So finally, what we do after creating this, after adding all these nodes, we go ahead and write graph builder. We need to compile it. So we'll go ahead and write dot compile. So once we compile it, we'll be getting our entire graph ready. So here is my graph itself. So once I execute this, my graph is ready. Now let me just go ahead and display this. So in order to display this, in the documentation, I saw this code where they're importing this image and display, and there's something called as graph.getGraph. So here, instead of graph, I'll write graph builder. Okay. Oh, sorry, it should be graph only because we have compiled it. Get graph, draw mermaid PNG. Okay. So once I execute this, you'll be able to see that I'll be getting this entire flow. So start and end are just like one private functions that are present inside the state. I probably say this particular class, the state graph class, right? Which is present inside this langgraph.graph, right? And now this will basically, as soon as the user queries, we will go to the start state. Then it goes to the chatbot. Here the interaction will basically happen. And once the interaction happens, the state should change, right? Once we get the response, it will go to the end state. Now let's go ahead and execute this, and then only you'll be able to see the output. Okay? And we are just going to start this. Okay? So here I will just go ahead and write while true user underscore input is equal to input user input user. And here I'm going to just go ahead and write if user underscore input dot lower int. Let's say I'll go ahead and say, hey, if you're just going and typing in quit or q, right? I'm just going to stop the conversation with the flow, right? So here I'm just going to write print goodbye. Okay. And then we're just going to break from here. Okay. But if the user input something else, so here I will go ahead and write for event in graph.stream. Okay, we're just going to stream. And here we're going to use this messages as my key variable. Messages is a colon. And here I'm going to give based on user. See, initially, whenever user gives the input message, I need to set this as user, right? As a parameter. And here will basically be my user input. Okay. Then I will go ahead and write print event dot values. We are just going to print the values. Then here more we can go ahead and probably convert this or explore this value. So here I'll write for value in event dot values, print value. And inside that value, there will be a key which is called as messages. Okay. And then we will go ahead and print our assistant message. Assistant basically means the message that is basically coming from our LLMs. So here you'll be able to see value messages dot content. So here let's explore this code. First of all, a user is giving an input. If it is not giving quit and queue, so it will go to graph.stream with respect to all the messages that users have already given. Then we are going to get that event.values. For value, we are going to get two important things. One is value of messages and one is the value of messages of content. So this value of messages, I think it should have the user message and this should have the LLM model response. So let me go ahead and execute it. So I will go ahead and write hello. Let's see. So here assistant you can see, right? Hello, how can I help you? So all these messages are basically coming in the form of dict value, right? So here, hello, how can I help you today is the response and I'm able to get it. So let me go ahead and ask what is generative AI, right? So here you'll be able to see that all the response is there, right? Generative AI is a type of artificial intelligence. Think of it. So it's amazing, right? You're able to get the entire response. And here also you can see response metadata, content is over here. So if you just go ahead and explore this, some of the other keys will be available over here, right? And if you go ahead and see down, so this is my entire generative AI message. So if I just go ahead and write Q, it should be exiting over here, right? So here you can see it says goodbye. So guys, I hope you liked this specific video and you were able to understand how to basically create a simple chatbot in the form of with the help of LangGraph. And here we have basically used the graph itself, right, from start till the end node. We have understood that whenever we create any node, it also needs to have a definition and how we can connect each and every node. Now in the upcoming videos, we are going to develop more complex projects on LangGraph where we'll be using external tools. There will just not use one node, but there will be multiple nodes as we go ahead. So I hope you like this particular video. I will see you all in the next video. Thank you. Hello guys, so in this video we are going to develop a multi-AI agent, a generative AI application using LangGraph, wherein we will try to create a chatbot. Along with the chatbot, we will also be integrating with some third-party tool so that whenever we ask a query with the chatbot, if the query is being able to handle by the chatbot, which is specifically being using some LLMs, then we will directly get the response. But if it does not have the answer, it will go ahead and ask this specific external tool. So the entire flow or the architecture looks something like this. Here, we will go ahead and start this process. Here, any user, if any user is specifically asking any query, first of all, the query will go to the chatbot. Then the chatbot will decide whether it should specifically provide the answer or should it probably go ahead and ask some third-party tool, right? The third-party tool can be Wikipedia, it can be Google search, anything it can be, right? And this chatbot that you'll be seeing, it will also be interacting with some open source LLM models. And this open source LLM model, we will be accessing it from the Grok API. So now we are going to go ahead with respect to one additional step with respect to LangGraph, like how we can integrate some tools. Here I'll be showing an example with respect to one tool. Like this, you can add any number of tools, and when the interaction is done with the tool, you get the response, and then you finally end this entire flow. Okay. So let's go ahead and implement this step by step. Now, first of all, what we really need to do is that we need to go ahead and install all these libraries. That is LangGraph, Langsmith, LangChain, LangChain_Grok. You know why LangChain_Grok is specifically used so that you can actually communicate with the Grok API. Then you have LangChain community, right? So I will go ahead and execute this. So once you specifically execute this, here LangGraph is going to get this. All these libraries will be installed. Okay. Now, after installing this, we will go ahead and import two more libraries. One is annotated and typedect. The reason is very simple. if you have already seen my previous video, we are going to use these two libraries in our state class, which will be managing the state of the LangGraph, right? So let's go ahead and execute this. So once we have executed this, I will go ahead and start writing my code, right? Now, first thing first, what we really need to do is that I will also go ahead and install some tools, and LangChain already provides you some amazing tools, and tools here that we're going to use is specifically like Wikipedia or RSIF, So if you have already explored LangChain, so already there are a lot of third-party tools specifically available, right? So for that, I will go ahead and write a comment. Here we're going to working with tools or external tools. So first of all, I will go ahead and write from LangChain _community dot utilities. I'm going to go ahead and import two tools I can actually use, but right now I will just show you an example with respect to one tool. One is RSIF API wrapper, and the second tool that I'm actually going to use is something like Wikipedia API wrapper, right? Now RSIF is basically if you are looking for any research papers, you can basically go ahead and interact with this particular wrapper. Instead, if you just want to get the search from Wikipedia, you can go ahead and take it from this particular library, okay? Then the next step will be that from LangChain _community dot tools import RSIF query run. This will be responsible in running any queries that you specifically give, and then you have this Wikipedia query run. Okay, so this is for the RSIF tool. This is specifically for the Wikipedia tool. Okay, then after this, I'm just going to go ahead and call my RSIF and Wikipedia tools. So let's say Wikipedia tools. Okay, and then here I'm going to write my RSIF _ wrapper is equal to RSIF API wrapper. Here, let's say in this API wrapper, how many results I want. I will go ahead and provide a parameter that is top tier results. Let's say top tier results, I just want one result, and I will go ahead and write my document content character max, like how many characters I specifically want. Let's say I will go ahead and write 300. Okay. Then with the help of this RSIF, what I'm actually going to do, I'll go ahead and create this specific tool. I will use this RSIF query run, and I will give the wrapper as a parameter over here. Right. One amazing thing about Google Colab is that it is now providing you code suggestion, which will be very helpful whenever you're writing any code. Similarly, if I go ahead and write my API _ wrapper, I will go ahead and use my Wikipedia wrapper. Here also I'll go ahead and write my top tier results and document content characters max characters. I really want 300. Right. That basically means whenever we are interacting with Wikipedia, I'm going to get the response as one document at a time, and inside that document, the maximum number of characters will be 300. So finally, I will go ahead and also write about Wikipedia tool, where I'm going to use this Wikipedia query run, and we're going to run this particular API wrapper. So two things, I've actually imported it. Now let's go ahead and just okay, one error is basically there. Let's say okay, I have not installed, so we need to install RSIF and Wikipedia. Okay, so without this will not work. Okay, so let's go ahead and execute this quickly. So this is going to get installed. Here you can see that it is getting installed, because without this particular packages, we will not be able to execute this code. Right now, it should basically run. Here I'm getting an error saying that base tool _init. Okay, RSIF tools takes RSIF wrapper. Okay, this is my RSIF wrapper. I need to provide my parameter, because over here I will go ahead and give my API _ wrapper as my parameter. Okay, so I'm not going to edit any of these particular errors. So please make sure that, and this is the key that is specifically used. And that is the reason it was giving an error. Now it should run. Okay, now this is run perfectly. Now let's go ahead and run any of this. So I will go ahead and write Wikipedia.tool, and let me go ahead and ask who is, I'll ask any question. Who is famous actor? Let's say Shah Rukh Khan. Okay. So here I'm going to write wiki _tool. It should be .invoke. Okay. So if I really want to invoke any of this, invoke, and let's me go ahead and execute it. Now it should probably go ahead and search from Wikipedia, and I'm getting a response over here. The maximum number of characters will be 300. Similarly, if you can go ahead and use this RSIF tool also. So if I go ahead and write RSIF _tool .invoke, okay. Attention is all you need. So this is one of the research paper related to transformers. So here you can see I'm getting all the information. You do not need all the information. So this is basically coming from the RSIF itself, right? And all the author research paper names, everything is basically available over here. So perfect. That basically means my external tools are working absolutely fine, right? But since I'm just going to use one tool, you can also use any number of tools. So I'll just go ahead and write this as wiki over here, or wiki _tool. So this will basically be my tool. Afterwards, let's say if you want to go ahead and add any number of tools, just go ahead and write comma and keep on adding all the tools, right? So now my third-party tool is done. Now I'm going to create my LangGraph application. Okay, LangGraph applications. Now in order to start LangGraph application, already in our previous video I've seen, I'm going to create class state, and here I'm going to use my type dict. Okay, the reason why I'm using this because I'm going to create this messages variable, which will be a list of variables. Okay, and I'm going to use the annotated, and I have to make sure that whenever the execution of a specific node gets completed, I'm going to go ahead and just make sure to update this messages variable. So here I'm going to get my list, and here I'm going to get my add _ messages. Okay, so once this is done, add _ messages also I need to import, and this add _ messages, if you remember from my previous video already, it is already available in the LangGraph. So let me just go ahead and import this. Okay, LangGraph.message import add message, and here I'm going to basically use the specific state, right? So all these are completed, and we have this particular add messages, and we're good to go. Okay, great. Now the next thing along with this that we really need to import is three important things from LangGraph. That is your state graph, start and end. I need to import all these things so that I get all the information that I really want. Okay, with respect to this. So this is done. Now let me go ahead and first of all create my chatbot. Okay, because already we have created this particular state class. Now we need to probably design our entire workflow, right? So here I'm going to go ahead and execute this. Now let me just go ahead and write quickly. I'll go ahead and create my graph builder. Okay, is equal to graph builder. I'll create this specific variable, and here I'm going to go ahead and write state graph. And here we're specifically going to take this state. Now this state graph is nothing but it is imported from here. This state is nothing but my class. The state is going to maintain all those different states in this particular messages variable. Okay, so this will basically be my graph builder. Now it's time to probably call my LLM model, right? Because at the end of the day, if we really want to create any chatbot, we really need to use a specific LLM model. Now I've already shown you in our previous video how you can actually go ahead and use LLM models, right? Or how you can use or how you can call the LLM model from ChatGrok, right? So here I'll go ahead and write from LangChain _grok import ChatGrok. Okay, ChatGrok. And inside this ChatGrok, I'm just going to go ahead and execute this, and then I'm going to create my LLM variable, which is nothing but my ChatGrok. And here you can actually go ahead and see my grok _API _key. This API key I should be getting from my secret keys, right? I've already added the secret keys, and I've already shown you how you can basically add it in the previous video, right? So in order to add this, I'll go ahead and write one more code. I'll go ahead and write from google.colab import user data, and then we will go ahead and write grok _API _key is equal to user data dot get And here I'm going to specifically use my grok underscore API underscore key, which is the key name that I've written it over here in my secret keys, right? Grok underscore API underscore key. Perfect. So this is fine. Now once I get my grok underscore API underscore key, I will just go click on grant access, and finally I will keep the value over here. So this should be grok underscore API underscore key. And here finally this is my LLM model. And this LLM model by default is using no model, so I have to provide my model name. So the model name will be nothing but, I will go ahead and my model name is equal to Gamma. I can use Gamma. So let's go ahead and use Gamma 29B IT. Okay. So I've specifically used this particular models, and let's go ahead and execute this. Perfect. This is done. My graph builder is also ready. Now it's time that we go ahead and create our chatbots, right? So we need to go ahead and define our chatbot. Now with the help of this LLM, we can basically call, we can call with our chatbot itself whatever nodes we are specifically creating, right? So let's go ahead and go with the next step, wherein we will go ahead and create our chatbot, which will be doing a functionality of managing the state and also interacting with the LLM model. So let me go ahead and create my definition chatbot. Because see, if I show you over here, right, we need to create this first, right? My LLM is ready. It is interacting with the Grok API. Now I'll create my chatbot. I will be interacting with this, but I will also be adding one very important thing. That is nothing but my tools, right? My LLM should also be integrated with the tools. So let's see how to probably do that. So first of all, I will go ahead and create a cell over here. I've created my graph builder. Everything is ready. I will take this LLM and I will say, hey, go ahead and bind underscore tools, whatever tools I'm going to use. So this will be my tools is equal to tools. And if you remember, this tools has specifically what does it has a binding as Wikipedia tool, right? So I'm going to basically bind this particular tool itself. And after binding, I will store this in a variable. This is just giving a additional functionality to the LLM that it has this particular tool access also, right? So this LLM with underscore tools will be used. Now, once I'm creating this particular functionality, I will first of all derive my, I will inherit this particular state inside this chatbot so that it has all the information related to the message. And here I'm going to probably return my output with the help of this messages variable, which is the key that is present inside the state, colon, and here I'm going to probably call or invoke with the help of my LLM model. But this time my LLM model will also have the functionalities from the tools, right? Because it also has the tools functionality, which is nothing but the Wikipedia tool. And here I'll go ahead and write dot invoke, and I'm going to probably take this particular state, the state which I'm inheriting, which is coming from this inside the state. You know what exactly is present? Messages variable is present. And if I take the state of messages, this is basically going to have the query of the user, right? So once I execute this is what it's basically going to return, right? So my chatbot functionality is ready. Okay, this chatbot functionality is ready. This LLM is being integrated with the LLM too, so it is basically going to interact. So whatever query comes, if this chatbot is able to probably provide the response from the LLM, then it is going to get the output. Otherwise, it is going to interact with this particular tool, right? And finally, we are just going to end this. Now we need to create this entire flow, the flow of the execution, right? So in order to create the flow of the execution, I will again take my graph builder. So let me go ahead and write graph builder dot add underscore node. Okay, and then we are basically going to write chatbot. So this will basically be my node name, chatbot, and finally you will also be able to see this chatbot, right? So this is my node. I will add the start with this chatbot node, right? I will add that particular edge because we need this specific edge, right? From start to the chatbot. Perfect. This node is basically added. Now I have to also make sure that I need to add the tool node. Okay, so see, whenever a tool is basically needed to add, because here we will be adding this tool over here, right? So this tool needs to be added to the chatbot. Then only the LLM will be able to interact with the tool. So for that, we basically use another library over here, which is called as tool node. Okay, so let me just go ahead and import one more library. So I will go ahead and write from line graph in order to add any third-party tools or any custom tools. You can also create this custom tools. I will go ahead and import one tool node, and then along with this, I will also give one tool condition. Like for this particular tool node, there should be some kind of conditions we need to add, right? Now, let's see what is the error. Tool node rebuilt from tool node. Okay, it should be tool conditions. Tools condition. Okay, no worries. I'll just go ahead and import this. Perfect. So this is done. Now what I've done, I've created the chatbot. I have connected from start node to the chatbot node. Then I will go ahead and call this tool node. So let me just go ahead and write tool node. And this tool node will basically have my tools. My tools is nothing but whatever tools I'm going to use. That is nothing but Wikipedia. And I'll create a variable which is called as tool node. Okay. So this tool node is also created. That basically means this tool node is also created. Now we need to connect from this chatbot to the tool nodes. How do I connect it? It's very simple. I will go ahead and write graph builder dot add underscore node. And here I'm going to basically go ahead and create a node which is called as tools. And this tools is going to get connected to tool underscore node, right? So this way, what we have done, this entire node is getting created, right? So here this entire tool node is basically getting connected. Now we need to probably connect this tool to our chatbot. Now in order to connect it, obviously we need to write some conditions. That basically means, what does this basically mean? Like if I'm getting a query, this chatbot may either interact with the tools or it may interact with the LLM and give you the output, right? So this kind of edges, if there is a bidirectional edge like this, we really need to use something called as add conditional edges, right? So here, what we are going to use is that I will write graph builder dot add conditional edges. See? Add conditional edges. That is the reason we had imported somewhere. Let's see where we have imported it. Have we not imported this? Let's see. I'll add conditional edges. Okay, we have not imported it. So first of all, we really need to import it, but no need to import it because this is an inbuilt function inside Graph Builder. Okay, so here I'm going to basically go ahead and write add conditional edges, and inside this particular edges, here what edges will specifically add from chatbot to tools underscore condition, right? And this tools underscore condition is nothing but it is basically coming from here. Now, understand over here why we are adding this conditional edges, because just from the diagram, you can see that from the chatbot, I need to interact with the tool and again get it back. So whenever we have this kind of bidirectional, we really need to add this particular edge, which is called as conditional edges. I need to give my node name and the tool conditions, the default conditions that is available over here. This tool condition is going to make that bidirectional directions itself, right? From the chatbot. Now, after that, you know that my tools also needs to get connected to the chatbot. See, this tools, when I'm using this add conditional edges, the chatbot till the tools, the communication will happen, but I need to reconnect it back. So in order to reconnect it back, I will just go ahead and write graph underscore builder dot add edge from tools to chatbot. See, from tools to chatbot, and finally we're going to add an edge which is from chatbot till the end. That is what we really want this end. So it is very simple. First of all, this is the entire flow, and this is really important. Inside this flow, we use three important things. One is add edges, add node, right? And then you also had conditional edges. right? All these three nodes we had, right? So first of all, we connected start to chatbot. So we created a node for chatbot and we add this edge from start to chatbot. Then we created this LLM tool integration. Then from chatbot to tools we specifically went, right? So if you go ahead and just revise this step by step, see, first of all, we added a node chatbot which is having this particular functionality. And this functionality is nothing but it is using this LLM underscore with tools dot invoke. It is just trying to get the output from this particular message, right? Whatever message is there, LLM will either give the response or the tool will give the response. Perfect. Then we added the edges with start to chatbot, this specific node. Then we created our tool node. Then this tool node got added as a node in the graph builder. Then we added conditional edges between chatbot and we applied a tools condition. Then we added the edges back from tools to chatbot. And then finally we have this graph builder dot add edge where we connected the chatbot with the end, right? So all these things were executed perfectly. Now let's go ahead and compile this. I'm going to basically use graph underscore builder dot compile. Okay, compile, and then this will basically be my graph, and we will just go ahead and execute this. Okay. Now finally, in order to display this graph, I can go ahead and use the same thing which we have used earlier in our videos with respect to IPython.display. This is just from the documentation. Now you can see the entire flow. See, start, chatbot, tools, end, right? Everything is basically here. So finally, you can see the flow over here after executing it. Let's go ahead and test it. So see, from start to chatbot, if the tools is required, then again it is connected back, and finally we go to the end, right? So all these things are specifically connected, and we are good to go with respect to this, right? Now let's go ahead and try out some of the flow, like with respect to any kind of messages, okay? And let's see how we are going to get the output, right? So first of all, I will just go ahead and give my user underscore input is equal to, I will write, hi there. Let me just go ahead and write hi there. And here I'm just going to write my name is Krish. Okay, I'm just going to probably provide some basic input from the user, right? Then I'm going to go ahead and use an events variable, and let me go ahead and write graph.stream. And here inside the stream, I'm going to give my messages in this format. This is really important because this messages will follow in this. See, any user message, we need to probably set it up in this way, right? Messages is equal to user input, stream mode values. Okay, stream mode values, and then we are going to probably get our response. So I will go ahead and write for event in events. Let's display the event of messages -1 dot pretty print. We are just trying to print it in a better way. So whenever I give this particular message, you can see by default it is probably going ahead with Wikipedia call. Okay, this should not happen because it is just connecting my name with some famous personality name, so it is probably giving you some information, right? Sangeeta Krish is selected. No worries. I'll just go ahead and write, hey, hi there, my name is John. Let's execute this now. Okay. So query John Wikipedia. See, it is going to probably Wikipedia. So no good Wikipedia search result was found. So it is saying, hey, hello John, it's nice to meet you. Now see, it is for probably going and checking the tool message also, whether I'm going to find this specific message or this particular name over there. So it did not get a good result. Then it is probably interacting with us, saying that hello John, it's nice to meet you. So guys, I hope you like this particular video. This was about building chatbot applications with third-party tools with the help of LangGraph. Just go ahead and try out with multiple tools and see whether it goes to RCF or not. Just keep on adding and keep on asking queries. You should be able to get all the solutions over there. Right? So yes, this was it from my side. I will see you in the next video. Thank you. Hello guys, in this video we are going to create an amazing end-to-end multi-AI agent application using LangGraph and AstraDB. Now if you don't know about LangGraph actually helps you to create AI agents in such a way that you'll be able to manage their state, the communication between the agents. It provides you the entire workflow to probably create this amazing AI applications. So in this video also we are going to probably discuss about an end-to-end project. First of all, we will go ahead and discuss about the architecture, what we are actually trying to implement. And then step by step we'll go ahead and implement this with the help of LangGraph. So here the architecture of the project looks like this. Let's say that I'm trying to create a chatbot application which has this multi-AI agent feature which will be able to communicate with each other and it will be able to do multiple tasks. So whenever a user query comes, there will be a start node in LangGraph, and this start node will further send it to router. Router basically means whenever I'm probably putting up a user query, we need to route it whether this user query can be fulfilled after requesting from a vector database or whether it can be fulfilled from an external tool like Wikisearch. Now here just for an example I'm considering Wikisearch, but in real world application you can even implement different external tools you like, right? So Wikisearch is one. You can also use SERP API, to probably do Google search itself, right? So in this example I'm just going to consider one, and similarly you can implement with respect to other third-party external tools. Then if I probably consider this side, you'll be able to see that it will do a vector DB search. Now this vector DB is basically getting created by AstraDB. We will try to create this entire vector database in the cloud, okay? In the cloud, and initially inside this vector database we will be putting some information. The information will be a website page from which we can specifically query, right? We will take some URLs and we will read the entire data inside that particular website, and we will store that all in the form of vectors in the vector database that is AstraDB, right? And this will be in the cloud platform. Basically, it is deployed in the cloud, and I will try to show you the entire configuration and how powerful and amazing AstraDB is. Okay. After we do this specific thing, then the next step will be that we will get the response from this, and then we can integrate along with LLM, along with some prompt engineering, like what we really want to do with this particular response, and finally we should be able to get our response. And the final node is basically end. So this is the entire architecture of this project in terms of LangGraph. We are going to use the LangGraph. We're going to implement this entire thing, right? So without wasting any time, let's go ahead and implement this entire thing. Okay. So first of all, you really need to know about data stacks. So data stacks actually provides you the access of AstraDB. So in order to access them, you can actually do vector search for real world Gen AI applications, and it is really, really powerful. Okay. And already I've made some videos related to AstraDB in my previous tutorials also. So first of all, just go ahead and sign in. So once you probably sign in, then you will be able to see this specific page. Okay. If you have not signed in, so first of all you need to sign up over there. Here you will be able to probably create databases. Okay. So in order to create the databases, you can actually see over here. I will just go ahead and click on create serverless database. Okay. Now there are two options over here: serverless vector database, serverless non-vector database. But as you all know, we are planning to probably create serverless vector database. Okay, and the reason is very simple: whatever data we have, or whatever data in the form of text we have, we are going to convert that into vector, and we are going to save in this particular vector database itself. So first of all, I'll click this. I will give my vector database name. Let's say this will be test database, right? And here I will go ahead and select any of the region, and let me just go ahead and click on create database. So as soon as I probably create it, it will take some amount of time. So let this get created. Till then, I will just wait probably to create this entire database, and then we will proceed with the next step. So yes, let me just go ahead and click this, and let me start it. Okay, so this is getting created. It is going to take some amount of time. So once it is getting created, I will probably go with the next step. So finally, guys, here you can see that my database has got created. That is text database. Test database. It is a vector database, and please make sure that you keep a note of this database ID because we will be requiring in order to access this database. Then the next step will be that we will go ahead and create our tokens. Now, in order to create a token, first of all, you need to probably select the role that you're probably going ahead with. So I need administrator user. I will just go ahead and click on generate token. Now this token will be important because with the help of this particular token, I will go ahead and access my database, right? So if you also want to know, you can also download this JSON file. So let me just go ahead and click and download the JSON file. Okay. So now I have my access token. Now my database is ready. Now it's time that we go ahead and start our execution of the code. Okay. So before we go ahead, step by step, I will try to show it to you. Till then, just let me hide my face so that you'll be able to clearly see the code itself. Okay. So here I'm going to use Google Colab. So I'll change the runtime. Let me just use any GPU that I want. So I'll just go ahead and click on save. So once I save it, my runtime will be on. Okay. Now what I'm actually going to do, first of all, we will go ahead and install some libraries. So first of all, I require a library like LangChain. Install LangChain. Then we are going to install LangGraph. Then along with this, we are also going to install Cachio. Okay. So this Cachio will be important because I'm going to, this will be helpful for me to initialize the AstraDB database itself, right? So I'll show you, because for initializing Cassandra DB, we require this library. I'll show you as we go ahead, why are we using this, okay? So here you can see the installation has already taken, it has already started, okay? Then the next step after this, so what we are basically going to do is that we are going to import Cachio, and then we will provide the connection of the AstraDB, okay? So in order to connect to the AstraDB, we'll be using this. First of all, the important parameter that I actually require is my AstraDB application underscore token. Okay. Now this particular token, we can get it from over here. So here you can see this token information is basically present. So I'm just going to copy this and I'm going to paste it over here. Okay. So here I'm just going to go ahead and paste it. And with the help of this particular token, we will be able to connect to our AstraDB. Right. Then we're going to probably use our AstraDB ID. Okay. That is our database ID. Okay. So we will be using this. We have created this particular variable. Let me go and see this. So here is my test database and here is my database ID. Okay. So this basically becomes my database ID itself. Right. Now in order to initialize this, I require this two information. So I will go ahead and write Cachio.init, which is nothing but .init, and we'll initialize this particular database. So token is equal to AstraDB application token, and the second parameter will basically be my database ID, which will be equal to AstraDB ID. Okay. So here you can see once I execute this, this will get initialized, and here I've got some warnings, but it's okay. Now we are able to connect to our AstraDB, right? Perfect. Now the next step will be that since we need to develop the LangGraph itself, first of all, I will also install one more very important thing, that is pip install LangChain underscore community. Okay. So let me just go ahead and install this entire application over here. Once this is installed, I still need to install some more things like LangChain Grok, LangChain Hub, LangChain LangGraphs. There's some more libraries that we are just going to install. So for that, I will just go ahead and copy and paste over here, and I'll talk about what all things we are basically going to install. Okay. So here you can see I'll be installing LangChain underscore community. LangChain underscore community, I think it is already been installed. We will be installing TikToken. I'll talk about this. We're going to use open source LLM models. So for that, we're going to use this LangChain Grok. Then you have LangChain Hub, ChromaDB, LangChain LangGraph, LangChain Hugging Face. I will not require ChromaDB because I'm specifically going to use this data stacks DB, right? So LangGraph, LangChain Hugging Face is basically there. So now let me just go ahead and install all these libraries. These are some of the basic requirements that I require in order to start my process. Okay. Now, if you have been seeing my entire LangChain series in this course itself, you'll be able to see that I have already discussed about LangChain. I've discussed about recursive character text splitter. So first of all, what I'm actually going to do is that I'm going to read some kind of websites. From that I will try to read the text data and convert that into vector and store it in a vector database which is present in AstraDB. Okay. So this is basically getting installed. It will take some amount of time. Let's wait till then. Till then I will go ahead and write my other code. So here I'm going to use a text splitter which is called as recursive character text splitter. And since I told you that the data ingestion, I need to read my data from different websites. So I'll be loading LangChain underscore community.document underscore loaders import web-based loader. Okay. Then the URL, which all URLs I'm specifically trying to read. So these are my three URLs that I'm going to use. One is related to agent, one is related to prompt engineering, and one is related to adversarial attack LLM. Okay. Now what we are basically going to do is that we are going to load the URL. So for this, I will go ahead and write docs is equal to web-based loader. I will give my URL.load instead of just using 0. I will use for URL in URLs, and this is basically going to read each and every URL and probably go ahead with the next step. Then I have automatically, this is the amazing thing, Google Colab provides you all the necessary things that is required. Okay. So here I'm going to use a text splitter. Now instead of using every time recursive character text splitter, this time I will show you something in a different way. So I'm going to use something called as from underscore tick token encoder, and here we're going to provide the chunk size of 500. And there will be also a chunk overlap. Let's say that I'm not interested in putting any kind of overlap, so I'll keep it to 0. Okay. So this way we will be able to do the splitting. So one assignment that I really want to give you is that just go ahead and explore about this particular function. Why this function is specifically used. Okay. The answer is given over here only. If you just highlight this text splitter that uses tick token encoder to count length. Okay. So tick token encoder uses encoding name as GPT-2. You can just go ahead and see the definition. There's a slight difference between recursive character text splitter using this tick token encoders. Okay. Then I'm going to probably do the splitting. My document split. I will go ahead and define this variable. And here I'm going to use my document split underscore documents with respect to docs. Okay. Now before I go ahead and probably do this, I will also go ahead and write one more line of code. That is my document list. Here I'm going to consider item for sublist and docs. I'm going to explore each and every docs for item and sublist. Okay. Let me explain about this specific code, what exactly this does. Okay. So here I'm saying, hey, for item in sublist, then we are iterating to sublist in docs, okay, and we're just getting the item, okay. So if you just go ahead and print the document list, you'll be able to see that we'll get all the items that is displayed, okay. So once I go ahead and execute this, you'll be able to see, okay. Let's execute this. It is going to take some amount of time. So here it is giving us an error saying that the list object has no attribute page underscore content. Let me just go ahead and check this out, and let me see what is the error that is probably coming up over here. So okay, it should be documents doc underscore list, okay. So if you want to just go ahead and print this doc list, you'll be able to see what it prints, okay. Okay, again I'll get an error, so it should be doc underscore list. So in doc underscore list, you'll be able to see what item is basically getting displayed, okay. So here is all my information with respect to this, see? And then I'm taking this entire information and splitting it, okay? So this is my entire metadata that I have, right? Then we do the text splitter with respect to chunk size, and then finally we do the split with the help of text underscore splitter, okay? Now, once I have this doc underscore split, so if you go ahead and see this, this is my doc underscore split. Okay. Now, if I just go ahead and display this, this is my entire splits that you'll be able to see, right? Perfect. Now, I need to take this content and convert this into vectors by using some kind of embeddings. So for this, I'm going to use from langchain underscore Hugging Face, okay? Hugging Face, and from the Hugging Face, we are going to import Hugging Face embeddings. Inside this embeddings, I'm going to use Hugging Face embeddings, and we're going to use a free embedding technique that is available as an open source, ALL-mini LM, okay, L6v2, okay. So this name, if you see, this is already available in the Hugging Face. So let's see this, and here you can see it is a sentence transformer, and this basically converts, it maps sentence and paragraphs to a 384 dimensional dense vector, okay. But for this, you also require one very important thing. If I go and click on settings, you'll be requiring a token, right? So this many number of tokens is basically created, right? You can go ahead and create a token because this token will be specifically used over here. Here you can see in the secret key, I've added a token which is called as Hugging Face, right? Hugging Face API token. So it will be asking for this particular token itself, right? So or HF underscore token. This token also you can basically specify. So create a token name, provide a token name, whatever name you want, and you should just provide permissions and go ahead and click create this. For creating, you can see over here. I'll just go ahead and write read, right? Okay, so let's say I want to read. So here I'll just provide my token. Let's say my token name is something like HF token. Okay, I'll go ahead and create a token. Just copy this token over here and paste it. Write this particular key name HF underscore token and paste it over here. I've already done that, so I'm not going to do that. I'll just go ahead and execute this because this is going to ask me the token information over here, and I just need to provide the grant access. So here you can see once this gets executed, my token will be ready. See, it is asking for grant access of HF underscore token, and here you can see it is now able to read the token itself. Okay. Now the next step over here, what we are basically going to do is that we're going to insert all the vectors that we have actually converted by using this embedding technique, okay, into our vector database. So first of all, I will go ahead and write from langchain dot vector stores dot Cassandra. Okay, import Cassandra. Okay, so we are going to import Cassandra, and then we are going to probably create our Astra underscore vector underscore store is equal to Cassandra, and inside this Cassandra we are going to use our embeddings. Embedding is equal to embeddings, and then I have my table underscore name is equal to, let me give a table name like QA mini demo. Okay, I'll just go ahead and write this. I'll keep my session as none. Now what this is basically going to do is that it is just going to insert my data in the database that I've actually given. Okay, so this will basically be none. Okay, so almost done. Any parameters has been left. Okay, I have to remove this bracket. Okay, now this is done over here. So let me just go ahead and execute this. Now this will get connected to my database along with this embeddings. Okay, and the table that I'm actually going to create is this particular table. Now inside this table, I need to just go ahead and store my data, right? So first of all, what I will do is that I will go ahead and import from langchain dot indexes dot vector store. I'm going to import vector store index wrapper, not creator, index wrapper, let's say, because this will be a wrapper on top of the vector store that we have created, Astra vector store. This will be my vector store itself to probably, I can use it to query my vector database. Okay, so let me delete this. Okay, vector store index wrapper. Now I can use this Astra underscore vector underscore store dot add underscore documents. And here I'm going to basically use doc split. Okay, and then I can go ahead and print inserted modulus I headlines. How many records I'm basically inserting? I'm just putting that particular information over here. And here I can use percentile length of the doc split. So this is basically the insertion, how many records has been inserted. Okay, so I'm just going to print this entire thing. Inserted, print, inserted records. Let me just go ahead and see whether I've done any syntax issue over here. Yeah, so docs underscore split. Perfect. Right. So now it is fine. Now I'm going to use this Astra vector d vector index. And after insertion, if I really want to access this, I will be using this vector store index wrapper, and I'll be using this Astra vector store. Okay, so let us go ahead and execute. First of all, it will just go ahead and insert it. Let's see, vector store index wrapper from langchain cannot import the name. The reason is very simple. Here I've made a spelling mistake. Okay, so here also I made a spelling mistake. It should be S capital. So now let's go ahead and execute this. This line of code is basically going to insert all the documents, right? And then on top of this, I am creating a wrapper using vector store index wrapper. Because of this wrapper, you'll be able to interact with the vector database. Okay, so here you have this entire thing. Okay, and now let me show the next step. It is obviously true that you cannot just use directly vector database or this particular variable to access the vector database. Yes, you can use it, but on top of it, we'll try to create it as a retriever. So here I'm going to define my retriever is equal to Astra vector store as retriever. Okay, and then I can go ahead and ask any question that I want. Retriever dot invoke. Let's say I'll go ahead and ask what is agent. Okay, and let me just go ahead and execute it. There's an error, no worries. Okay, what is an agent? And this is my entire answer, right? Building AI agents with this. See, is basically coming from the vector database itself. When I probably use this retriever, right? And retriever is basically created on top of Astra vector store, right? Which is basically referring to my vector database. Perfect. So if I go ahead and see this part, I've actually created it, right? This entire part of Astra DB configuration, inserting the data. And if you also go ahead and see over here, right? Over here, if I just go ahead and execute it, see the amount of data that has been put up, right? So here is my QA mini demo default key space, right? All the data is basically available over here. I'm again reloading it so that you'll be able to see this. If I go ahead and click this, you'll be able to create a collection. You'll be able to see this, all the information over here, right? And this is great. Just now you did a query, and these are all the information that you're able to see. Perfect. Now, the next step, obviously, if this is completed, I need to create Wikisearch. And for creating Wikisearch, I really need to go ahead and probably create and use an external tool that is called as Wikisearch. Okay. Now, before going and creating this Wikisearch tool, what I'm actually going to do is that I'm going to define a router function. Okay. And if you are seeing my LangGraph videos, I think you should be knowing how to probably go ahead and create it. So let's start working on our LangGraph application. So here I'm going to basically write LangGraph application. Here, three important things we are basically going to import. Okay. One is from typing import literal from langchain underscore code prompts, we're going to use chat prompt template, and from langchain underscore code, we're going to use base model and field. This will be important because when we are basically using or creating our route query, we have to inherit this base model. So here, let me just go ahead and create my data model. So here I'm writing class route query base model. Here I've used data source as two important things as a literal, right? One is vector store, one is vector Wikisearch. because this route query class needs to route on any one of them, whether it should go to vector store or Wikisearch. So given a user question, choose to route it to Wikipedia or vector store. Okay, so that is the reason we're basically using this particular route query. So let me just go ahead and execute this, because after this we're also going to create some functions. Now, if you're familiar with already working with ChatGrok and all, so here what I'm actually going to do is that I will go ahead and initialize my use my Grok API. So for Grok, I will just go to grok.com. Okay. Inside this grok.com, you need to sign in, and here you can see that it provides you most of the open source model in the form of APIs, right? You need to use the access token. You should be able to use any of this. Even Llama 3.1 is also available. Okay. So first of all, I click on start building. I will go ahead and see my Grok API. So I will go ahead and create my API token. So here you can see API keys. You can just go ahead and click on API key, give it some name, and you should be able to create it. And once you get the secret key, you need to update this in the secret key. So here you can see I've already updated it in the name of Grok underscore API key, and this is my API key, right? So with the same name, you can go ahead and call it, right? Now, from this Grok, I'm going to use my model that is nothing but Llama 3.170B versatile or 8B instant, any one of them we can specifically use. I will use this, okay? And let's use this. So before using this, first of all, we need to import or get our Grok API. So here, I will go ahead and execute this. Before understanding one thing, that if I really want to access any secret keys from the Google Colab, I need to import from Google Colab, import user data, and then I'm using user data.grok API. So if I just go ahead and print my Grok underscore API underscore key, you should be able to see my API key, right? Grant access. And here you can see. Now, if you go ahead and see the secret key, the same API key it is basically referring to, right? So here is my entire API key that you will be able to see. Then we will go ahead and initialize our LLM model. So for initializing it, I will write LLM chat Grok, okay? And here I'm going to use Grok underscore API underscore key is equal to Grok underscore API underscore key, okay? And second parameter, I need to give my model underscore name. This model underscore name we will go ahead and initialize with Llama 3.1. Let's see whether I should be able to copy this or not. Llama 3.1 70B. Let's say I'll go ahead and write over here Llama 3.1, okay, dash 3.1 dash 3.1 dash 70B, and this is last is versatile. Okay, please make sure that you have the name same, otherwise it will not be able to call. Okay, now if I have this, what I'm going to basically do is that I will just go ahead and use this LLM model. Okay. We'll just go ahead and print this and see whether we are able to call it or not. So here you can see I'm able to call this particular model, which is amazing. Okay. Now one thing that you should know is that our router, this router is really important, because based on a user query, I need to give it to vector store or Wikisearch. Okay. So now what we are basically going to do is that we are going to integrate this route query with our LLM model also. Now how do I do that? So see, at the end of the day, whatever output that I'm actually getting should be in this particular format. So here I'm going to create a variable called as structured LLM underscore router is equal to LLM dot with structured. So there inside the LLM there is something called as with structured output, and I'm going to use my route query over here. Okay, I'm basically going to call my route query class. Okay. Now this is fine, perfect. Now let's go ahead and check whether everything will work or not with respect to our route query. Okay, route query basically means what? Whenever we get any user query, it should be able to tell whether it is a wiki search or vector DB search, right? And for that we have also used one LLM model and we have used one route query inside it, right? So first of all, what I'm actually going to do is that I'm going to use one prompt. Okay, so let's say this is my prompt. In this prompt, I'm writing here, you are an expert at routing a user question to vector store or Wikipedia. The vector store contains document related to agents, prompt engineering, and adversarial attacks. Use the vector store for the question on these topics, otherwise use wiki search. Okay, so that is what we have written over here. Okay, and that is the reason we have used the chat prompt template from message. We have used system because this is the instruction that I need to give to my LLM model. And here we are giving the question as with respect to whatever human question is basically given. Then we will go ahead and create a variable which is called as question router. Here I'm going to use the same route prompt and structured LLM router, because this entire task will be done by an LLM model itself, right? So once I execute this, This is done, right? Now I'll go ahead and write print question underscore router dot invoke. Okay, dot invoke question underscore router dot invoke. Let's test it. Okay, so I'll just go ahead and write a question. Let's say the question is, what is an agent? So if I'm writing what is an agent, obviously my answer should be, it should route it to what? Vector store, because my vector store has already all this particular information. But what if I write a question which looks like this? Who is Shah Rukh Khan? Shah Rukh Khan is a famous actor in India, right? So if I go ahead and execute it, you'll be able to see that it's going to Wikipedia search, because that kind of information is even not present in vector store. So I don't need to probably push this particular query to my vector store. It should probably go to the Wiki search. So this part of vector store I've already created, right? I've created a retriever. Now what is pending is basically for this Wikipedia search, right? Now how do I probably go ahead and create this Wikipedia search? So again, in LangChain, you have this third-party tool in Wikipedia, and for that we need to install this, right? We have something like RSave of Wikipedia, but I'll just go ahead and install Wikipedia, and I'll also install Wikipedia LangChain underscore community. Okay, so here you can see it is already been satisfied, so it is getting downloaded. Okay, that's LangChain underscore community. We have already installed it, I guess. No worries. Okay, now for Wikipedia, I will probably go ahead and import, because here we are working with external tools, right? LangChain underscore community.utilities. I'm going to import Wikipedia wrapper, Wikipedia API wrapper. Now along with this, I'm also going to import from LangChain underscore community.tools import Wikipedia query run, right? We're going to import both this. Now, first of all, I will go ahead and create my API wrapper. And this entire thing will basically be responsible in probably running my entire queries, right? So whenever I give a query, when it is going to the Wikipedia search, this API wrapper will make sure that it will do that. And here I'll just go ahead and define my variable wiki. Okay. Inside this, I can also go ahead and write how many results I want. Let's say if I go ahead and write top A results is equal to 1, and the max to max document content character max, I say that hey, I need 200 characters. Okay. And then I will be able to use this Wikipedia. So once I execute this, you will be able to see that if I go ahead and ask any question, if I go ahead and write wiki dot run. Okay. And let's say if I go ahead and write tell me about Shah Rukh Khan. Okay. So I should be able to get all the response from the Wikipedia itself, right? So all the information is an Indian actor, film producer, works in Indian cinema. The 200 characters you'll be able to see this. So this in short is basically querying the Wikipedia itself, right? Now my turn is basically to create a graph, right? So we will go ahead and create graph, or we'll go ahead and create AI agent application using LangGraph. Because if you understand, from our architecture, we have also developed this. We have also developed router. Now it's like we need to connect this in the form of graph, right? Like how this graph is entirely there. So let's go ahead and do that. So AI agents application using LangGraph. So first of all, I will go ahead and create one class. Let me just go ahead and create one class. So here I have from typing import list, typing extension import type. So I'm going to create a graph state, which will be my class, which is inheriting type dictionary. And this will be in the form of key value pairs. Like question is equal to str, generation is equal to str, and documents list of str. Okay. So I'm basically creating 3 variables. This 3 variables will be responsible in managing the entire state of the AI agents that I've actually created. So it represents the state of a graph, attributes of this many things. Okay. So for right now, just keep a note of that. Okay. You'll be able to understand once we start this. Okay. Now. Let's do one thing. Whenever I ask, or whenever query is basically coming, whenever we give that query to the vector database, then for that particular vector database, what we really need to do is that we need to probably retrieve from the vector database and we need to give the response. Okay. Whenever we get a response, that will basically be stored in this documents. Okay. In this document variable. And whatever question user is basically asking, it will get stored over here. Right. So here I'm going to probably go ahead and create from LangChain. I'm going to import .schema. So .schema. I'm going to import something called as document. Okay. Then I will write definition retrieve. Let's say I'm going to take some state over here. So this state that we have defined, it will be a type of this graph state, which will have this 3 information. Okay. And when we are calling this retrieve, we are just going to give that particular parameter. So here, what we are basically going to do, I will just write down some of the comments so that you'll be able to understand what is happening inside this function. So here you can see state dictionary, the current graph state, and returns a state dictionary itself. Okay. So here, what I'm actually going to write, I'll write print retrieve dash. Okay. I'm just going to write this print, and then let me quickly go ahead and write my question. Question is equal to obviously the question of state, which should be coming from this, because the state, which is a type of graph state, will be keeping the note of the question. So we're going to probably consider the state over here, and then we're going to go to the next line. Here we are specifically going to do the retrieval. For doing the retrieval, I will go ahead and write documents is equal to retriever dot invoke, and here I'm going to use the question. Okay. Now let me just go ahead and return the documents colon documents, whatever documents we are going to specifically get, comma. So this should be my questions over here. Okay. Oops. Questions. Okay. And the second parameter that I'm going to retrieve is basically my question, which will be equal to this particular questions. So this is what we are specifically returning. Okay. And just through this, you'll be able to see this. Okay. So overall, I hope you are able to understand what we are basically doing with this retrieve. Retrieve basically means we are just going to query it from the retriever, and we are going to just display it. Okay. So I hope everybody was able to understand. Okay. There was some indentation issues. No worries. I will just use this. Let's see. It should be fixed. Okay. Perfect. So now it gets executed. So retrieve function is basically done. Now similarly, I will go ahead and do it for the Wikipedia search. So for that, I can just copy and do this. So for Wikipedia search, there will be a functionality where I take the same state. I will write print Wikipedia over here. No need to print hello. I'll take the question. I'll print the question over here. Then we'll go ahead and write wiki.invoke query of question. And then whatever docs I'm actually getting, that is my wiki results. I'll convert that into a document. And I hope I have imported the document also. So this should be imported now, right? And now this finally, I'm probably doing the Wikipedia search and converting into a document and returning back all the results. Okay. So perfect. So what all things have been implemented? We have implemented this functionality. We have implemented this functionality. We have implemented this functionality. Even the LLM part also we have implemented along with the prompt engineering. So in short, why do we say multi-AI agents? Because here they are multi-agents. One is communicating with HRDB, one is retrieving the result from there, one is doing the Wikipedia search, and all of them are interacting with each other. So finally, now it's time that we go ahead and probably do all these things. But one thing that we missed out, right, over here is with respect to the routing functionality, because that routing functionality needs to be also defined as a function, right? So here I will just go ahead and define this. Let's go ahead and do this, and I think you should be able to get this. I'll be getting state of question. I'll say question router.invoke, this one, okay? And where do you get the question router? So question router we have already created it earlier, right? If you remember, we have created over here question router. So we are going to use the question router over here, and here only you'll be able to see that we are just writing this particular question. And I'm saying if source.data source is wiki search, then we return wiki search. Otherwise it is vector store, we return vector store. So all the functionalities, the chunk of functionalities of all the nodes has been created. Okay. Now it's time that we start creating our entire LangGraph flow, right? So I'll write from LangGraph dot graph import end. Then you have the state graph. Then you have the start. Okay, start. Now the first thing is that I'll start my workflow. I will go ahead and write workflow is equal to state graph, and here I'm going to use my graph state, whatever graph state I've actually defined. That is my default class. Okay. Then we will go ahead and define the nodes. What are nodes you have over here? Main important nodes. One is the Wikisearch node and one is the vector DB. Now in order to create the nodes in LangGraph, I will just go ahead and write this one. Workflow.add node Wikisearch. Then you have this retrieve function. What is the function name? You can see over here, retrieve. Okay. So I'll just go ahead and write this name because the spelling is wrong over there. So I'll go ahead and define this. Okay, no worries. So here, one node name is Wikisearch. The functionality is this. Then I have add node. I'm adding retrieve, which is the functionality is this. Okay. This is basically do the web search. That is Wikipedia search. Another one is basically to do the vector search. Okay. Now I'm going to build the entire graph. This is amazing. This is just amazing. Okay. Workflow.add conditional logics. So here I'm also going to go ahead and add conditional logics because this conditional logics will be really important. So sorry, add conditional edges. Okay, should not be logic. So first of all, we start with start. Then we go with our route question, right? So here I'll just go ahead and define my route question. And you know, in route question, what is basically going to happen? It is going to go in this two terms, right? One is Wikisearch colon, and then I have this wiki underscore search. Okay, and the second one is nothing but vector store. The vector store will go to my which node? See, this will basically go to this particular node. This node is defined over here. Vector store should go to my retrieve node. So here I'm going to basically go ahead and define my retrieve node. Done. Now this is my route question. Okay. So start. We have started it over here. We have put a conditional edge saying that when we are routing, whenever this function is written, it should either go to Wikisearch, that is this, or this particular node, that is retrieve. Okay. Then after completing this, what is the next step is that we go ahead and add workflow dot add underscore edge. There's nothing from retrieve. Where do we go after probably if we complete this? Retrieve. Where do we go? See over here. After we do the retrieve is basically done from here. We go to our end stage, right? So end stage will go ahead and connect it. So here I'm going to basically connect my end stage, and then I will also go ahead and write workflow dot add Wikisearch should also be going to the end stage, right? Now finally we do compile this entire graph. So I'll write app is equal to workflow dot compile. Okay, and now this entire compile will happen. Route question is there. Let's see. Okay, I have to give comma over here. Then a little work. Okay, so let me just go ahead and execute this. So route question. Here two options I've given them. Then over here that I have this entire workflow and all the compilation is specifically happening. Now in order to just display this entire graph, I can just use this image and display from IPython display, right? And this is what is the function app.getGraph.draw mermaid png. So this I probably saw from the documentation. So here you can see start, vector store, retrieve, otherwise Wikipedia, and in between there is something called as router also. The router is not getting displayed, but the entire flow will happen in that way. Okay. Now in order to execute and see how things are basically happening, you can actually check this out. Okay, and you will be definitely able to see this. Okay. So I will just go ahead and print one of the code. So here you can see what is the agent I'm asking the input. I can add multiple inputs if I want. So I'll say for output in app.stream input, so key value output items, I'm printing the key. And then we are printing the document of zero.dictionary.metadata.description. It should be able to get the answer. So once I execute this, here you can see building agents with LLM as it is control. So when I ask this question, this is saying, hey, route the question to RAG, that is retrieve. This is the what is I've printed it all there, right? And finally, I'm able to call this node retrieve function. And finally, I'm getting output. Similarly, if I go ahead and ask some other question, let's say I ask a basic questions like Avengers or something, some movies, right? Here my question is Avengers. And if I just go ahead and print the same documents, you should be able to see now it is routing to Wikipedia search, right? So this was about this amazing end-to-end LangGraph applications, basically multi-AI agents where we have added conditional edges. We have seen how each and every node functionalities will be created and many more things. So I hope you like this particular video. Definitely go ahead and check it out with respect to AstraDB because this was quite amazing. Because of this, we're able to do this also, and the vector database search that we're able to do with the help of retriever was possible. And again, here we have used Grok, and the entire application has been basically created, right? So this was it from my side. I hope you like this particular video. I'll see you on the next video. Thank you.